Hey everyone, welcome back. Oh wait, this is the first video. Hey everyone, it's Caleb from Caleb the Video Maker 2. This video is your very first video on C programming. Now before we dive into the depths of C programming, I'd like to give a quick shout out to our sponsor, Onyx, who is going to continually broadcast his message of water drinking. He's doing it right now. Did you hear that? And now that we are done with that glorious introduction, let's get started. C is an example of a programming language. In order for us to fully grasp what a programming language is, we need to understand a couple things. First, as humans, we want to communicate with computers. The problem is that a computer, it only understands what's called machine code, which is basically sequences of ones and zeros. We could communicate to a computer using machine code, but we're going to have long, huge sequences of ones and zeros, and it's going to be very error prone. Because it's so complicated writing in machine code, smart people invented programming languages that allow us to communicate to the computer without having to type something like this. A programming language is readable to a human once you learn that language, and it's not nearly as complex as something like this. So us humans, we learn the programming language, and then the programming language converts whatever we put into that into machine code. You can think of the machine code as individual commands that we tell the computer's processor. So inside of the computer, there's this little processor, and all of these ones and zeros translate into commands for this processor. Programming languages make it easier for humans to tell computers what to do. So everything on the computer, whether it be Windows or Mac, or applications such as Google Chrome or any other kind of applications, they're all built or created with some kind of programming language. One of the first and most popular programming languages, even today, is the C programming language. Now, if all this illustration is too complex, I can make it simpler. Here's the computer, here's us, and we can tell the computer what to do using the C programming language. What the computer does with the C programming language, when we're starting out, we don't really care about all that. All we care about is the fact that we can tell the computer what to do. That means we don't even have to worry about all that machine code and all that stuff. You could say that stuff is abstracted away. When something is abstracted away, it means it's hidden from us. Sort of how when you drive a car, you don't need to know how the car is built or how everything works. All you need to know is how to use the car. Same with communicating with computers. We don't need to know all the intricate details right yet. All we need to know is C programming or some other kind of programming language. As you can see, I wrote this up on the board, but don't worry about what it says for right now. All we need to know is that this is something we will learn to type. This is a language we are going to learn to speak. And all we have to do this is open a text document and type it out. It's very simple. Well, all of this stuff in here, this is known as code. Or some people would call it source code. After we type out our source code, we have to compile that source code. Once we take the source code and compile it, the output is an executable program. This program is something that the computer can understand. In this series, we are going to learn how to write all of the code, how to compile it, and how to make all kinds of super cool programs that can do all kinds of fascinating things. By the way, another name for a program would be software, or an app or application. All of this is the foundation for software development, engineering, app development, all of that. Additionally, this is one topic inside of a subject known as computer science. And computer science is really the study of everything that we can do with stuff like this. By the end of this series, not only do I want you to know how to program in C, I want you to have a general understanding of computer science so that the knowledge learned here can flow into other programming languages and other areas of your life. This may all seem kind of overwhelming at first if you're a beginner. If that's the case, don't worry about it. In the next video, we are going to create our first program, and then we are going to run that program, and it'll do something fancy on our computer. At that point, you'll probably understand all of this. And when you get to the point of running your first application, it's a very satisfying feeling. So stick with it, guys. Don't quit. This is going to be a ton of fun. And by the end of the series, we are going to learn a lot of information. That is all for the introduction, but there's a couple other things that I wanted to mention. The first thing is that I took all the notes that I created to plan out this series and compiled it into one document, and that is downloadable on my website. I will put the link at the end of this video, and also check the description. The second thing is that if you want to support me and my channel, I really appreciate when you click like on the videos and ultimately subscribe to this channel. When you subscribe, you'll get notified of future videos, and that way it's easier for me to communicate with you and tell you that I have new content for you to consume. Hopefully by the end of this series you see the joy and excitement that you can find in computer science and programming, and hopefully you can write some cool apps in C. If you don't believe me that this stuff's fun, well, wait to the end and you'll just have to see for yourself. Alright guys, see you in the next one. Hey everyone, welcome back. It's Caleb from Caleb the Video Maker 2. This is your second video in your C programming tutorial series. Now, at the end of the last video, I said we were going to start programming in this video. I may have lied just a little bit. That's because I forgot we had to set up our environment. So the environment is the computer we're working on that has all of the tools we are going to need installed and ready to go. So, the first thing we're going to need is an operating system. Now, if you don't know what an operating system is, it's just the software that runs on every computer. You either have, a Windows operating system such as Windows 10 or Windows 7, or if you're fortunate enough, Windows 8. Or you might have Mac. And in general, you can classify operating systems into two groups. The first one is Windows-based operating systems, and the second group is Unix and Linux operating systems. Now, Mac would be part of that second group. It's a Unix-based operating system. And I know you're probably wondering, why am I getting into all this stuff right now? Well, the reason is because Windows is a little bit different, and I would highly recommend to have a Unix or Linux operating system. You can try to do it on Windows. It might work just fine, but you might have to look up a couple things and do things a little bit differently. So to make things easier for you, I think we should all be on Linux or Unix operating systems. So what are some good examples of that? Well, if you have an Apple computer, you're set. You have what you need. If you have a Windows computer, don't give up hope. Don't go buy a Mac right now. I don't want you to be in debt for the rest of your life. There is a tool called VirtualBox, which will allow you to install operating systems inside of other operating systems. Then you can install Ubuntu, which is completely free, and that will allow you to follow everything in this video basically exactly the same. As for how to do all that, I recommend just looking up a tutorial. There's probably 1,000 on the internet. Once you got all that done, we're going to need to open a terminal. So on Mac, go up here and type in terminal. Ooh, it's green. It's pretty. Once you're on the terminal, you can change a couple things. First, you can zoom in by holding Command, or if you're on Linux, you can hold Control and pressing the plus button. You can also click Terminal and go to Preferences, and you can change all kinds of goodies and all that stuff. I think the classic neon green is perfect for me. So to begin, we are going to need a compiler. Now, remember from the previous video, the compiler takes our C code and turns it into something the computer can use. So the compiler we are going to use is called GCC. GCC is very common and it's probably installed on most, if not all, Unix operating systems, and it's very easy to install on Mac. All you gotta do is type GCC and press enter. Now, I already have it installed, so it didn't do anything fancy, but if you don't have it installed, it's probably going to ask you if you want to install some kind of developer tools and infect your computer with a bunch of viruses. Just be sure to click yes. I'm kidding, no viruses. Be sure to click install, and once that's done, you'll get to this point, and when you type in GCC, it'll complain because you're not telling it what file you want to compile. In addition to GCC, we are also going to need a text editor. Now, the text editor is where we type in our C code. And just like how I said GCC is common on a ton of computers, there is a text editor that is very common on a lot of computers. That text editor is called Vim. Now, 50% of you are probably going to be like, oh, Vim. 25% are probably going to be like, yeah! And then the other 25 are going to be like, I have no idea what Vim is. It takes a while to get used to Vim, so a lot of people dislike it, but once you figure it out, it's very useful because it's available on so many different computers. So no matter what, you can use this text editor to edit files. even if you're connecting to a computer remotely through the console or the shell or whatever the heck you want to call this thing, the terminal. But I'm getting off topic. It doesn't really matter if you want to use Vim or not, because I'm going to use Vim, and if you want to use something else, that's totally cool with me. I don't care. So let's type Vim and then put a space, and then what comes after that is the name of the file you want to create. So we will just say hello.c and press enter. Now Vim is open. Anywhere there is a tilde, it means there's no line there. This first line is where we're typing. And down at the bottom, you can see the name of the file, and you can also see that it's a new file. Now, like I said, Vim frustrates a lot of people. And part of the reason is, how in the world are you supposed to get out of this program? Well, I'm going to teach you the trick on how to escape Vim. One of the most useful pieces of information to know in life. The trick is to put :Q and then press enter. Now we're back to the terminal. That is a pretty good introduction. We got our environment ready to go, and we're ready to start coding. So in the next video, we're going to write and execute our very first program. So be sure to subscribe if you like these videos, and I will see you then. Hey everyone, it's Caleb from Caleb the Video Maker 2. In this video, we are going to write our first computer program. Ooh, magic. Not really, it's just programming. So one tip is, if you are in the shell here and you just want to get rid of all this crap, there is a keyword you can use, and that keyword or command is clear. Voila. Now we are going to create a new file, and we're going to call it hello.c. Now this .c here is how we say this is a C file. Kind of like how when you have a text file, you put .text, or you'll see .txt somewhere. Exactly the same way. So let's press enter. So when you open this and you start typing, you know, like, oh, it's not doing, and then it finally starts working. Well, the reason it's kind of a pain in the butt like that is because Vim has different modes, and one of those modes is insert mode. As you can see, we are currently in insert mode. So to get out of insert mode, you press the escape key. To get back into insert mode, you press I. So whenever you want to type, all you have to do is first press I and then type. So let's just type some stuff in here. I meant to say Caleb, but I wrote stuff. To kind of walk around like this, you can just use your arrow keys while you are in insert mode. In some upcoming videos, I'll teach you some more tricks and some fancy ways to kind of move your cursor around. That'll be coming up in just a couple videos. Okay, let's delete everything. Now, since this is your first program, you might just kind of have to copy and put exactly what I put, but I will try to explain it the best I can. In the next video and the video after that, I'm going to be explaining this stuff in more detail. So first we need to go into insert mode, and you want to type include, and then you put stdio.h. So the very first symbol you have to put is the pound symbol, and then you put include, then you put a less than sign, standard io.h, greater than sign. Then enter to go down 2 lines, and you can put int main, parentheses, next line, curly brace, end curly brace. So this is where the bulk of our code is going to go. Like I said, you'll understand all this formatting within a couple videos, but for now, just get into the habit of typing it just like that. Inside of here, what you want to do is say print f, and then you use parentheses and put a semicolon. That is how you do a statement in C. This is basically saying to the computer, hey, I want you to do something, specifically print something. These parentheses, we put some data inside of that. So hover over it and put 2 double quotes. Back up a space, and now what we are going to put is hello world, exclamation mark. To indent, you can use the tab key, and then what you need to say is return 0, semicolon. So if you are completely new to using the terminal, you'll notice that the cursor is actually a huge box. So sometimes it's a little less clear as to where you are typing. So if you are like here, for example, and you start typing, it's going to put the characters right before the R. So if you need to visualize a thin line, it would be the left side of the box that is blinking. So that is where our cursor is. One other thing I wanted to add was in this printf statement at the very end, inside of the double quotes, I wanted to put a \n, and you will understand what that does pretty soon here. So we've written our program. Now I want to compile it and run it. So to get out of insert mode again, you press escape, and then we need to save it and escape out of the entire program. So to save it, you can use :W, and then to quit, you can put a Q. So you just type all that at once. You just put :WQ and press enter, and it brings you back to the terminal. To compile this, we use GCC, which is the compiler we downloaded in the previous video. Hello.c, and press enter. And you can see that it didn't do anything. That's actually a good thing. When you get no response, that means the compilation was a success. If you did something wrong, you're going to get some errors. Now, when you compile a file, it creates a new file that we can run. To run that file, what we do is we type :a.out. It's kind of weird, I know, but trust me, you get so used to it, you can type this stuff without even looking. Then we can press enter. And you can see that it outputs hello world. Isn't that cool? We got to tell the computer something to do, and it did it. Now let's go back, look at our code, and try to explain a couple more things. So to go back into our code, we open Vim again. The first thing is this main here. Well, this is called a function, and we'll explain that in a ton of detail in the next video. But this gets ran when we execute the program that is compiled. So when we put :a.out, this function gets ran. And inside of this function, we are saying, hey, we want to print this thing right here. This \n is called a new line character. And it says, hey, after you're done printing this, go down to the next line. The return 0 is just saying, hey, we're done with the program and everything went well. So we can end it right here. So let's go back to the terminal and I'll show you the output one more time. :Q, you can see up here it says hello world, and then it goes down to the next line. That's because we did that \n. Now, if you're not so lucky, you'll have some problems with your code, and the first time compiling, it's not going to work. But don't freak out, don't worry, just always try again. And just remember, if at first you don't succeed, don't try skydiving. To illustrate compilation errors, let me go change some of my code. Let's just go in here and, just bleh. Write it, quit. And then we need to compile again. So to compile, we do GCC hello.c. Oh, there you can see, we broke junk. So this is an example of an error, and I'm sure you will see thousands, if not millions of more of these. It's very helpful to practice reading these because they actually might be able to help you figure out what's wrong with your code. But for now, that's all I got to say in this video. If you've enjoyed it, please click like and subscribe. In the next video, we are going to explain in much more detail all of the pieces of this code we have right here. So that's going to be really good if you're a beginner or you're just starting out. So be sure to go check that out. Thanks, guys, and I'll see you then. Welcome back, everyone. It is Caleb from Caleb the Video Maker 2. And I'm assuming from the last video, you got your first program running. That was the goal. If you've had some experience and you are familiar with some of the things in the previous video, that's okay. But I am going to teach as if you don't know anything. So the program we wrote had a lot of commands and keywords and all these fancy things in there. And the chances are, at first, you're just going to have to memorize how to type this stuff out. Don't obsess over it though. Don't feel like you have to commit how to write every single thing down with your eyes closed. Just know that at first, you're going to have to do some things you might not understand at a deep level as to understand why you are doing things. But by the end of the series, my goal is for you to be able to look at every single thing we just did in the previous video and a lot of the upcoming videos. And I want you to be able to explain what every single thing is, why you're doing it, and what is the benefit of doing that in scope of the entire program. In the previous video, we wrote our first program and executed it. If you had to see visually how difficult that might be, it might look something like this. This is called a learning curve. It takes at least this much knowledge to fully grasp everything we did in the previous video. But you can't get all of this knowledge at 1 second. So we have to build our way up to that point. So starting in this video, we are going to start with the very basic concept of how a C program works. Now, I'm not talking how to compile it and how it runs and how the computer can understand that. That's basic junk. We've talked about that in video number 1, like forever ago. This is talking about how our code means something and how we can communicate what we want to tell the computer in C. So if you don't know what I'm talking about, just keep watching. When you are working with computers, you have to know they are very, very dumb. So you have to break things down and be so super specific with what you want it to do. So let's pretend that you have the intelligence of a computer and I am going to tell you what to do. And the thing I want to tell you to do is to like this video. And no, that is not a subliminal message, but you should like this video. So how do you like this video? Well, to put it very super specific, you have to first move your hand to the mouse. Then you have to grab the mouse. Then you position the mouse till the cursor is on top of the like button on the screen, and then you click the left mouse button. The whole concept of explaining everything step by step is known as an algorithm. Everything we want a computer to do, we should first express it as an algorithm in English. Then it's easier to convert our algorithm that's in English to C. And you'll see that in action as we progress in this series. Now, what if I wanted to teach you an algorithm to like any video on my entire channel? We're going to have to modify that algorithm a little bit, and I'm actually going to write it out so you can see each step. And voila! This is an algorithm where you can plug in any video that I have. So I can just put the title of the video there, and this will teach you how to click like on that video. Not only do computers need very specific instructions, they also don't really remember how to do things. So if I wanted to tell you to like another video, I would have to repeat all 6 of these instructions. So you would essentially have 12 instructions now, just to like 2 videos. Well, wouldn't it be cool if we could somehow kind of teach the computer how to like a video without having to repeat these 6 instructions? What if we could just say like video and then say what video we wanted the computer to like? Well, we could actually do that, and that introduces something called a function. So a function is basically a group of all these dang it, oh, my chalk exploded. So a function is basically a group of statements that you can just shrink down into one statement. So it's kind of how a computer learns, if you want to think about it in human terms. So let's call this entire function like video. When you tell someone to like this video or tell the computer to like a video, you are calling that function. So what that means is we could open this and say something like, yeah, and once again, don't get caught up if you don't understand everything. But what this is saying is that we are expecting a video title to put right here. Now to call this function elsewhere, let's just kind of move this aside. All we have to do is do this. Yeah, I don't have a whole lot of room here, so I kind of crunched it in here. But essentially all we have to do is say the function name, or just the general command, like video, and say what video we want to like. The reason I'm explaining this all is because in programming, we like to break out sections of our code into repeatable sections. So essentially we get like a toolbox of commands we can tell the computer. When we do functions like this, things become more modular. We have these modules we can kind of piece together to make applications. Now, what if I wanted to expand on this and say, hey, you, once you like the video, I want you to tell me how many people have liked that video. Well, that is the concept of a return. So I want you to return to me the like count. So every function can have a return. And inside of a function, it would just look something like this. Return something, and then we could just end the statement with a semicolon. So in the last video, our program started with something like this. And then inside of this, at the very end, we had a return 0. If you're wondering what the return is returning to, like who is getting this 0? Where's it going? Well, we can actually have programs that call our program. So it's like a chain of programs. And the 0 just signifies that everything was okay. Even in other programming languages, a lot of them start with main. And that is just the entry of our program. It's where we start. we always start right here on the first line of the main function. So that is your first piece to understanding why we typed out what we typed out in the previous video. You always want to start your program with a main function, and at the end you want to return 0. And this int here, if you're wondering, we'll get into this later, but int is the data type of 0. So don't worry about that for now. All right. Thanks guys for watching. As always, be sure to subscribe. Don't forget there's notes you can download, and also you can see the next video. I don't know if I pointed the right way, but somewhere on the screen there's some clicky buttons. Thanks guys, bye. Welcome back everyone, it is Caleb from Caleb the Video Maker 2. This video is part 2 of how C programs work. So the only real purpose of this video is to break down what we discussed in our Hello World program 2 videos ago. So that program looked like this. The first thing that you need to notice is right here. This is a function definition. Whenever we define functions, it's going to have a very similar look to this. So it's best to familiarize yourself with it right now, because long down the road in this video, we're going to create some of our own functions. For now, we do not have to worry about that. All you have to know is that the main is a function, and inside of that function is the stuff we want to do. So once again, as a reminder, what is a function? You can think of a function as just a name for an algorithm. Now the name main doesn't have a lot of meaning, but by convention, this is the function that is called when we first run our program. Main is called when the program runs. It's the first function that is executed in our program. Now this thing here is called the identifier. That is a general term to mean the name of something. So in this case, the identifier of this function is main. Identifier is a very computer science-y term, so be sure to throw that in your sentences if you want to impress the ladies. Or turn them away, because you know that happens too with computer science. That made no sense at all. Inside of our function, we have each thing we want to do. The first thing we want to do is print something, and then the next thing we want to do is return something. We discussed what the return means in the previous video. Both of these are examples of statements. And you can clearly see that they're statements because they both have semicolons. You can think of statements as commands. The 0 here says that the program worked as expected. We could, if we wanted, return some other value. For example, we could return a -1, and we could make that mean, you know, things didn't go so good. But in this situation, there's no reason why we should return anything other than a 0. Up here, we have what's known as the data type of 0. And we'll get into data types later. But just think back to math class. Integers are whole numbers. 0, it's a whole number. So we're just saying, hey, we're going to return some integer. That's all that says. This line right here is actually another function call. That means somewhere there is a function called printf that was defined. So let's just say we have this file over here, and inside of that file we have printf, and then the algorithm of how printf works. Here we are calling that function, so we're just saying, hey, we want to use this code over here inside of our program. Where is this code located though? Well, it actually comes from some library, and that library is denoted right here. So you can see here we have standard IO. And inside of this library, one of the functions that is available to us is the printf function. And I can assure you it's going to look more complicated than this. But thankfully, we don't have to write that function. That function was made available to us. All we had to do was include the library in our code to make it accessible to us. If we didn't put this here, and we tried to compile this code right here, the compiler is going to be like, dude, what is this? What? This isn't a real thing. There is no such printf function you speak of. So that's why it's always important to make sure you use the include. Last thing I have to say is this little \n. This little weird thing right here. This is called the new line character. Whenever we use this \n, we are saying we want the console to go down to the next line. So what this is going to do is it's going to print exactly what we have. And then when the console tries to print this \n, what happens is it goes down to the next line. And then this is where the cursor is now. And then that's the end of our program because we return 0. So the program is going to end on a new line. That's all I got to say on how a C program works. As you can see, there's a lot of information that's kind of crammed in this video and the previous video. And the next whole series is going to be devoted to breaking down each one of those things in depth and learn some more features and more functionality. So by the end of the series, you can write this with your eyes closed and much more. So thanks guys for watching. Be sure to check out the next video, click subscribe, and as always, be sure to like this video. And yeah, that's about it. So thanks, and I'll see you in the next one. Peace. Hey everyone, welcome back to your C programming tutorial series. Now, before we go into more C programming, I wanted to take a break to learn some of the basic Unix and Linux commands. So when you are working with a Unix or Linux operating system, there are a ton of built-in commands that you're going to need to know. The reason I think this is so important is because one of the reasons C became so popular is because it was the standard programming language when Unix and Linux gained popularity. So there is like this special connection between C and the Unix Linux environments. Now if you're on Mac or something like Ubuntu, all of these commands are going to be exactly the same. Now the actual difference between Unix and Linux, that's not so important for right now. All you really need to know is that Linux is a Unix-like operating system. So these are actually very similar. Because these are so similar, oftentimes people will just use the terms interchangeably. That's because if you want to teach these commands that apply to both of these, you don't always want to say Unix/Linux. So if I just say Linux, just assume I'm also talking about Unix, which includes Mac operating systems like OS X. So let's get started. One of the biggest things Linux is known for is the terminal. When it comes to Windows, no one really uses the command prompt unless they're super techie and they need to do something on there. But when we're talking about Linux, even the average user knows some commands in the terminal. And because Linux is so popular, I guarantee you are going to need to know some of these commands. The first type of commands you should learn how to do are the commands that do the basic things like working with the operating system, moving files, copying files, all of the stuff you can normally do with a mouse, but you want to do it all in text. I know, it sounds fun, but it actually is kind of cool. Just like you can do a lot of things visually with a mouse, you can do a lot of the same things with commands. For example, you can navigate folders, you can rename things, all of that good stuff. So the first command I'm going to teach you is called pwd. What this command does is it prints the current directory, or the working directory, which is why it's pwd. And you can see I'm in users/CalebCurry/YouTube. This is basically the location that I'm in the terminal. To see all of the files and folders in this folder, you can type ls. And you can see nothing showed up. That's because there actually isn't anything in this folder. Now, I should probably start using a more technical term, directory. That is what folders used to be called before the term folder came into existence. So folder and directory, that's the same exact thing. Now, let's say I want to move to this Caleb Curry folder. I can do this by typing cd ... Now, when I type in ls, you can see there's all kinds of stuff. We can actually ask for more specific information by doing things such as ls -l. This gives much more information. You can see this gives the file permissions, the dates, all kinds of good stuff. So I can just press up and ls-l shows up. This -l right here, this is known as a flag. We can pass flags to these commands to alter the output. Another common command is ls-a. The first command, ls-l, what it does is it lists the long version of what we are trying to accomplish. The ls-a lists all the files, including ones with the little periods, which are hidden files. If you want to send more than one flag, you can combine them in one, like this, ls-la. This is saying list the long version and list all the files. If we want to navigate into one of these folders, all we got to do is figure out the name. For example, let's say I want to go into this YouTube folder. All we have to do is say cd for change directory and then type in the name of that folder. And now when we say pwd print working directory, you can see we're in that YouTube folder again. One more thing about the ls command is that there's two special ones in this list. If we scroll up, there is a dot and a dot dot. The single dot is a reference to the directory that is being listed right here. So the Caleb Curry folder. The dot dot is the parent directory, which in this case, if we scroll down and go back to our pwd command, you can see that that would be the users folder. When we are typing in the cd command, there's two types of paths we can give. There's one called an absolute path, and there's another called a relative path. So I'm going to show you how to do both of those. The absolute path is from the very beginning. So you say cd /, which means from the very beginning. So we are starting right here. Then we can put any folder we want. Users / Caleb Curry. Enter. And you can see that works just fine. We say pwd and we're in that folder. The other one is a relative path, which we actually showed earlier. That's changing the directory relative to where you are. So if you do cd ... the parent is relative to what folder you're in. What I mean by that is if you look up here, the parent of the YouTube folder is Caleb Curry, but the parent of Caleb Curry is users. So what folder you go to depends on the folder you're currently in. That is how a relative path works. And now you can see that we are in just users. So that is kind of like your head first dive into Linux commands. Hopefully I didn't overwhelm you with too much information. I would recommend just writing down each of the commands, or you can download the notes that I have on my website. I will have a link at the end of the video, and that'll just have them all there for you. So thanks guys for watching. In the next video, I hope to teach you some more Linux commands, so be sure to check that out. Peace. Hey, welcome back everyone to your C programming tutorial series. This video we are going to continue our discussion on Linux commands. So make sure you watch the previous video because that kind of laid the foundation of how Linux works and why we are talking about Linux when this is supposed to be a C programming tutorial series. So let's just get started, no more wasting time. One thing I would like to share with you is that you can imagine the Linux filing system as a tree. Now, I wish I could draw this for you, but I'm limited to just this computer screen. But when you run pwd, you get the absolute path of where you are. You can think of the /users as a branch to this tree. This brings up many important terms relating to paths that you should know. The first one is root directory. When someone says root directory, they are referring to the very first directory. To get to the very first directory, all you have to do is say cd /. And now when we say pwd, you can see we are at the very beginning. Another important directory is called the home directory. Now to get to the home directory, all you have to do is type cd. Very simple. Press enter, and then pwd. You can see that we are in users / Caleb Curry. So Caleb Curry is my home directory. If you are a very visual learner, it might help you to open a Finder or a window or whatever you want to call it. This is the home directory. Next, we can travel to the users directory. And then inside of the users directory, we can travel to our home directory. This is the folder that we are currently in inside of the terminal. So let's get rid of that. There is also a way you can refer to the home directory, and that is using the tilde. So for example, we could say change directory tilde, and that'll do the same exact thing. The benefit of this though, over just using cd, is that we can reference stuff from the home directory. So for example, if we list our directory, we can see there's this YouTube folder. So I could go into that folder by doing something like cd /YouTube. And now we are in the YouTube folder. This is a good example of a relative path. We don't really care where the home directory is. We're not starting from the very beginning by starting with the / and then putting users and then blah, blah, blah. We're just saying, hey, let's go from the home directory and then travel into the YouTube folder. We can actually do some more complex things. For example, we can use relative paths to list certain folders. So for example, if I wanted to see what was inside of the parent folder, all I'd have to do is say ls ... And you can see it lists all of the stuff inside of, if we pwd, inside of Caleb Curry. We could even do ls ... And what this does is actually lists everything in the users folder. These are things you're not going to really have to use that often, but it's useful to know that you can do that. If I wanted to, for example, go into this shared folder, what I could do is first compare it to where we are currently at. We are in YouTube. So we need to go up a parent, and then down into the shared folder. So we could say cd ... // shared. Print working directory, and you can see we are now in the shared folder. That's pretty cool. I think that's enough about listing directories and moving around in the file system. Now I want to talk about creating files. First, I want to go to the Caleb Curry /YouTube folder. So to do that, all we got to do is say cd home /YouTube. And now let's create a file using the touch command. So anything that comes after the touch is the file name that we want to create. So we could say filename.c. Now, when we list the files, you can see we have the filename.c right here. Now that we have a file, let's talk about how to move this file around. Let's say I wanted to move this file up into the Caleb Curry folder. Currently, it is in YouTube, and I want to put it into Caleb Curry. The command to do that is mv, and then you say the name, and then you say where you want to put it. So we want to put it in the parent. Enter. Now let's view the files in the parent. To do that, we can say ls ... And let's look for it. Filename.c right there. Oh yeah. Now this part's kind of odd, but you can actually rename files using the move command. Because if you think about it, we could move this file to the same location with a new name. That's kind of how I like to think about it, or how I grasp that concept. So let's try that. First, let's move it back into the YouTube folder. So let's move filename.c into the current directory. But this is actually not going to work because the filename.c, that'll be searched for in the current directory. So we need to go up to the parent because we're currently in the YouTube folder. So we are here. The file name is inside of Caleb Curry. So we need to go up to the parent and then grab filename.c. Then we need to say where we're going to move that, which is the current directory, which is YouTube. So right here. Hopefully that's clear as mud. Okay, let's run this. And now when we say ls, you can see the only file inside of YouTube is filename.c. Now to rename this file, all we have to do is say move filename.c, so the original file name, and then space, and then the new file name, new.c. Then when we list the files, you can see that the file name is no longer there, and it's replaced with new.c. Lastly, let's get rid of this useless file using the rm, or remove command. And there you go, it is now gone. Don't feel like you have to have all of this memorized by the end of this video. Like, really, this takes a lot of practice. The next video is going to be the last video on Linux, and then we're going to get back into C programming. So thanks for watching, be sure to subscribe, and I will catch you then. Peace. Hey everyone, welcome back. This is going to be the last Linux tutorial inside of this C programming series. So if you're sick of Linux, don't worry, it's almost over. The very first thing I wanted to teach you how to do in this video was how to create your own directories. So if we do print working directory, you can see we are in the YouTube directory. And if we say ls, you can see that there's absolutely nothing in this directory. Well, I'm going to teach you how to put a directory into the working directory. So the way to do that is mkdir, which stands for make directory, and then you give it a name. Now when we say ls, you can see that there is a folder or directory inside of the current directory, or the working directory. We can go into that directory by using cd test. And now when we say pwd, you can see that we're in that directory. Let's go out of that cd ... That goes to the parent. And now I want to talk about auto-completion, because this is going to be one of the most helpful things, I promise. So to explain auto-completion, I am going to make a couple directories. Make dir. So every single space is a new directory. So I'm making 2 directories here, pumpernickel and kombucha. Now, when you type cd p and then press tab, it'll automatically fill out pumpernickel for you. It's awesome. I want to show this a little bit more, so let's make another directory. We're going to make a directory called plump. Now if you type cd pl, well, there's only one directory that will match this, and that's plump. So it's going to work. When I press tab, boom, there you go. The problem comes up when you don't type in enough characters to make it unique. So for example, if I delete down to the P and press tab, nothing happens. If I press tab again, it'll list all of the options that match that. And now we have to pick which one we would like. So I could add U and then press tab and goes to pumpernickel. Onyx, would you quit your drinking? Okay, I'm sick of your subliminal advertising. Just because you're my sponsor doesn't mean you can interrupt every single video. He obviously doesn't care. That's it for auto-completion. It's going to be super helpful once you have thousands of files and you just need to type things real super quick. The next command I wanted to teach you is called the echo command. So it's really simple. All it does is take whatever you give it and it will spit it back out in the console. So we could say echo, and then in double quotes we could say something like, hello world. Then when we press enter, it just spits it back out to us. And you're probably thinking, wow, that's completely useless. Well, we can actually do some pretty cool things with this. For example, we could do something like this. And now we can use a greater than sign to output that to a file called output. Now when we say ls, you can see that there is a file output. How do we see the contents of that file? We get to use a new command called cat. So we can say cat output, and you can see that the output is in that file. So whenever you need to redirect some text into a file, you can use this command right here. Let's try it again. Echo pizza. And we're going to put that into output. Now when we say cat output, the only thing it outputs is pizza. Where did hello world go? Well, this actually overwrites everything in the file. So you have to be super careful when you do something like this. If you want to append to the end of the file, meaning keep hello world and just add to it, you have to use 2 greater than signs. Just like this. Now, when we say cat output, there's a bunch of garbage in there. That's because I messed it up a couple times, but you guys get the point. Let me try it again without messing it up. We're going to put this into output. And then cat output. And you can see pie is right there, ready to be eaten. Pizza cat, yum. The greater than symbol can actually be used with other commands. For example, I could say ls-la and then output that into some file, let's say ls output. What would that command normally output? It would output this. And if we see what's inside of the file using cat, we could say ls output, and it's the exact same thing. So if you ever need to barf the output of some command into a text file, that is how you can do it. Sometimes when you output a file on the screen like this using cat, there's just going to be way too much text for us to look through. There's actually some commands to help us with that. Just to show that, I'm going to make the text in the file super long by appending this again, and then just running that a couple times. So now, when I say cat ls output, look, it's so much garbage. Holy cow. Like, how am I supposed to read that? Well, the command you want is called less, because we want to see less of the file, you see? Then all we got to do is say the file name, ls output, and it only displays a little bit. Just to make it clear, I'll clear the screen, and then let's do it. ls output. There. And now you can actually scroll using your arrow keys. Pretty sick, I know. The trick is, how do you get out of this trap? That's for you to find out. I'm just kidding. You just have to press Q. And absolutely last thing I gotta tell you is if you're ever in a program that just keeps running and you can't get out of it for some reason, all you gotta do is hold Control and press C. So I know that was a lot for one video, and to be honest, the last couple videos have been a lot of information. So do your best to learn it all, but don't freak out if you don't get it all figured out by the end of the day. It's okay. I will still be here on YouTube to teach you on this video. So thanks guys for watching. If you've enjoyed this video, please be sure to click subscribe. And if you need all of these commands on Note, be sure to download my notes, which I will link at the end of this video. And yeah, that's all. So be sure to subscribe, and I'll see you in the next video. Which, by the way, we are going to be talking about the basics of C. So we're going to start talking about how to actually do things in C programming. Yeah. Welcome back, everyone. This is Caleb from Caleb the Video Maker 2, and this is your C programming tutorial series. Now, we are going to start covering the basics of C. Now, we already did the Hello World program, and I discussed functions and all that good stuff. But now I want to teach you how to learn to write your own programs. So I highly recommend you get the general structure of the Hello World program figured out, almost to the point where you can write it yourself. It's okay if you have to reference some, but you want to understand the general format of how to write a program. I don't think you have to sit there with note cards memorizing every single thing, because honestly, that's going to come with time. Just have a rough idea of where to put what and where semicolons go. In this video, the very first thing I'm going to talk about is spacing. So where do you put spaces in C? So to get started, I'm just going to create a file. We'll just name it subscribe.c. And let's just start with the basic format. So you want to get into the habit of writing this out every time you write a program. Now you can see I put some spaces in here. There's a space here, there's a tab over here, and like, how do you know where you put those things? Well, fortunately for us, C is a space-insensitive language. What that means is we can put space wherever we want. That means I could just the same write this, or like this, or like this, or like this, and it's all going to work exactly the same. Just to prove it, I'm going to exit out of this, and we'll compile this. And you can see there's no compilation errors. Let's go back into our code. And you might be wondering, well, if you don't have to put spaces, why did I choose to put spaces? So let's kind of format this back to how I had it. We can go into insert mode by pressing I. Let me just kind of clean this up, you know. The reason I formatted this is for clarity. I put a distinct separation between the includes and our first function right here. Additionally, inside of these curly braces is a code block, and by convention, we indent everything in this code block. So if I was to add another line in here, I would also indent that, like this. That way there is a clear visual presentation that both of these lines are part of this code block. So now we know how to format things, but how do we actually go about coding things? Well, the very first thing I wanted to introduce to you when it comes to coding is variables. A variable is something that can store some data that can be used later on in our program. So inside of here, we can create a variable by typing int x. Now, the x is just the name of the variable. You can name it whatever you want. That would work just fine. There are some conventions here though. For example, I lowercase the first letter and I uppercased each of the other letters. If you're just doing a single variable like int x, I would leave it lowercase. This statement right here is called a variable declaration. We are saying, hey, there's a variable called x. We are declaring that the variable exists. How exactly though does the variable store a value? You know, like what use is a variable if it doesn't store anything? To give the variable a value, we need the variable initialization. So to do that, all we gotta do is go down to the next line and say x equals 5 or whatever value you want to give it. The only thing is it has to be an integer value because up here we said int. So an integer is a whole number. Think 1, 2, 3, 4, -5, 23, anything without any decimal points. Now, a very important word that you need to know when it comes to computer programming is syntax. Syntax is the form or format, like where do we put semicolons, where do we put equal signs, and where do we put all those other fancy symbols and stuff. All of those rules are called the syntax. and you will become more familiar with the C syntax as you start programming in C. Now that I have this variable x, let's talk about using this variable. First, let me get rid of this garbage. And then up here, we are going to do some math. I know you guys probably love math. Most people do. So we can just create a new variable and say int y equals x divided by 2. Anytime you see an x in our code, like right here, you can think of the value 5 going and replacing that x. So it's 5 divided by 2. So y is going to equal half of 5. So let's go through an example with some simpler math. X equals 10. 10 divided by 2 is obviously 5. So if you were asked, what is the value of y? Well, you could say 5. The value of y is not x divided by 2. It is not that. That's because the value of x is replaced here, and then the division happens, and then it gets assigned to the variable y. So the variable y only contains one thing, and the thing it contains is an integer, as you can see right here. Now you may have noticed that instead of using x here, we could have just put a 10. So I could just put 10 divided by 2, and y would equal the same exact thing. So why would you ever want to use a variable like that? Well, if we are using the variable x, 10 or 20 times in our program, we're not going to want to have to repeat the same value over and over and over again. Instead, we could give x a value like 10, and then just replace those values with the variable. Other times, we might get the value of x from a database or from a user, and we might not know ahead of time, so we can't go in here and type in the value of x, because we don't know the value of x. So it's always best to use variables when either of those situations come up. The last thing I wanted to teach you in this video is the concept of an expression. An expression is anything that can be evaluated, and the result is going to be one value. So down here we have an example of an expression, x divided by 2. That expression evaluates to one value, which is 5. Then we have the value 5 inside of a bigger statement. So to summarize, the keywords we need to know are expression, statement, declaration, and initialization. Up here you can see that we declared the variable, and then we initialized the variable with a value. Down here, we're actually doing both steps in one line. We're declaring the variable y, and then we're giving it some value, 5. In the next video, we are going to be talking about how to get this to print to the console using printf. Hopefully, everything so far makes sense to you guys and that you're keeping up. If you have any questions, please be sure to leave a comment. Either I or some of the other viewers will be able to help you. Thank you, and I'll see you in the next one. Welcome back everyone to your C programming tutorial series. By now, I'm sure you guys are C experts, so I'm going to stop explaining things and just start typing. Kidding, but it seems like that's what a lot of people on YouTube do, and it drives me crazy, so I don't even know what I'm talking about. Let's just get started. This is where we left off in the last video, and I'm just going to clean up some junk, so we don't need any of this junk. And then we are going to condense this down to one line, as we learned we can do. So now we have two variables, and I told you that the value of y is going to be 5. But, I could be deceiving you. How do you know the value of y is 5? Well, this video, I'm going to teach you how to print the value of these variables to the console. Oh, I'm also going to get rid of this crap down here. So let's just try going down here, and let's just print a number, okay? We'll print 9001. And now, let's save the program by hitting escape to get out of insert mode, and then type in :WQ. And we'll compile that gcc subscribe.c. Oh, crap. What is all this? These are compiler errors. The compiler is basically saying, bro, quit being an idiot, make sure your program is correct before you tell me to compile it, and then I'll compile it. Stop being a noob. So let's go back in there and fix our problem. So we'll go back into Vim. And the problem is that we can't just print a number. I know it sounds stupid, but you just can't do it. All right, that's a rule. Just deal with it. So to print a number, you have to type in some extra stuff before the number. So follow me, go into insert mode, and put double quotes and then a comma. So let me get my stupid cursor out of the way. You can see we're passing in a string and then a comma, which says, hey, we're going to give you some extra information. And then we're giving the number. Well, what goes in this string here is what's important. And that is called a format string. This string right here is called a format string. Inside of the format string, we can put format or conversion characters because we need to convert this number into a form that the console allows. So to do that, we have to put %i for integer. So that is how you print a number. We'll hit escape and save the program and exit, and now let's try compiling. Okay, we still have an issue. We got some period or something floating around, so let's go back in there and fix it. And this brings up a good point. This will usually tell you about where it's wrong. So we can look for these lines and columns. So we can go back in Vim, and you can see on line 11, we're currently on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Column 2. There is a period. It's not supposed to be there. So we got that fixed. We can escape and save. And then compile. And now let's output it. And you can see the number outputted right there. But we want it to be on its own line. So to do that, go back into Vim. And after the %i conversion character, go into insert mode and put a \n, which, as you've learned, is the new line character. So that'll put it on its own line. But I don't really want to print out this random number here. I want to print out the variables that we already have created. Because these are technically just variables storing an integer, we can use the value y wherever an integer is expected. And just like this is an integer, we could replace that with y. So let's just go over here and do that. So if we did everything right, this should print out the value 5. So let's save and compile and then run. And you can see the value 5 is right there. Another thing is that anytime you change any of the code, even if it's just something super, super small, you have to recompile using GCC. That's because this a.out is actually a file. If you say ls, you can see that the file exists right here. And when you don't compile, even if you change this file right here, this file stays the same. In order to update this one, you have to compile this one. So anytime you make a change, be sure to compile. The next thing I wanted to do is, rather than just printing out this random number, I wanted it to give some kind of description, like, hey, the magic number is 5, or something like that. So let's figure out how to do that. Let's go back into our code. And we can just add it to our string inside of printf. It's really simple. So literally the value of y is just going to be imputed into this location inside of this string, which is going to be printed. So it's going to say the magic number is :5. And then it's going to go down to the next line. Every time we have something in here separated by a comma, these are known as arguments. So we're passing 2 arguments to the printf function. We can actually pass more arguments. For example, if we wanted to include x in this, we could do that. For example, we could just start typing here, the value of x is %i \n, and pass in another argument of x. The reason this is kind of connected right here is because it looks weird here, but in the console it's going to go down to a new line, and then this is going to be the start of a new line, so it's actually going to look pretty cool. So let's compile and make sure everything looks right. The magic number is 5 and the value of x is 10. Awesome. So we got it working. All of our code is working exactly as expected. So hopefully that's cool and satisfying to you guys. In the next video, we are going to be covering taking input. So I will see you then, guys, and be sure to subscribe. Welcome back, everyone, to your C programming tutorial series. Here, let me just clean that off to make it nice and fresh, okay? So in the last video, we had this code. And this is cool, but you can see we're typing in the values of these variables right here. This is called hard coding. It means, like, once we compile this, the only way to change it is to recompile the program. We have to go in there, edit it, recompile, and then redistribute our new program to all of our customers. That is generally bad. Instead, it would be so much cooler if we could just ask the user, hey, give me a value for X. Make the program a communication between the computer and the person using the final program. That is our goal for today. So we're actually going to create a pretty cool application. The goal of the application is to calculate the area of a circle. So the person's going to run the program, it's going to ask for a radius, and then it'll calculate it and spit back the value to the user. And if you're crappy at geometry, that's okay, I'll teach you how to do everything. So I'm basically going to just slaughter everything we have here, just get rid of it all, but I'll keep some general structure. So first I'm going to get rid of this string because, we're going to change that. But I'm going to keep the new line at the end, and then I'll get rid of the variables. That's kind of like the basic outline of what we're going to fill in with new variables. The next thing is we're going to get rid of these variables and just create new ones. So the very first thing is we are going to create a radius variable. So the radius is the distance from the outside to the center of the circle. That is the thing we are going to get from the user. So how do we get a value from the user? Well, just like there's this printf function, there is a function to scan data from the console. And you guessed it, it's scanf. If I can type, scanf. Now, what do we pass in here? Well, it's actually very similar to printf. The first thing is we need to say the format string. So what is the format of the data? And the format is going to be an integer. Now we don't have to put a new line in here. We only need the new line down here if we want to output that new line. But in here, we're just going to get an integer. And where is that integer going to be stored? Well, it's actually going to be stored inside of the variable radius right here. So this part's kind of weird, and this is one of those things where you might just have to memorize at first until you really understand it, but you actually have to put an ampersand, I think that's how you say it, and then the variable name. For you smarticle pants people out there, this is called the address of operator. And what this does is it allows the scanf function to change the value of this variable we are passing in. If we just, passed in radius like this, it's not going to work. I mean, you can try it, but it's not going to work. So let's make sure we put that back in there before we break things. The reason printf does not need the address of operator when we pass in something in here like x is because the printf function doesn't actually change the variable. All it does is output it. Scanf will change the variable. It gives it a value of what the user inputs. So that is super, 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 super important to remember. So I'm going to get rid of that x for now and go back up here. So let's save this and run it and make sure it works. First thing though is that the printf is not properly formatted, so the compiler is just going to complain. So what I'm going to do is I'm just going to throw in the radius variable here. And then let's escape and save. Oh, okay, so I have an error because I forgot to put the percent sign before the I. So let's go back into our code and let's add that in there real quick. There we go. Okay, I just ran the program and you see it's beeping at me. It's just telling me to type something in. But the thing is, it's not very clear. It doesn't say, "Hey, beautiful, it's nice to see you today. Would you please give me a number?" Yeah, exactly. It doesn't say anything. But if we type a number in here, you can see it outputs it, so the program's working, but it doesn't ask the user. So that is something we want to implement. And generally, when we ask the user to insert some data, that is called a user prompt. P-R-O-M-P-T. And that's just asking the user to do something. We're prompting the user. So let's go back in our code and make things not crappy. So before we scan, we actually want to print to prompt the user. So we want to go into insert mode and say printf, please enter a radius, just like that. And now let's compile using GCC and run it. Please enter a radius, 200. And then it outputs the radius. To make this output a little bit better, we could say, hey, the given radius is 200. So to do that, let's go back into our code. Vim, and just add in here, the given radius is and then when we compile and run it, enter radius 2000. The given radius is 2000. In the next video, we are going to worry about doing all the complicated calculations. I think that was enough for this video. Now you guys understand how to get integer input from the user. And if you go back into our code real quick, I'll show you something cool. This %i, this conversion character, there are actually other conversion characters used to take different types of data. And we'll learn about all of that stuff in the upcoming videos. So thanks for watching, guys, and I'll see you in the next one. Please be sure to subscribe. Welcome back, everyone, to your C programming tutorial series. Now, in the previous video, I talked about how to get input from the user and how to take that and put it on the console. So output that to the console. So you can see here we have a radius, and what we're doing is we are actually taking the radius from the user and then we're printing that radius. But now I want to actually figure out the area of this circle, which is essentially what we're trying to do in this app here. Whenever you want to calculate something, you're going to need a location to store it. Anytime we want to store information in a program, we need some kind of variable. So we are going to create another variable. Where exactly are we going to want to put this variable in our code, though? Do we put it up here? Do we put it in here? Or down here? Well, we actually want it about here. The reason we want it here is because the area is actually going to be calculated from the radius. So the radius needs a value, and the radius doesn't get a value until this line. You could just the same put it right here. It doesn't really matter because this is just a print statement. And in fact, we're not even going to need that print statement anymore because all I want to do is output the area. So let's just get rid of that whole line. Now let's create another variable, int area. So we are going to create a variable to store the calculated area. And how do we get the area? Well, this is where the formula comes in. And the way you calculate the area from a radius is you take pi, which is 3.14159, and you multiply that by radius squared. Well, how do we square something in programming? The easiest way is to just multiply the variable by itself. I mean, isn't that what squaring something means? So if you have radius squared, it's the same thing as radius times radius. So radius times radius. Now, do you guys notice anything wrong with this code? This line of code actually has one problem in it. The problem is that we are making this an integer, and an integer is always a whole number. And almost any time you multiply something by this, you're not going to get a whole number. So this is faulty code. You could consider this a logical error. A logical error is when the code compiles, it works, but the result is not what we are expecting. There is a problem in the code that produces an incorrect result. So to fix this, we are going to need a new data type. Now, a data type is literally just the type of data. Int is an example of a data type, and that stores whole numbers. Well, there's also a data type that can be used to store numbers with decimal places. If we were to just use this integer data type, and we got a value, let's say 76 point whatever, well, this would actually be truncated to an integer, and that means that everything after the decimal point is just deleted. It's not rounded, it's truncated. This is not what we want. So to fix this, we need to use the data type called double. I would say that we are correctly storing the data, but how do we output the data? Well, if you were to just copy that line we had previously, we had something like printf, and then in here we had, quotes and %i inside of them, and then we just passed in that variable, area. Well, this isn't going to work like we were hoping. That's because this %i is specific to printing integers. And we don't want to print an integer anymore. We want to print everything, including what comes after the decimal. The correct conversion character that we are going to use is actually a % and then an F. The reason we are going to use that is because F is short for floating point value. And we'll get into all the data types and fancy words like that, but double is an example of a floating point value, so that works just fine. But we should probably give some more information like, hey, what exactly is this variable? So in here, let's say the area of a circle with %i radius is %f. And then in here, we're going to have to also pass in the radius. Just like that. And then we'll run it. Please enter a radius. 5. 78.4 539750. So hopefully that gives you guys some satisfaction writing your very first program that actually does something kind of cool. You can run this as many times with different values and try all kinds of cool things. So thanks guys for watching. In the next video, we'll be talking about some more of the basics of C programming. So be sure to check it out and click subscribe. Thanks guys, and I'll see you then. Welcome back everyone. I apologize ahead of time if I sound weird. My allergies are going crazy, and I thought it would help if I drank a couple drops of peppermint essential oil. So now my face is on fire and it's just going downhill from here. So please bear with me. In this video, we are going to be talking about typecasting. Oh, I can hardly breathe. So to begin, we are going to create a new program to solve some more math. And this one's going to be a little less serious because serious math can be pretty boring sometimes. So let's start a new file, vim eggs.c. We will include the standard input and output, and then we are going to open our main function and then return 0. Now, what exactly are we trying to accomplish here? Let's say we are writing a program for a chicken company, and this company wants software that tells them how many dozens of eggs they produce in a day. So each night, a guy enters in how many eggs they've gotten, and then the output is how many dozen that is. Yeah, it's pretty simple. All you gotta do is take the number and divide it by 12. But I'm going to illustrate some cool points in this video. So for those of you who don't know, a dozen, this is a unit that is 12. So if you have a dozen chicken eggs, you have 12 eggs. So we're going to need a variable to store the number of eggs. We will just say int eggs. We'll declare that. And now we're going to get the value from the user, %i, and then we're going to need the address of operator because we're changing the value of the variable. Now we need to also give a prompt to the user so they know what to do. So up here, we could say printf and say something like the number of eggs for the day. And now we can go down here, and I just like to space my code out a little bit so it's a little easier to read. We need a new variable to store how many dozens of eggs there are. So we're going to use the double data type because, we could have a half dozen or a 2/3 dozen. So we always want to use a double data type when we're going to have decimals or fractions. We'll just call this dozen, and we'll make it equal to eggs divided by 12. And then finally, we want to print how many dozen eggs they have. And we're going to want to use the %f conversion character because this is a double data type, which is part of the floating point data types, which we'll learn about those soon, as I said, so I'll shut up now. Dozen eggs, and then we'll end it with a new line character. Now the variable we're going to pass in to the %f is dozen. Now let's run this program and see if everything works as expected. So we'll save it and close, and gcc eggs.c. a.out. The number of eggs for the day. Let's say we're not having a very good day and we only produce 24 eggs. The output is 2 dozen eggs, which is correct. So it seems to be working, right? Not quite. There's actually a serious problem in our program. And that is the main topic of this video that I want to talk about. Let's try it with a different number of eggs. Let's run it again. This time, we're even having a slower day than last time, and we only produce 18 eggs. Oh, we have 1 dozen eggs? Huh. That's not right. What the heck? The problem here has to do with data type arithmetic. Let's go back in our code and try to fix this little bug. Which, if I haven't mentioned it yet, bugs, that is when something is wrong with your program. So we need to squash this bug. Vim. Okay, let's figure it out. Where do we get the number 1? Well, we can kind of go down to about where that value is coming from. It's probably coming from around here, because that's where the value is calculated. The problem behind the incorrect output is that we are taking an integer, eggs, from up here. You see here that it's an integer, and we are dividing it by an integer. C will assume that when we are dividing an integer by an integer, that we want the output to be an integer. This means even though we put in the value 18, we don't get the value we were expecting. Because if you think about it, 18 divided by 12, I think that equals 1.5. And because we are using integers, this 1.5 will actually become 1.0. The reason it has the 0.00000 after it is because we're actually storing it into a double. So if we wanted to be a little bit more correct, 1.5 becomes an integer, so it becomes 1. And then we store the 1 into a double data type, so we get 1.00000. Yeah, I know, it's kind of confusing, it's kind of dumb when you first start, and it'll probably annoy the heck out of you. But eventually, you'll figure it out, you'll understand that, hey, if we are dividing two integers by each other, the result is going to be an integer, even if, mathematically, it should have some fractional part in the decimals. So how do we fix this? Well, whenever we have a double inside of arithmetic, then the result will be a double. So we could add a 0.0 to the 12. Now we are saying, hey, we're working with an integer and a double. That means we want the result to be a double. The final result then would be 1.5. This is one way of doing it, but it's not always going to work. You're not always going to be able to just go in here and add a 0.0 to whatever we're working with. For example, we might not be hard coding the value in here. In that situation, we are going to need something else, and that thing is called typecasting, as I mentioned in the very beginning of this video. Typecasting is when we change the data type of some value. This is the more sophisticated way to get the correct output. So to do typecasting, it's very simple. All we have to do is say what data type we want the value to be inside of parentheses inside of the expression. So I gotta get rid of that comment. So let's say we want to convert eggs to a double. Simple as that. Which way you prefer is up to you, but to summarize, you can either put the data type in parentheses before the variable, or you could add a 0 to a specific constant. I am going to go with the typecasting way. Now, you have to be careful with typecasting. You always want to make sure you are casting what you think you are casting. So for example, what if I did something like this? And I threw both of these inside of parentheses. Now what's going to happen is we're going to do the math and then convert it to a double. Another way to think about it is that the double here only affects the first thing to the right of it. When we didn't have the parentheses, it just changed eggs. It didn't change 12 as well. The end result here is still going to be incorrect because we're using integer division, and the result will be 1 if we pass in something like 16, even though it should be 1.5. But once we have 1 in here, we then convert the 1 to a double, and we get 1.0. So you can see how if you're not careful, you might be trying to cast something, but you're not casting it the correct way. So in this situation, we need to get rid of these parentheses and just cast the eggs to a double. Now let's save this and make sure the result is as we expected. Make sure you recompile every time you change anything. Number of eggs for the day, 18. And you have 1.5 dozen eggs. Awesome. So thanks guys for watching. If this was helpful, please be sure to click like, subscribe, and I will see you in the next video. And in the next video, we are going to be talking about strings. And that is a very important part of programming, so be sure to check it out. Thanks. Hey everyone, welcome back to Caleb the Video Maker 2. This video is going to be a little bit special because we are actually going to be creating our very own complement machine. This video is dedicated to those looking for love. Well, don't worry about other people. Psh. You know, computers are way more predictable, and you can tell them to say whatever they want. Forget all those jerky guys and them mean girls. Just this is getting weird. Okay, let's just get started. So we are going to create a new application, and we are going to make kind of like a modified hello world that tells us our name and gives us a complement. So let's say Vim, and we'll call this complement machine. You can capitalize it however you want. It's totally up to you. Just know that Linux is case sensitive. So this and this with a lowercase c are completely different. So let's go in here and go into insert mode using I and then say include standard io.h int main return 0. Perfect. Now I guess we'll just start with a normal hello world, right? That would be a good place to start. Hello world. And instead of world, we could actually put our name in here. And we'll break down to the new line after that. Now let's compile. And let's run it. You can see that it works. It even says our name. Oh, it's so personal. but it's not good enough. So let's improve it. I'm going to talk about how to put strings inside of these quotes without directly typing them, because we want to start separating what's in our code and what should be imputed in our code or inputted or inserted, however you want to think about it. So sort of how when we started with numbers, we would get numbers from the user and then output them to the screen. Well, we want to do the same thing here. So to start, I want to teach you a new format or conversion character. And that conversion character is actually %s. And that is for string. So what is a string? A string, it's a sequence of characters, where a character is just anything you can type on the keyboard, or like a new line, tab, and all that good stuff. So each one of these is a character. A space is a character. A period is a character. A string is when you put all of those in a sequence using quotes, like this. Hello. You can see here we're actually passing in a string to the printf function, and that is called our format string. Well, what I want to actually do is pass in another string into this string into the %s location. So we need to pass in another argument. So let me get rid of this junk, and we'll go in here, add a comma, and now we need to add something into this function. So what do we want to add? Well, let's just make it work just like it was by passing in our name, and also we will put the exclamation mark right here. So take a good look at that, make sure you understand it, see how it works, and then we will run it and make sure it works just like we were hoping. You can see that it works exactly the same, and make sure you recompile it so we're actually getting new results. This app is pretty cool so far, but I want to take it a step farther and actually ask the user for their name and then output it. So let's go back into our code. And now this might be new to you, but just look at the syntax and familiarize yourself with it, and it'll start to make some sense. We need to create something called an array. And we will discuss arrays in a lot of detail in the future. But essentially, since a string is just a sequence of characters, you can see here just each one of these is a character, we could put each one of these in what's known as a character array. So to do that, let's go into main, go to a new line, and we are going to say char name, which is the variable name. You can name it whatever you want. You can name it Taco Bell, you can name it McDonald's, you can name it spaghetti, you can name it corduroy pillows, which, by the way, there's a new one out and it's making headlines. Basically, you can make it whatever you want. We're going to go with name because that's what it's going to store. The next thing you do is put square brackets. Inside of those square brackets, we are going to say how many characters are allowed. So my name's Caleb. It takes up 5 characters. So what is like the longest name you can think of? That is what you're going to want to consider. So I think 30 would probably be a good number of characters. But there's a little trick here. You have to have one more extra than the total you want to allow. So if I want your name to be up to 30 characters, I'm going to put a 31. And the reason that is because strings need a character at the end to say the string is over. And that is called the null terminator. And it looks like a backslash and a 0. All right, let's get rid of this comment and start working some more on our code. Oh, now for the fun part. How do we get this value from the user? Well, as always, we are going to use scanf. And inside of scanf, you are going to use %s. And as always, you need to put those in double quotes. That is our conversion character that we are going to use, which makes sense because we're expecting a string. The next thing is we're going to use the variable name. And this is where things get kind of confusing. You're actually not going to use the address of operator. So you just put the variable name as is. If you had an integer variable, like int x for example, when you wanted to pass that into scanf to get a value for it, you always have to do the ampersand and then the variable. But when we're talking about arrays, you don't do that. And all of that will make a lot of sense when we start talking about arrays in the future. But for now, this is the exception to the rule. Make sure you don't put the address of operator. Now, inside of the printf, we can just use that variable. Instead of Caleb here, we can pass in the variable here. Let's get rid of this, and we will put name. Let's run it and give it a try. Okay, so it's asking us for a name, but we forgot to put a prompt. So we'll want to do that. But let's put Caleb. And you can see it's working, which is kind of cool. Let's go back in our code and improve it. Let's first give a prompt. So up here, maybe right here, we could say, you know, we might as well make our complement machine a big jerk like every other guy in the world. All right, now let's run it. Yo girl, enter your name. And there's something weird here. You actually can't use spaces. So if you wanted to do that, you would want to take first name, last name separately. So if you did like Sally Bob, it's only going to say, hello, Sally. And the last thing is, don't forget, we have to put a complement in here. There we go. I think our app is complete. Yo girl, enter your name. Sally Bob. Hello, Sally Bob. You look very nice today. So yeah, guys, this is how you make a complement machine in C programming. Hopefully that's helpful for all your lack of relationships. I don't know. If you've enjoyed this video, please click like. And in the next video, we are going to be talking about using functions in C. And that is so huge, so make sure you check that out, guys. Peace, and I'll see you then. What is up, everyone? It's Caleb from Caleb the Video Maker 2. In this video, we are going to introduce using functions in C. I've talked about this a little bit, and I mentioned a little bit about what functions are and how to use them, but I wanted a video just to introduce a little bit more detail. So that way, as we use functions, you're not like, what the heck is he doing? So that way you have a better idea of what's going on when we start typing out more code and everything. As we move on in this series, we're going to start moving more systematically through concepts in C, rather than what we've done in the last 5 or 6 videos where we just kind of give an overview of a bunch of things. That's because we need to go in more detail in order to understand everything we need to know. Specifically, farther in the future, we are going to talk about functions in depth. So don't feel like you have to know everything from this video, and if I've already told you basically everything already that I talk about in this video, that's okay. I just want to centralize it in one video so you can have it for your use. So, with that being said, let's begin. What is a function? A function can be used to call or execute multiple statements at one time. Now, the computer actually does go through each statement one at a time, but for us as programmers, we only have to say one thing. So for example, if we are trying to print 3 things to the console, our code might look something like this. Now technically you wouldn't have to have 3 printf statements, because you can always break things down to the new line using \n. But sometimes for readability, it's easier to break things up into multiple printf statements. That way we don't just have like this huge never-ending string with like a ton of text and a bunch of \n's. It's harder to consume this with our eyes than smaller printf statements. In addition to this, we've also created code that is going to monitor some kind of information. And we want to continually print out the same statements with new updated information. So we might have some kind of sensor that this will print like temperatures or something like that. It doesn't really matter what we're using this for. Just make up something in your head. Essentially, we want to execute all 3 of these numerous times. Well, with a function, we could basically group all 3 of these together into one. Don't look at me all innocent. You just ruined my video, boy. I don't even know what I was saying. Anyways, you could execute all 3 of these at one time and give it some kind of name, like console dump. We're just dumping all the information straight to the console. And then we can just call that using these parentheses. That is essentially what a function is. It's a shorthand to calling a bunch of statements. So this here, this printf statement, this is actually a function itself. You can see we're calling it with these parentheses, and we're passing in information inside of these parentheses of what we want to print. The actual code for the printf statement, we don't need to care about that. All we need to know is how to use that function. Who knows how many lines of code that function actually takes up? It doesn't really matter to us, to be honest. All we need to know is that when we call this function and pass in some information, it goes to the console. That's all we care about. The second benefit of functions is that if you wanted to change something, like let's say we have this code in our program 10 times and we're not using a function, and then we want to go back and change something, we're going to have to change it in 10 different locations. that's not going to work very well. If we're using functions, we can kind of think about it as extracting this code as a formula, and then we only have one copy. So this is our individual copy, and then we can call it multiple times. So now we have 2 calls, and we could repeat this as many times as we wanted. The data that we actually pass into a function inside of these parentheses, these are known as arguments. Functions can accept as many arguments as they want. The only thing is you have to separate multiple arguments by commas. So for example, in this printf function, we could do something like this, where x is the name of a variable that stores some value. The action of putting data here is called passing. So if you had to put it into a sentence, you would say we are passing 2 arguments. The arguments in this case, the first one would be this string here. The second one would be x, and they're separated by a comma. Arguments allow us to customize our functions. For example, in this situation where we had this function we created called console dump or whatever, we could accept arguments that allow us to change how the function works. You can see that in the printf function. The printf function does something different depending upon what we pass in. If we're passing in x here and it has the value of 5, it's going to print 5 to the console. But if x has the value of 6, it's going to print 6. So if you need another way to think about this, you can think of functions kind of as cookie cutters, right? Let's say we have this cookie cutter in the shape of a carrot. This could be our function. A cookie cutter only gives you most of what you need. As for the actual color and the material, you're probably going to use this for eating, so I don't know if material would be the best word, but substance, all of that stuff depends on you. You get to choose that kind of stuff. You can think of that kind of stuff as the arguments. You know, you could easily fill this up with peanut butter and then make a carrot-shaped peanut butter cookie. Or you could fill it up with chocolate chip cookies. The end result, it looks like a carrot, but each carrot is slightly different. This one could be, you know, chocolate, and this one could be peanut butter. If you had to convert this into computer science terms, it would look something like this. Make carrot cookie, and then we could pass in here like a string, for example, chocolate. Where this function is defined, that's what we'll get into farther in the series when we talk about creating our own functions. But essentially, if you go track down where this function is created, you'll find something called a parameter that describes what you're passing in here. So we would say something like flavor, I guess. So flavor is going to be a variable, and the value of flavor is going to be chocolate. That is your rundown of functions in programming. They're super helpful because 1, they make it less easy to make mistakes because you don't have duplicate code everywhere. 2, it makes your code easier to read because all we have to do is say a name, make carrot cookie, super clear. And 3, it makes the main section of our code much smaller. For example, if you had an app that makes cookies and sells cookies, you could just have another function in here, and this might all be inside of main, and you can see that all of our code really looks like there's only 2 lines. That's pretty easy. It's nice and readable, nice and easy to maintain. It's awesome. So that is why functions are so great, and I hope you guys understand the beauty of them and enjoy them, if that's even possible. It is possible to enjoy carrot-shaped chocolate cookies. So yeah, guys, thanks for watching. If you've enjoyed this video, please click like, subscribe, and I'll catch you in the next one. Woo! What is up, everyone? It's Caleb the Video Maker 2. This video, we are going to be talking about comments. Now, I know if you've ever programmed before, you're probably like, oh, do we really need a whole video over comments? Come on, it's easy. Yes, it is easy, but I'm hoping to do more than just teach you comments. I'm hoping to explain when to use them, how to use them, what to do, and what not to do. So hopefully this is a little bit more helpful than, hey, here's how you make a comment. And if you have no idea what a comment is, that's fine too. So let's get started. You can see that I listed all of the files in my working directory, and these are the files we've worked with so far in this series. I am going to work with this eggs file again, and I'm going to add some comments to it. So let's open it. In C, there are 2 types of comments. The first is called a single line comment, And to make a single line comment, you use 2 forward slashes. So go into insert mode by pressing I and then press // This is a comment. Inside of this comment, we can put anything we like. The compiler just ignores it. I like eggs. There was some person on a TV show I used to watch, The Amanda Show. There was this girl on the bathroom episode who was always like, I like eggs. You know what I'm talking about? Yup, right there. She would love working at this egg company. Anywho, let's get back on topic. The other type of comment is called a multi-line comment. And the main difference is that a multi-line comment allows you to type as long as you want. All of this is inside of a single comment. That does not work with a single line comment. For example, if I typed right here, well, this is going to give us a compiler error because it's no longer part of a comment. Each one of these comments has a benefit and a downside. For the single line comment, the obvious downside is, well, you can't do it on multiple lines. But the benefit of a single line comment is you can actually put it after code. For example, here, let me get rid of this line. So down here, I can actually explain something after the code. So I can put // this does something, and you can explain what it does if it's confusing. That way, when you come back 5 years from now, you can read what you had to say about this code and you can understand what it's doing. This has its downside though, in that anything after this on this line will be counted as a comment. So I can't do stuff like int x, yada yada yada. It's all on the same line, so it still thinks it's a comment. With multi-line comments, you can actually put it inside of other code. So I could put a comment here and say, I think I might add more info here. So that way the user knows what to do. Something like that. And this is actually going to be fine for the compiler, except I typed that in wrong. There we go. So often at the top of a program, you can put something like who wrote it, what the program is for, all that good stuff. And I have some strong words to say about these code blocks, let me tell you. Oftentimes you'll find extra asterisks, so that way it's extra clear what's going on here. There you go. And now we have this little section that kind of describes what the program does. And I'd probably put it above the include statement, but it's fine for now. You could just the same make these all single line comments using double slashes, but oftentimes you'll see it in a multi-line comment. Oh, these multi-line comments, I tell you, sometimes they introduce some really dumb stuff to code. And if you go to computer science school, the chances are they'll tell you to do this. But personally, I think it's pretty dumb because, one, rarely ever are you going to have code that's written by just one person. So why do you put an author here? I have no idea. And then let's say you work at this job and you're really bad at coding, so they fire you. Well, now the next guy has your code. So is he supposed to change this to his name? Because technically he didn't write it, but he worked on it. So I don't know. I think that's stupid. The description, that might be useful. That might be able to say, hey, what is this page for? The date, personally, I think that's stupid and they should get rid of that too. Like, why would you put a date on a document that is going to continually be updated? The first problem here is that that's assuming the code is never going to be changed. And if you try to fix that and say, oh, every time you change this code, you just got to update the date. Well, that's stupid because the chances are you're going to forget to do that. And two, why does it really matter? I don't know. Most programming companies are going to use something called source control. An example of this is Git or Subversion, etc. And all of those are going to keep track of when your changes are. So you don't need to put a date in there either. When I took a computer science class, I got points off on literally almost every project because I didn't comment well enough. But the thing is, the teacher wanted me to comment so much that I had more comments than I had actual code. If you comment so much that happens, when you change your code, you'll have to go search through your comments and update everything. And then what happens is, if you forget to update something, you have comments that are out of date. And nothing is more confusing than a comment that says code does something, and the code actually does something else. That comment is actually making it harder to understand, not easier. So I am one of those people who lean on less comments than more comments. Although I do think it is helpful to maybe give a sentence or, if you have to, a couple sentences describing what a function does or what a section of code does if it is complicated or hard to understand with a minute or more of studying. This could really help other people know what your code is doing. Just make sure you don't overdo it and describe every single detail. The point of the comment is so you know what the function or section of code does, not necessarily how or why it does every single thing the way it does. If you disagree and you think, hey, we should use tons of comments, give me your reasons why and I'll see what you have to say, and maybe I'm wrong and maybe I should try to use comments more. But if you find yourself doing stuff like in x equals 5 plus 5 and then commenting x equals 10 or something, like, you should be able to figure out the value of x just by looking at this. This is redundant information and actually lowers the quality of your code and will ruin your life. So yeah, that is my argument for the day. I may have gotten a little off topic. There is one other thing I wanted to share with you, and that is if you're working on code and you're working on something, but you're not quite done with it, you can do what's called a to-do comment. And what you do is just say to do and then explain what you need to do. The benefit of this is that when you need to go back and update your code, you can just search for anything that says to do to make sure you got everything done and that you can update the sections that you didn't finish. So I highly recommend trying to do that. And yeah, that will probably help you out and other people who are working with your code. So yeah, guys, thanks for watching. Hopefully I had some good insight for you. If you have any other information, please leave me a comment and I will check it out. Thanks, guys. Peace. Welcome back, everyone, to your C programming tutorial series. Now, this video, we are kinda going to go a little bit off topic, but the content is still going to be extremely useful. So, I am going to have this video and probably the next video to talk about Vim. So Vim is the text editor that we've been using to do all of our fancy coding. The thing is, this text editor is very hard to use when you don't know how to use it. So if you're not using Vim, you can just basically ignore this video and the next video. But if you are using Vim, hopefully I'll be able to give you some good tips to teach you how to use Vim to the best of your ability. If you aren't using Vim though, you might still want to consider watching this video to learn a little bit about Vim. That's because you might end up having to use it someday. Anyways, let's get started. The very first thing is that when you look at this, you just think, oh, it's all green and it's ugly, and yours is probably black and black. It's just ugly. So we can actually fix this by typing :syntax on. Oh, now look at that. That's pretty. The other thing is sometimes we get errors and it'll say, oh, this error is found on line 17 or whatever, and we have to go count 1, 2, 3, and then by the time we get to like 14, we lose track and have to restart. We can actually put line numbers on this by using setNumber. Oh, nice. The only downside to using these two things that we just enabled is that if we close it using WQ and then reopen it, oh, everything's gone. Really? So that's one thing that's really annoying when you're first starting Vim. Even when you try to make Vim a little bit more user-friendly, it turns around and stabs you in the back and erases everything you've done. In order to make the line count and the syntax highlighting on by default, we have to add those commands to a configuration file. So I will show you how to do that. First is you want to quit Vim and just go to your ordinary console. I'll just clear the screen just so it's nice and beautiful. The next thing is you want to travel to your home directory. If you remember how to do that in Linux, you use CD. Now we need to actually either edit a file or create one if it does not exist. So the file is actually .vimrc. So the chances are if you're new to Vim, it doesn't exist. So if you put ls-a, you can look in it in here. And if you look closely, you're probably not going to find it. We found Vim info, but that's not quite what we want. So we're actually going to create this file. If you do have the file and you want to edit it, you can follow along. Just type vim and then put .vimrc. Now the dot means it's a hidden file. So if I was to open up a Finder and look in this folder, all of these would be hidden. The -a makes it show hidden files. So let's open that. And now we need to put the commands in this file. So go in insert mode by pressing I, and type syntax on, and setNumber. And then escape, :WQ. Now let's go back into our YouTube folder, list the files, and we'll open eggs. And there you go. That is how you make the lines and the syntax highlighting on by default. The next thing I wanted to talk about was how you move the cursor around. Now you've probably figured out, hey, you can use the arrow keys and it works just fine. But there's actually another way to do it that people who are like advanced at Vim prefer. But the recommended way to move is first, make sure you're not in insert mode. So press escape to get out of any mode you're in, and then you can use H, J, K, and L to move around. H moves to the left, L moves to the right, J moves down, and K moves up. I'm pretty sure these characters are based off of an old keyboard that used to have the arrow keys on those 4 characters. But now it just kind of sticks, and a lot of people prefer that, and also you don't have to move your fingers as far for those of you who are like super lazy. Now whether you use these or the arrow keys is totally up to you. But either way, you'll probably want to try to get into the habit of only being in insert mode when you really need to insert something, and not all of the time. So what I mean by that is, like, let's say I want to go down and change the double data type to float or something like that, to some other data type. Well, you don't want to be like, oh, I'm in insert mode, let's just walk down there and okay, yeah, let's just delete that and put something else. That's not what you want to do. What you want to try to do is only be in insert mode when you really have to. So I'm actually really bad at this. The recommended way would be to travel down to the double, not being in insert mode. And you can see I had to press that key a whole bunch of times to scroll down there. Well, there's actually a shortcut to kind of go down into your code. You can see that that is on line 10. So we can jump to that line by typing in 10 capital G. And you can see it jumps to that line. So you don't have to press colon or anything like we did in some of the other commands. You just push 10 capital G. If you want to go to the very end of the file, you can just put capital G. Another thing you'll want to do is go to the end of a line. So for example, if I wanted to add a comment after line 10, first we can travel to line 10 by pressing 10 capital G, and then we can use the $sign to go to the very end of that line. If you want to go to the beginning of the line, you can use the caret symbol, which is capital 6. Let's go back to the end by using the $sign. And now, if you want to start typing after the semicolon, there's 2 ways you can really do this. First, you can press I to go into insert mode, and then use your arrow key to scoot over one, and then you can start typing. But there's actually an easier way. So let me escape and go back a character so we're just exactly where we were a second ago. You can press lowercase a, and that will go ahead of the character that you're currently on and insert you into insert mode. There are a few last commands I want to teach you, and the first is using the lowercase w, and that will jump to the beginning of the next word. So for example, if I'm over here and I'm on dozen, right? And then I press W, it jumps to the beginning of eggs. You could also use B, which will jump to the beginning of the previous word. Lowercase b goes to dozen. Those are some of your quick ways to move around. It's going to take you a while to learn all those. If you need comprehensive notes, you can download my notes. I'll put the link here at the end of the video. If you've enjoyed this video, please be sure to click subscribe and like, as that really helps my channel and I really appreciate it. Thanks guys, and I will see you in the next video. Welcome back YouTube, this is Caleb the Video Maker 2, and in this video, we are going to be talking about some more tricks in Vim. The previous video mainly talked about how to move around in Vim, but this video is going to teach you some even more important things to help improve your efficiency. So now that you know how to move around, I'm going to be teaching you how to actually do things. The first thing I wanted to teach you was different ways to quit the application. So as you probably figured out from this video, you can type in a colon and then put WQ to write W and then quit Q. The write means to save. So you can combine these commands, but they're actually originally individual commands. So you could do these separately as colon W, enter, and then colon Q, enter. Those are the basic ways, but now I'm going to be teaching you some more ways. The first way is to quit without saving. So let's say you go up here and you just slaughter your code. I mean, you just accidentally deleted something and you don't know how to put it back. Well now, how to fix that? The easiest way is just to quit without saving and then reopen it. Just make sure you've saved it at one point in time. So when you do this, any changes since the last time you saved the file will be lost and you can't get them back. So be very careful, but you can do it by typing colon Q exclamation mark. And you can easily figure out how to do that, because if you do make changes in here and you just try to quit, it'll say add an exclamation mark to override. So you don't really have to try to memorize that one. All you got to know is that you can try to quit, and if you haven't saved it, it'll tell you how to quit without saving. Voila. So I deleted that junk, and now I'm going to teach you a new way to save it and close it without having to type in :WQ. It's a little easier. You just hold Shift and press ZZ. So 2 capital Z's. That will save it and exit the program. Now let's reopen it. The next thing I'm going to be teaching you is pretty cool. What if you want to temporarily close Vim and kind of put it in the background, but you don't want to have to decide whether you want to save your changes or just close without saving. You just kind of want to, put it to the side, go back to the console for a couple minutes, and then return. It's actually very easy to put something in the background. All you got to do is hold Control and press Z. And you can see down here it says stopped. To restore that session, all you have to do is type FG and press enter. You can think of FG as meaning foreground. You want to take the thing that's in the background and move it to the foreground. So we want to start working on it again. Enter, and you can see it opens just how we had it. So that means if you go in here and you slaughter your code, and you think you like it, but you're not really sure, you're not sure if you want to save or quit without saving, pressing Control Z, then you can do some commands in here, whatever you want to do, and then when you're ready, you can press FG, and it's back exactly how you had it before. Now, I'm going to tell you right now, occasionally, you're going to be working with Vim, and something's going to mess up. For example, let's say we close this using Control Z, and now we try to reopen it with the Vim command, like this. Press enter, and you can see we get this funky error with a ton of information. Essentially what this page is saying is, hey, you had this file open at one point. You might not want to try opening another session of this file. This will happen if you accidentally shut down your computer without shutting it down the correct way, or if you already have the file open somewhere else. If it's the first case where you turn on your computer after a power outage or something, you can hold Shift and press R to open the file, as you can see down here. That will recover the file as you had it. If you have it open in another process, what I would do is I would actually quit by holding Shift and pressing Q, which is right here. And then open it the right way using FG. So now you kind of have some more ideas on how to open things and close things, but what happens if you slaughter your code like this and you want to fix it and you just kind of want to undo things? All the fancy editors nowadays have undo buttons, but if you try to undo something in here using Control Z, well, it just puts it in the background. So the question is, how do we undo things when we are in Vim? You actually use a lowercase u, and you want to make sure you're not in insert mode. So you can see as I press U, it starts undoing things until it's back to how it was. You can also redo, meaning put that stuff back, the stuff you just undid. This one is actually pretty normal in that you hold Control and press R, and you can see it comes back. I'll just undo that because I don't really want that there. You can cut lines using DD. So for example, I could cut this and come down here and paste it using P. Using DD will put the line in what is known as the clipboard. When you copy something, it goes into this location called the clipboard, which is a magical location. No one knows where it is. So I'm also going to undo that because, why would I leave that down there? One other way to do it, though, is you can actually use capital P, and it will paste before the line that you're on. Lowercase p, paste it after the line you're on. If you're working in here and you want to delete part of a line, you can actually use the lowercase d command followed by the $sign. If you remember from the last video, the $sign is another way to say the end of the line. So we could say lowercase d for delete, and then $sign to delete up to the end of the line. So let's get rid of this line. I just cut the thing using DD. And now let's teach you how to copy, because sometimes you don't always want to cut. Cutting allows you to paste it elsewhere, but you might want to keep it in 2 locations. So if I wanted to copy this line, you use lowercase y, and that is short for yank. Now we can go somewhere else and paste it. Oftentimes you can mix commands with numbers. So for example, if I wanted to copy 4 lines, I could say 4 YY. And then down here you can see it says 4 lines yanked. Now we can go down here somewhere else and paste all 4 of those lines. I think that should be enough to get you started with Vim. It's a lot of information. Don't feel overwhelmed. You don't have to have all those memorized. Honestly, I'm still learning a lot about Vim. So throughout this series, if you see me do something completely wrong or dumb with Vim, please let me know. I am learning too. Now there is a helpful website I would like to share with you, and you can find it at vim.rtorr.com. And here's just tons of commands you can use to use Vim to the full potential. So thanks guys for watching. Hopefully this was helpful. Once again, you can download my notes, which will have all these commands written in them. Thanks guys, and I'll see you in the next one. Hey, welcome back everyone to your C programming tutorial series. This is Caleb from Caleb the Video Maker 2, and in this video we're going to talk about data types. Now before we start talking about the types of data, let's first talk about what data is. Well, the best way to discuss data is to imagine that we have a variable that holds some data. So let's say we have a variable called tacos, and it stores the value 5. The 5 is a piece of data. By the way, an individual data is called a datum. But I personally think that word sounds dumb, so I'm not going to use it. 5 is an example of data. Now the data type tells the computer how to interpret this data. How does the computer interpret this data right here? And it seems kind of odd, like doesn't the computer just know? Well, actually not. For example, when we're working with integer division versus double division. 5 divided by 2 equals 2. 5.0 divided by 2 equals 2.5. You can see that we get 2 completely different results. These are not equal. And the reason they are different is because the data we are working with has different data types in each of these situations. The data types of each of these pieces of data are as so. The 2 is an integer, the 5 is an integer, the 2 is also an integer, but the 5.0 is a double. So far you can see that there are differences even in the numeric data types. So these are part of the numeric data types. The other one you should know is called float. But starting off knowing int and double is very helpful. The data type of the data changes the results. So you can see that data types are very, very important when it comes to programming. Super important. Our human brains like to group things. So to help us out, data types are often classified. And one of these classifications is called primitive data types. I don't really like this word either, but that's a discussion for another day. The primitive data types are considered to be the smallest data types. And when I say smallest, I don't mean like size. What I mean is that they can't be broken up into pieces. You could say that they are indivisible, or what some people would say, atomic. If that doesn't make a whole lot of sense, consider primitive data types as the building blocks. These are like the Legos that we can combine and piece together to make more complex data types. I just used a word that you should know. The other type of data type is complex. Now, a perfect example of a complex data type is a struct, and we can define our own structs. We are not going to get into the details of how to make structs right now because it's way down the road, but it is important to know that they exist. A struct is essentially using these primitive data types to make something more complex. For example, we could make a struct for dates. So then we can make a variable like this. You can see that the variable today is of type date. Or we could have something like this. You can see that the variable LOL is of data type coordinates. These are not primitive. They are complex. We used the building blocks to create them ourselves. We can even combine multiple structs to make even bigger structures. We just keep building and building and building until we have very complex data types, or what some people would say, data structures. An example of a more complex data structure would be a linked list. A linked list you can think of as a chain of things, where these can be whatever you want them to be. So for example, we could make a linked list of coordinates. So each one of these would have an XY. And this could be some kind of route that you have to take to get somewhere. You can see that they're all connected. And you can see it just gets more complex and more complex. For now, I don't really want you to worry about the complex data types. What's important is that you get down the primitive data types. there's a lot of data types that are built into C, and structs are a good example of something that's built into C, whereas the linked list you kind of have to build yourself. But I want you to focus on the stuff that is already included in C and don't worry about this stuff for right now. Once you got down the numeric data types, the arrays, and even some structs, then you can start building some more complex things like linked lists, which is the hardest word in the world to say. Lists. That's all I got for you guys in this video. Hopefully it was helpful. I will see you in the next one. Peace. Also, be sure to subscribe, and don't forget to download the notes if you think that would be helpful for you. All I ask is for your email. You know, I'm not gonna like spam you that often. Hey guys, welcome back. This video we are going to continue our discussion on data types. So if you don't know what that is, go check out the previous video. And if you did watch the previous video, let's dive right in. One classification of data types that you guys are going to need to know about are arrays. Now later in the series I'm going to have a video dedicated to arrays and a couple videos with working with arrays and all that good stuff. But now I want to give you an introduction because I know you guys are going to run across arrays and I don't want you to have to wait till like video 758 to know what an array is. An array allows you to store more than one thing inside of like a group of whatever this thing is. So for example, we could have an int array. You can name it whatever you want. And an array is signified with these square brackets. And inside of here, we put some number. So we could put, you know, like 10. And essentially what this is going to do is give us a group of things. Okay, kind of ran out of space there. But each one of these can hold an individual value. Boom. Fit them all. This entire thing is grade. And it might make more sense if we put an S on it. Grades. You could also have arrays of different data types. For example, you could have a character array, and this would look something like this, where each one of these is an individual character. And this entire thing is balloons. Now, there's another data type that every programmer needs to know about, and that is the string. All a string is a double-quoted sequence of characters. I'll just give you an example, it makes way more sense. This is a string. Each one of these is a character. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters. So this is a string with 11 characters. And you can literally think of characters being strung together in a sequence. Well, how exactly is this string thing stored in C programming? Well, it's actually stored inside of a character array, which makes sense because if you think about it, we just have a sequence of characters. Kind of like down here, we could have, you know, I space L-I-K-E space C-A-T-S and so forth. So if we made a variable to store something like I like cats, it needs to be a character array. But this string is a kind of string that has to be terminated. And I'm just gonna scratch the surface of this because we're gonna devote tons of videos to strings later, I promise. But at the very end of the string, you have to put something called a null character, which looks like \0. This is how we write the null character. In reality, the null character is the absence of everything, because that's what null means, N-U-L-L. But to tell C we want to put the null character, we would put a \0. And this is interpreted as one character, just like we have the new line character, \n. That is one character that goes down to the next line. Because of this, the array actually has to be one character longer than what you would expect. So we end up with something like this, where this is the string, and now I'm going to split the characters. We end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have an array with 12 elements. Everything inside of an array is called the array's elements. We'll get into strings and arrays more in the future, just introducing it to you guys so you have a rough idea. There is another term you guys ought to know, and that term is constant. Claire. What do you want, Claire? Now, there's kind of two definitions of constants. One is where you kind of make a variable, but it's like a variable that can't ever change. And you probably know of those from like science class when, oh, you change this, but this remains constant. That's kind of one definition of constant. There's also another definition, which is just a value. So if we declare a variable, the number of cats I have, this here is a constant. Think of a constant as something you can write down. Usually it's pretty clear, but let's go over some examples of different ways you can write similar constants. For example, you could have this, you could have this, and you could have this. These are 3 different types of constants that are all very similar, but the data type for these are all different. The first is a character because of the single quotes. The next is an integer because there's no quotes. And then the third is a string because of the double quotes. Generally, you don't have to worry a whole lot about the data types of constants. I'm just trying to give you some extra detail. For example, in this situation, this is interpreted as an int. But let me give you another example. Let's say we do something like float cats equals 98.5. Well, this brings up an interesting point because this constant here is actually a double data type. We don't really have to worry a whole lot about that because we're assigning it to a float, so we get the expected value of cats being a float data type that has the value of 98.5. But sometimes you want to be very, very specific, and that might come up sometime in the road down the future. If that does come up, there are certain things you can do to be very specific on the data type of a constant. If you want to be specific and say this is a float, you can do things such as adding an F to it. Now, this is a float constant. I'm getting into a little bit more detail than you need for right now, but that's fine. If this is something you guys need to know more about, go research it, read some books on it, or ask me some questions. But for now, I think I covered the topic good enough for now. So thanks guys, be sure to subscribe, and I will see you in the next video. Welcome back everyone to Caleb the Video Maker 2. This video we are going to be talking about numeric data types. Now I know we've talked about numeric data types a little bit. In fact, I know I've already taught you about int and also double. The other one that I wanted to talk about is float. If you haven't heard of float, it's very similar to double with just a little bit of a difference. There are some other numeric data types, but they're basically just variations on these 3 data types. So it's very important you get these 3 down, and then you can kind of just modify them a little bit to figure out all the other data types. The very first one, int, it stands for integer, and an integer is a whole number. So for example, 6, 7, 8, 9, 10, those are all whole numbers. Even like negative numbers, -4, -3, 0, all of those. Now the next 2, these you could classify as floating point numbers. It seems kind of odd because you see it has this word float in it, and it makes you think it only applies to the float data type. But actually, both the double and the float data types are considered floating point. Essentially, what a floating point number is anything with a fractional part. So for example, 5.4, 6.8, 3.0. So this video is going to try to familiarize you with all 3 of these and also talk about some tricks and tips and all that good stuff. So what I'm going to do is I'm going to open a file. We'll just create a new one. We'll name it numeric data types.c. So we're in our file, and the 3 data types, again, just so you have them here for reference, are int, double, and float. So let's say you wanted to store in a variable the number of dogs you own. Which data type are you going to want to use? Well, you're probably going to want to use int. That's because I highly doubt you have a fractional part of a dog as a pet. If so, that's just messed up. So you could do something like this. Int dogs equals 6. So that one's pretty easy. Whenever you want to have whole numbers or things that can't be divided, you will want to use an int. But when do you use double or float? They're pretty similar, so it's kind of hard to tell the difference. Well, if you're not sure, err on the side of using double. Double is considered the more standard, more accepted, better data type of the 2. Now, there are certain situations when to use float. I think it would be more clear if I actually explained the difference. Let's make a section for floating point. The difference has to do with precision. Think of precision as how much data the thing can hold. So if you have a value 99999.9999999, this thing is super precise. Then again, if you have a value like 4, I mean that's not precise at all. It's just 4. So the difference between the 2 is that double has double the precision. That means if you need to store a lot of information, you're probably going to want to use the double data type. Let's clear this junk out, and then I will go through an example showing you the difference very clearly. Let's say we want to print some values. We need to know the conversion characters for all of these data types. Well, the first is %i for an integer, and we want these in a string. And then the second is a %f for floating point values. There's a little tip here. I'm going to talk about this more later, but if you pass in a float to this, it becomes double. The function will actually convert the float value to a double. That is another example of why we want to use doubles more often, is because they are more standard. There is a time when you would want to use a float though, and that is if you're very, very, very low on memory. That's because doubles take up twice as much space. So if you're on a very, very small device with very limited memory, you might want to use floats. But for basically every other computer application, you're going to want to use doubles. The fact that this becomes a double also shows us why there's only one conversion character. No matter whether we pass in a float or a double, it's going to be outputted exactly the same. So we only need %f. We don't need %f for doubles and then %f for floats. It's just the same. So let's get rid of some of these comments, and now I'm going to show you where floating point values have their weaknesses. So let's put a comma here and let's pass in some values. I'm actually going to pass in a float and a double, so let's add another %f and a new line. We'll pass in 1.1111, and then we'll pass in 1.1111 with a capital F, which is to say, hey, this is specifically a float. Let's save this and run it and see the output. All right, you can see that the output for the integer is what we expected, 1, and the float and the double output exactly the same. In this situation, whether you use float or double doesn't really matter. The output is exactly the same. But there are times when there are differences. For example, let's go back into our code and let's change the numbers we're printing out. Let's change this to 1111.1111. Oh, now you see some differences here. The integer is just like we expected. The double is what we wanted, but the float is not what we wanted. This problem has to do with how numbers are stored on computers. They are stored in base 2. Essentially, they are stored in binary. And in binary, certain numbers cannot be represented exactly. This problem of being in base 2 with the combination of using a float variable gives us a number that is not exactly what we were hoping for. If we kept adding data to our numbers, eventually the double variable is going to mess up too. So the moral of the story is that you can't trust floating point numbers for everything. Integers are a little bit more trustworthy. If you put in 1, you should expect 1 to come out. That's all I got to say in this video, guys, and as always, my last minute words on whether to use float or double is, if you're unsure, prepare for trouble, make it double. And that's all I got for you guys. See you in the next video. It's Caleb the Video Maker 2. I got a video for you. Ha! Welcome back to Caleb the Video Maker 2. This video we are going to continue our discussion on numeric data types. Specifically, we are going to be talking about floating point numbers in more detail regarding scientific notation. So to get started, we're going to continue working on our file from the previous video, but if you don't have it, that's fine. You can just start fresh here. So numeric data types. This is what we have. Literally all we're doing is printing some values. It's really nothing complicated. Since you've seen the basics in the previous video, it's important for you to understand how floating point numbers are actually stored. Well, let's go down to this floating point section. Floating point numbers are actually stored in scientific notation. Now, if you need a refresher of what scientific notation is, that's okay. I didn't pay attention in science class either. Essentially, what scientific notation is you can take a number and multiply it by 10 to some power. So for example, if we have the number 24,000, we could represent this as 2.4 times 10 to the 4th power if you wanted to write it mathy. We could also have negatives. For example, if we had the value 0.000045, this would become 4.5 times 10 to the negative fifth. Sometimes it's actually easier to input our data in scientific notation. Now, when we're typing it into a computer, it's a little bit different than this, and I will show you what it looks like in just a minute. Alright, so I've simplified this code quite a bit. All we have now is a variable, and then we're going to print this variable. But we actually need to initialize this variable with some value. But I want to do it in scientific notation. So how do we do that in the computer? Well, let's say we want to say we have 25,000 dogs. How do we do that? Well, we start with 2.5. And that's just part of the rules of scientific notation. You go up to the point till we only have one decimal on the left, and then we grab every number that's not a 0. Now, we put E, and E is short for times 10. And then we say what power of 10 we want that to be right after it. So we would say 4. And essentially, you can think of it as this. A decimal is right here. We multiply by 10, we scoot over 1, multiply by 10, scoot over 1, multiply by 10, we scoot over 1, multiply by 10, and we have 25,000. All right, let's see if it works as we expected. And the output is 25,000. Awesome. There's only one problem. This here, we are typing it in ourselves. This is called hard coding, and it's generally frowned upon. That's because if we ever wanted to change this, we would have to go in here and retype something, recompile, and then redistribute our program to all of our customers. That's bad. We always want to try to get values from some other source, such as a database, a text file, or input, which is what we've been doing. So in the next video, I want to talk about how to get this as an input from the user. This would be useful if we were given some kind of text document with a ton of numbers, but everything was in scientific notation. Well, this next video might help you convert that to numbers like this, which is called decimal notation, by the way. So thank you guys, that's all I have for this video. Please be sure to subscribe, and if you've enjoyed this video, please click like and share it with all of your friends. Thanks guys, peace out, check out the next video. Hey everyone, welcome back to Caleb the Video Maker 2. In the previous video, I talked about scientific notation and how to hard code those values. But this video, I wanted to talk about how do we get these values from the user and how do we output in scientific notation. Essentially, I want to explore some of the different ways we can format our data. So, to begin, there are some format characters, also known as conversion characters, that we need to learn. So for example, this %I is one conversion character, but there are many more that we can use. So let's learn those first. Let's go down here and make a list. The first one, which we've already learned about, is %F, and this is for decimal notation. Decimal notation is like this, nothing fancy about it. The next one you're going to want to know is %E. This is used for scientific notation. Lastly, we have %G. And this one allows the computer to decide. How does it decide though? Well, it depends on the size of the exponent. If the exponent is less than -4, it will put it in scientific notation. Or if the exponent is greater than 5. Otherwise, it will use decimal notation. To learn these, let's take our number up here and output it using all 3 of the conversion characters. So let's go up here to our printf statement, and you can see here we are using the I for integers, but let's convert that to a double. And now let's output this as F, E, and %G. It's kind of confusing looking, but essentially we're putting the F on one line, the E on the next line, and then the G on the last line. And we are going to need to throw in this dogs 3 times. Now let's run this. All right, now you can see what our output looks like. Speaking of dogs, mine is being very obnoxious. The first one is decimal notation. The second one is exponential notation. And then the third one, the computer decides and it says, hey, I think it would look better without the exponent. If this exponent was a 6, this would output a little bit differently. Let's show that. Let's change this to a 6. And there you go. Now you can see it's using scientific notation. Now the plus here, that's kind of redundant. It's kind of like putting a plus before a number in math. If you don't put it there, it's just assumed. Negatives, on the other hand, are required. Now let's talk about taking input. Let's go back to our code. Let's get rid of this outdated comment. And we'll add a prompt here. we will declare the dogs variable, but we're not going to initialize it. We are going to get the value from a scanf. Now, scanning in floating point values is a little bit different. We actually need to use %lf. That is how we scan in a double. The variable we want to store that value in is dogs. Now, the good part is that this format character can actually be used to read scientific notation and decimal notation. So we don't have to memorize all the different options of LF, LE, and LG. We can just use LF for everything. Let's give this a try and see if it works as we expect it to. Let's save, compile, and run. How many dogs do you have? I would say I have about 65,300 dogs. The output seems to be correct. Let's try again. Yep, seems to be working. And now let's try to give an input in scientific notation. So you can see in this situation, even though we gave our number in scientific notation, it can still be outputted in all three different ways. That goes to show that the LF conversion character can be used for both scientific and decimal notation. One thing you gotta pay special attention to is that for scanf, you have to use the L when we have a double. For printf, you just use F by itself, you don't need the L. And the reason behind that is kind of confusing and gets into a lot of advanced details. But essentially, as I mentioned before, if we pass in a float to the printf function, it gets promoted to a double. But scanf, on the other hand, works a little bit differently because we are using this address of operator. The data type of dogs does not get changed if it were to be a float. And because of that, we have to have two conversion characters, one for double and one for float. And if that doesn't make perfect sense, don't worry about it. By the end of the series, I'm sure you will understand that. So thanks guys for watching. If you've enjoyed this video, please be sure to click subscribe, like, and I will catch you in the next video. Peace. Yo, what's up everyone? It's Caleb from Caleb the Video Maker 2! In this video, we are going to be talking about the char data type. Sponsored by Onyx. Anywho, char is short for character. This is another type of data. We've already discussed the numeric data types, which are used for numbers. Well, the character data type, or char, is used to store individual characters. Now, what exactly is a character? A character is anything we're allowed to type, input, or output on the computer. So you can generally think of a keyboard as anything on there being a character. So you're gonna have a space, you're gonna have a tab, you're gonna have a backspace, you're gonna have a bunch of letters, a bunch of numbers, all that good stuff. There are some other characters that you can't visually see on a keyboard. For example, there is a null character, which you can represent as a \0. So examples of characters would be A, which by the way, these are not the same character, B, 1, 2, \T for tab, \N. And when you're writing characters in a program, you will always use single quotes to surround them. That establishes the difference between 1 as a character and 1 as a number. They are two separate things. Well, how do you know what characters are allowed? Like, I mentioned that most of the characters on the keyboard are allowed, but what about different languages and all that good stuff? Well, that has to do with what's known as a character set. Now, the character set is the allowed characters. And the character set we use when we are using C is a very limited character set known as ASCII. Now, if you want, you can look up ASCII and figure out the characters that are allowed in this character set. Now, before we talk more about character sets, I want to discuss binary. Now, whenever you hear the term binary, you should automatically think two states. We can represent two different states using zeros and ones. This could be on, off, high, low, yes, no, true, false, etc. The term binary, you often associate it with computers, but it doesn't necessarily have to be computers. Anything that is in two states can be considered binary. But in computers, we use binary to represent numbers and characters and all of that stuff. So if we just have one individual binary character like this, it is called a bit. So an individual bit can be either a 0 or it can be a 1. Now, having only two options isn't very helpful. So to make things more complete and more complex, we can have multiple bits. For example, we could have 8 bits. So a group of 8 bits is so common that it has its own name. This is called a byte. You're probably wondering why I'm going into all this stuff. Well, trust me, this is very useful when it comes to understanding data types and data in C programming and any programming language. So each one of these bits can have a value of either 0 or 1. So we could say 0, 0, 0, 0, 1, 0. This is just an example. You could fill it up however you wanted. Well, computers understand groups of bits like this to represent something in the computer. If a programming language is using the ASCII character set, it will interpret groups of 8 bits. So this actually means something. What exactly does this mean? Well, this is actually how you represent a capital A. So when you make a capital A, this is how it is stored in binary. Now, standard ASCII actually only uses 7 of these bits. So it's going to take the first 7 of these, and this last one is left untouched. Some versions of ASCII use that last bit, and those are called the extended character sets. What we need to understand is that ASCII has groups of 8 bits. The biggest one, or the most significant one, is left alone, so it doesn't worry about that one. And it uses these 7 to make some kind of data. Well, since we only have 7 spots to put data, there is only so many options. For example, you could have 1 1 1 1 1 1 1, 1 1 1 1 1 1 0, 1 1 1 1 1 0 1, 1 1 1 1 1 0 0, and so forth. If you count all the possible possibilities of 1s and 0s, you get a special number, which is 128. What this means is that we are able to represent 128 different characters. The question is, though, how does the computer know how to interpret this data? Well, it's actually pretty interesting, because if you interpret this data as a character, you get A. But if you interpret this data as a number, you actually get 65. So what that means is there's actually this direct correlation between characters and numbers. A, as an integer, is 65. It's kind of confusing at first, but just think that every character has some numeric value behind it. It just depends on how we interpret that data. If it's interpreted as a character, it'll be A. If it's interpreted as a number, it'll be 65. And every single character is going to have a different number. So for example, if this was 1, the number would be 67. And the character would be C. So hopefully that is a pretty good introduction to ASCII, binary, characters, and all of that good stuff. It's a lot of information for one video, so if it's a little overwhelming, that's okay. Just watch it a couple times. Be sure to click like and subscribe, and share it with all of your friends. Alright, thanks guys. I'll see you in the next video. Peace out. Welcome back everyone to Caleb, the Video Maker 2. In this video we are going to explore the char data type. So let's create a new file. We'll just name this char.c. And we'll do the standard include standard IO. Alright, so how do we make a character variable? Well, we just say char, and then we give it a name. And then we can give it a value. Now remember, when we're working with characters, we always want to use single quotes. So something needs to go inside of those single quotes. But what? Let's use capital A just so we can become familiar with one character. This is the one we used in the previous video, and we learned that the integer value for A is actually 65. And I want to prove that to you in this video, so you know I'm not just making something up. Let's learn to print characters to the screen. We are still going to use the printf function, but we are going to learn a new conversion character. Specifically, it is %c, and then we'll go to a new line, and what are we going to print? We're going to print x. That's a particularly confusing variable name because it's a character itself. I want to make sure there's not confusion. I don't want people to think, hey, I'm going to print the value X. Instead, I'm going to rename this to something else. My character, or my char. Now it's a little less confusing. Now let's run this, make sure it works. And you can see it outputs the character A, just like we wanted. Now, how do we actually take input of characters? Well, I'm going to show you that. Let's go back to our code. And in here, we're going to declare the char variable, but we're not going to initialize it. And now we are going to use the scanf function. And in here, we are going to pass in %c, just like you would expect. The variable we are going to put it in is with the address of operator, my char. Let's try this. When we output it, it'll ask us for a character, even though it doesn't say anything. We never put a prompt. But let's try R. And it outputs R. So it's working. Well, what else do you need to know? Well, to be honest, there's really not a whole lot to it. There is one thing I wanted to share with you guys, and that is the ASCII table. This is the ASCII value for every single character that we can use inside of ASCII and inside of the console. You can see here, this is capital A, and it has the value of 65. As you can see, the decimal version is 65 right there. Now, if you wanted to classify these things, because I know some of you guys love classifications, you could say that the first section of characters are called control characters. Only a few of those are going to be useful for us. I'd also group the last one in here. These codes were for controlling devices such as printers. They're really not used so much today. There are a couple that'll be useful for us. For example, tab, the null character, and I'm sure there's a couple others we might run into. The rest of them, these are considered the printable characters. These are the ones we could actually see. The second table down here is called the extended ASCII codes. That's what I was explaining in the last video, where in some situations, that most significant bit will be used, and this will allow us to have more options. In the next video, we are going to create a program that will actually convert between integers and ASCII. By the end of that video, you'll see how easy it is to work with ASCII. So be sure to check that out, guys. If you've liked this video, please click subscribe, click like, and check out the next video. Thanks, guys, and I'll see you then. Hey guys, welcome back to this video. We are going to continue our discussion on the char data type. The previous two videos kind of laid the foundation for this data type, and in this video, I'm going to be talking about conversion between character data and integer data. So if you remember from the ASCII table, every single character has some integer value. The example that I am trying to help you guys memorize is that 65 is the integer value for capital A. What I'm going to show you in this video is that what value is shown depends on how we tell the computer to interpret the data. So to begin, let's open up this char program that we started in the previous video. This is what we have so far. All we are doing is taking in a value, specifically a character, and storing it in the mychar variable. Then we are printing out that character. To show the correlation between ASCII and integer data, I'm going to rename the variable. I'm not going to change it a whole lot, just completely to ASCII. So I need to change this all throughout my code. I think that'll just make it a little bit more clear as we go on in our code. This first section here, all of this code, this is taking a character and displaying it as a character. But I want to display it as an integer. Before I dive in and do that, I want to add a prompt so the user knows what they're supposed to input. So I'm going to go up here and add a line and say printf, please enter a character. And I'm going to group all of these together just like this. Now, how do we present a character as an integer? Well, it all has to do with the format character or conversion character. Same thing. We are using %c here. Well, you can actually display this as an integer. All you have to do is change that to a %i. So let's save this and I'll show you. You can see I have an error. I did not spell the variable right. So let's go back in our code and make sure I add that s in there. Thank goodness for compiler errors, right? We'll save that. And now let's run it. Please enter a character. We'll put capital A and it outputs 65. So there's proof. I wasn't lying to you. A is actually 65. If you want to try some other characters, you can do that. For example, you could try 6. That value is 54. Now what I want to do is take an integer value and output it as an ASCII character. This would be useful if you're ever creating an app to convert between ASCII and integers or the other way around. So let's go in here and we will create a new variable. We'll just call it integer, and we are going to ask the user for an integer. Now the range we are going to use is 0 to 127. I told you in the first ASCII video that there are 128 different characters that you can use, but one of those characters actually has the integer value of 0, so the maximum is 127, not 128. The next thing, we are going to scan a value into that variable, and we are going to scan this as an integer. So you can use %d or %i. We are going to store that value into integer. Now we need to print it, but we want to print it using the %c conversion character, which is for character printing. Then we need to pass in the variable as an argument. Just say integer right there. All right, let's save this and make sure it works. Please enter a character. A. Please enter an integer between 0 and 127. Let's go with 65. And it outputs A. Now, the input and output is kind of crappy, so let's go clean that up. I'll add a new line here, and a colon and a space there. Now let's run this thing. Enter a character A. 65. Please enter an integer between 0 and 127. Let's go with 94. Now, I want to talk about doing math with characters. I know it sounds kind of odd, but because every character has an integer value behind it, we can actually use them to do math. So let's go back into our code, and down here, let's add to our code. We'll make a variable that is going to store the value of when we add two characters. And we are going to add A, and let's add a tab character, which is represented as a \t. Now let's print this. I am going to print what is being added. So we could say A, which has the value 65, plus the tab character, which actually is the ASCII value 11. And this is where we render it, %c. And then to keep the formula consistent, we're going to put the character followed by the integer value. So in parentheses, we're going to render the same variable as an integer. And then we will put a new line. So this is a little confusing, just the way it's written out, so look through it, make sure you understand what's going on. Now we need to pass in the value, and we do that by putting the maths variable in here twice. That's because the first one goes to the C, and the second one goes to the D. Now there is something wrong with this code, and I actually want to run it to see if you guys can understand what's going on. So let's save it, compile, and run. Okay, so the output, A, which is 65, plus this huge space, 11, equals J, which is 74. The problem is that the tab character is actually getting rendered. It is literally putting a tab. Sort of how we can use a \n to put a new line. So let's go back in our code and figure out how to fix this. If you literally want to put \t and not render it as a tab character, all you have to do is put 2 backslashes. This is called escaping something. So what we are doing is escaping this backslash and saying, yo, this backslash is not being used to format our data. All we want to do is present this backslash as a normal character. Now when we save it and run it, we should get what we expected. A65 plus T11 equals J74. And T, I meant tab. So yeah, guys, that is how to work with ASCII, integers, and addition with all of that. So thank you guys for watching. If you've enjoyed this video, please click subscribe, and let me know if you learned anything that was particularly useful for anything. Some of this kind of seems like, oh, what would we ever really need this for? And you might be right, but I'm sure there is some situation where you're going to be thankful that you understand the direct correlation between ASCII and integers. So thanks, guys, and I'll see you in the next video. Oh, welcome back, guys. It's Caleb from Caleb the Video Maker 2, and in this video we are going to be discussing Boolean data, or Boolean, depending on how you would like to pronounce that. Boolean data is anything that is either true or false. So this is similar to binary, which is in 2 states. You can think of 0 as false, and 1 as true. So let's create a new file that we can use to test some of this Boolean data. Alright, so in here, we are going to create a Boolean variable. So to do that, you put an underscore bool with a capital B. Then you make some variable name, and that is how you declare a Boolean variable. Now, pay attention to the naming convention here. This is what's known as camel case, if I haven't told you guys. Essentially, the first character is lowercase, and then every word after that starts with an uppercase letter. This is one popular way to name things in C. Another is to do underscores, so you could do something like this, but make everything lowercase. Now you're probably wondering, why in the world did I name this Caleb is fat? Seems like an odd variable name. I named this variable Caleb is fat, not because he is, but rather because he might be. I'm not saying, hey, Caleb is fat. I am saying Caleb is fat is either true or false. This is the foundation of Boolean logic. You will find Boolean logic in many subjects including discrete math, computer engineering, computer science, and a ton of other cool useful stuff. Now, we've declared this variable, but how do we assign a value to the variable? In order to do this, we have to ask ourselves, is Caleb fat? Now, I wouldn't go so far as to say I'm fat, but I could use some trimming around the waist. In fact, I had to buy new dress clothes for my videos because I'm so fat. Therefore, I'm going to say, yes, I am fat. To do this, we use a 1. This represents true. Again, if you want to say false, you would use a 0. Now, the only real important number is 0, which represents false. All the other numbers represent true, so you don't have to use a 1 here. If you put any number, it's going to be stored as 1. So I could put Caleb is fat equals 9,001. Now, my fat level is over 9,000. But how do we actually output this data? Well, as always, we are going to use the printf function. And inside of here, we need a format string. We'll start with something like a question. Is Caleb fat? And then we'll just kind of give a key of what values are important. 1 is yes, 0 is no. And the format character we are going to use is actually %i. That's because we're actually using integers. So %i, and then we'll go to a new line. The variable we are going to try to display is Caleb is fat. Now let's save it and run it. Is Caleb fat? 1 is yes, 0 is no, 1. So as you can see, according to my program, indeed, I am fat. Now this is cool and all, but a lot of this isn't very intuitive. For example, if we go back to our code, why in the world does this data type have an underscore and an uppercase B? That doesn't seem to match any of the other things we've learned. Also, using numbers is just kind of weird, like why can't we put true or false, for example? Well, that problem is going to actually be addressed in the next video. So hopefully you guys check that out, where we are going to be exploring even more with Boolean data. Thanks guys, please be sure to subscribe, click like, and as always, I'm not going to check you out, but check out the next video. Thanks, and peace out. Welcome back guys, it's Caleb from Caleb the Video Maker 2. This video we are going to continue our discussion on Boolean data. This file here is the file we ended with in the previous video. So if you have no idea what's going on here, go check out the previous video. If you understand all of this, you're good. The problem that we're having is not that our code doesn't work, but that it's not very clear. The underscore capital B is kind of confusing, and the fact that we're using 9001, I don't really like that. And that's what I'm going to change in this video. There's actually a really easy way to do this, but we're going to have to include another file. So go up to the top and go into insert mode and type in include standard bool.h. This allows us to use new keywords for our Boolean data. So no longer are we going to have to use this underscore bool here. Instead, we can just use a lowercase bool, which makes a lot more sense, because if you think of the other data types, they're all lowercase. Int, float, double, char. Now, bool is not the odd one out. Additionally, we're no longer going to use a number here, but instead we are going to use the keyword either true or false. So let's set this to false. Yes, I exercised since the last video. One thing you need to notice though is that false is not in quotes. It's just a keyword. Don't quote it. This is not the same thing. The way this thing actually works is no different than underscore capital bool. It just makes it easier to work with. In fact, the values stored are still 0 or 1. So we should be able to run this just the same. Let's write it, and we'll compile and output it. And the output is 0 because I set it to false. But we can do more with this. For example, if you come down here, you can put something like this, where in quotes we are going to output an integer and then go to a new line. And the integer we want to output is actually Caleb is fat plus 10. And that seems really, really odd. But what I just want to show to you is that there is a direct correlation between this and a number. False is 0, true is 1. When would you actually do this? I'm not too sure, but just follow along. Let's save this and run it. And you can see down at the bottom it outputs 10. Just to show that it's working, let's set it to true and make sure the output is 11. So when I change this to true, Caleb is fat now has the value 1. So when we get down here, it should be 1 plus 10, which equals 11. So let's try it. And you can see the output is 11. If you're wondering where the extra space is coming from, it's right here. Now, there is not a format character to print out the word true or false, but later on, when we start talking about conditionals, there are ways where we could output Caleb is fat or Caleb is not fat, depending on the value of the variable. But for now, this is very good, and I think this gets the point across of how Boolean data works and how to use it in your program. So hopefully that was helpful for you guys. If you've enjoyed it, please click like and click subscribe, as those two things very much help my channel. Thank you guys, and I'll see you in the next video, where we will be talking about something new. Hello, humans navigating the intertubes. This is Caleb from Caleb the Video Maker 2. This video we are going to be discussing, now I know we've discussed it already, but variables. And the reason I wanted to make a video dedicated to variables is because there's some more information I needed to give you. That being said, I'll try not to be redundant, so this video might be a little bit short. Variables are used to temporarily store some value. So think of them as a box that you can put stuff in, like a number, for example. One thing I wanted to make sure we have clear is the difference between declaring a variable and initializing a variable. Declaring is when you say, hey, this variable exists, such as this. Initializing is when we assign a value to that variable using x equals something. This here is known as the assignment operator. So you can literally think of it as assigning the value 5 to the variable x. That would be the equivalent of putting a value into the box. You can declare and initialize a variable in one step, like this. This is the declaration, and this is the initialization with the assignment operator. Now, you always want to make sure to initialize a variable before you try outputting it or using that variable in some kind of math expression or something like that. If you don't believe that this is important, try outputting an uninitialized variable. So you can see here, we are outputting x and a new line, but if we never initialize this, give this a try and see what happens. You'll quickly find out that uninitialized variables basically just output garbage, and that is not the kind of thing we want showing up in our application. So make sure you always remember to initialize your variable. If possible, initialize it at the same time as declaring it like we did up here. That way you don't forget to do it. Now, the next thing I want to talk to you about is naming variables. As programmers, we are given the privilege to name our own variables. I know, it's crazy. I don't know why anyone would trust us to do something that requires so much responsibility. Thankfully, they created certain rules so we don't make some stupid, dumb variable names. The first thing that you need to know are what characters are allowed. Onyx. So yeah, anyways, you're allowed to use all letters, numbers, and underscores. These are the allowed characters in our variable names. And these are considered different. That's because variable names are case sensitive. That means tacos, and tacos are all different, but they all taste great. Even though you're allowed to make all these tacos, I would highly not recommend it, because that's going to be way too many tacos. We don't want no tacos going to waste. No, but in reality, if you have two variables with the same name but different capitalization, you're probably going to get confused. Unless there is some kind of known convention like, oh, if it starts with a lowercase letter, it means something, and if it starts with an uppercase letter, it means something else. Then you might be able to distinguish. But in general, I would try to just stick with one once you're starting out, and even if you're super advanced to programming, just because it can introduce confusion. If you do need to use the name twice, you might want to consider adding an underscore before it like this. Now there is kind of a more clear distinction between these two variables. Take note that the only symbol we're allowed to use is the underscore. You might get by with using other symbols such as the $sign or something, but the chances are it's not universal and you should just never use any other symbols besides the underscore. You can start a variable with an underscore or a letter, but you can't start a variable with a number. It's just not going to work. Why? I don't know. Now, when it comes to what you should name your variables, you want to keep a balance on length and description. So you want it to be short in length, but I guess you could say long in description, if that makes any sense at all. So I'm going to give you some variable names, and I want you to decide, are they good variable names or are they bad variable names? The first one, amount. Yeah, I would say bad. It doesn't say what the amount is of. Amount of cookies, amount of donuts, amount of, I don't know. Amount sold. That's a little better. I would say that's probably okay. What about this? AMT sold. I personally avoid doing this because I think over time the meaning of shortened words is lost or diminished. So you'll go back and you'll have a bunch of variables like LSW and JPM and you don't remember what any of them mean. And it makes your code harder to read. All you have to do is put 3 extra letters and you can put the whole word. I would say no, but you'll get some different opinions on that one. What about this one? The number of cars sold. The underscores are perfectly acceptable. Some people prefer that naming convention over using capital letters or camel casing. But I generally would say this is a bad variable name. It's too long, it's too easy to misspell. To improve this, you could just get rid of useless words. You're never going to need the, and even this number of is kind of redundant. That's because you can figure that out from the data type. If we have int cars sold, that makes just as much sense as the number of cars sold. And it's way easier to type too. Okay, so this video might have been a little bit longer than I assumed, but I think I gave you guys a lot of useful information. I personally would try to make some variable names and try to make some incorrect variable names and see what the compiler likes and dislikes, all that good stuff. So thanks for watching. If you found this video useful, please click subscribe. And as always, I will see you in the next video. What's happening, guys? It's Caleb from Caleb the Video Maker 2. This video we are going to be talking about operators. Operators are super important in computer programming, so pay attention. At least more than you paid attention in class. Because that's probably why you're looking this up right now. You didn't pay attention in class, right? I know you, don't lie. The easiest example of using operators is in an arithmetic expression, such as 5 plus 5. This plus sign is an example of an operator. Both of these are examples of operands. So the things that the operators work on are called patients. Kidding, operands. See what I did there? Because operators, you know, like, shh. Never mind. So you're probably thinking, like, didn't we discuss math in C like a million years ago? Yes, but there's more to operators than just basic addition and subtraction and even the assignment operator we talked about in the previous video. There is much more. And this video is going to introduce you to that, so as we discuss it in future videos, you have that organized structure. You can categorize things and have a nice organized understanding of C operators. It's also very important to understand that not all operators are used for math. Here is a perfect example, if you guys can even see that. This is the assignment operator, an equal sign. This isn't used for math. This is used to give a value to a variable. Well, there's operators for all kinds of things. When we get into math, there's only a couple operators. If we want to do some more complex stuff with math, for example, if we want to get the cosine of something, this is generally where functions would come in. Operators are usually more for the basic stuff, such as addition, subtraction, division, multiplication, and yeah, we'll get into all that later. I've mentioned it before, I am a firm believer that human brains like to categorize and group everything. So, there are groups or categories for the operators. The first are binary operators. I think I spelled this wrong. There we go. You can see that this has the term bi in it, and this refers to the number of operands. This is one of the 3 classifications, so I will write all 3 now. The first, which only has 1 operand, are called unary. The second are binary, and the third is ternary. So this is 1 operand, 2, and 3. Classifying the operators by the number of operands works great when you're first starting out. But there's actually another classification, I gotta make it even more confusing, right? And this is grouping them by function. Not function like computer science functions that you call, but function meaning what do they do? One example of a classification of this is arithmetic operators. Some of the other classifications of operators are logical operators, assignment operators, and relational operators. And there's some more, but these are the foundational ones. The reason I gave you these 2 groupings, first classifying by the number of operands, and then grouping them by their function or how they're used, the reason I do all that is because I can describe an operator when I'm first introducing it to you, and you can already figure out a lot about it. For example, if I say, we are going to learn a new binary arithmetic operator, you can already figure out that, hey, it's going to have 2 operands, and it's going to be used for arithmetic. So you don't really need to know much more than that except what to put in. So yeah guys, that is your introduction to operators. There's a lot of classifications here. Don't feel like you have to have it all memorized right now, but this is something you should familiarize yourself with. So when someone says, hey, it's a binary operator, you have an idea of what that means. You also need to know these groups, but don't feel like you have to know them right now because we are going to go through all of these. So thanks guys, I'm excited for the upcoming videos because we are going to be learning a whole lot of cool stuff. So thanks, and I'll see you in the upcoming videos. If you want to support this channel, please click like and subscribe. Welcome back everyone, this is Caleb from Caleb the Video Maker 2, and in this video we are going to be talking about the arithmetic operators. And I know we've discussed these a little bit because we've worked with math in C, but I'm going to try to give you a little bit more information, kind of keep you learning things. So to begin, let's create a file. And I guess we'll just name this, I don't know, arithmetic operators. And in here, we'll just write the standard stuff. Now, the arithmetic operators. There are 4 main ones that you need to know. They're pretty easy. You probably already know them. They're plus, minus, divide, and multiply. These work exactly the same as in math class. They just might look a little bit different than what you're used to. Now, this last character is called an asterisk, and you can find that by holding shift and pressing 8. So I like to call it capital 8, but I'm weird. Now, let's assign some data to a variable using some arithmetic expressions. So let's get rid of this junk, and we'll give our variable some real creative name, x. And we'll assign the value 2 plus 3 times 4 divided by 3 minus 2. This huge complex thing here. Now this brings up the topic of order of operations. This is the mathy term to describe which one of these happens first. Well, there's actually a computer science-y term to describe the same thing, and that is operator precedence. So operator precedence means the same thing as what operators happen first. Each operator, you could say, has a precedence over other operators. Alright, so let's try to figure out what's going to happen here. Multiplication and division happens first, and that's from left to right. So we start at the beginning and just start going right. The first time we see a multiplication or division sign is right here. So the first thing to happen is 3 times 4. This means that we could actually group these with parentheses, like this. You can add parentheses wherever you want as long as you remember to close any parentheses you open. Now, pretend that evaluates to some value. It'll be 12. So what we have is 2 plus 12 divided by 3. That division happens next. So we can actually group that. Just like this. Addition and subtraction happens after that. So we start from the left and go to the right. 2 plus whatever this evaluates to. And then once we group all of that, like this, we get that entire value and subtract 2 from it. You don't have to use the parentheses. That's because the operators have a precedence and the computer will work it out itself. But if you can visually see what's happening with parentheses, I recommend you use them. The output of this should be 4. That's because we take 3 times 4 and we get 12, and then we divide it by 3. So basically these 3's cancel. And we have 2 plus 4, which is 6, minus 2, which is 4. If you don't believe me, we can output this, just like this. And we'll save that. Let's compile this. Output of 4. Awesome. You can actually use parentheses in other ways. For example, if we want to create a precedence that is not going to happen by default, we could do that. So if we wanted to say, hey, let's do this subtraction first here. Well, we can do that. First, let's get rid of these parentheses because we don't really need them there. It's kind of clear, so I don't think they're that necessary in this situation. So at the end, we can add our parentheses now. All right, so now what's going to happen is any parentheses are going to be evaluated first. So we get 3 minus 2, which equals 1. Then you're going to have 2 plus 3 times 4. 3 times 4 is going to be evaluated as 12. 12 divided by 1 is 12. And then you add 2 to that. So your value should be 12. Let's check. 14, sorry. There we go. Now, whether you should use parentheses all of the time or not is up to you. If you look at this and you think it's pretty clear what's going to happen, then you're fine. But if you think this might confuse a coworker or another person looking at your code, go ahead and add parentheses here and just make it extra clear. Now, I'm going to introduce you to a new operator, which is always fun. So, this operator is called the modulus operator. And it looks like this. Int y equals 5% 2. Now you can use any numbers you want, and at first, this is kind of confusing. I want you to look at this, and I'm going to tell you that the value of y is going to be 1. And I want you to figure out why. I already told you why, but I want you to figure out the reason why is 1. Can you figure out what this operator does? Well, I'm actually going to be teaching that in the next video. So hopefully that suspense will keep you ready, waiting. And if you want to be notified of when I make new videos, be sure to click subscribe. And assuming YouTube isn't a butt, it will tell you when I create new videos. So thanks guys, and I will see you in the next one. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. And I hope you guys are enjoying the series so far. If you've made it this far, you're probably either A, really enjoying it and learning a ton, or B, you're a total geek. And if that's the case, right on. Okay, I'll stop wasting your time. Let's get started. We are going to be discussing the modulus operator. Okay, so I told you that the result of this expression is going to be 1. But did you figure out why? Well, the modulus operator actually gives you the remainder, and this is for integers. So the best way to see this is to use a really good illustration. One of my faves. Imagine you have a pizza with 5 slices, and you want to share the pizza with your pet rat, Pepperjack. Well, you give a piece to Pepperjack, a piece to you, a piece to Pepperjack, and then another piece to you. Now you have 1 left over. So let's change this code to illustrate our illustration a little bit clearer. We're going to say we have int pieces of pizza, and that's going to be 5. And then we'll have number of eaters. That's going to be 2. You know, you and your pet Pepperjack. Now we are going to have int leftover. And this also assumes you can't split a piece of pizza in half. That would just, mess up all the dimensions and who knows what would happen. So what we need to do is take pizzas of pizza, take the modulus of that, and we'll put numbers of eaters. Oops, it should be number of eaters. And the real reason you can't split the piece of pizza in half is not because of some weird dimension junk. I was just kidding. The real reason is because it's an integer. And integers cannot be split in half or they are no longer integers. So imagine if you take the piece of pizza and you rip it in half, it just melts into this goop and it's no longer pizza anymore. Oh man, my illustrations are always really, really weird and awful sometimes. But that's okay, I like them. Whenever we are using the modulus operator, we have to be working with integers. If we were working with doubles, for example, well, there would never be a remainder. That's because if you took 5.0 and divided it by 2.0, the result is going to be 2.5, and the remainder is going to be 0. The modulus operator literally is useless when it comes to floating point numbers, so you can only use it with integers. Let's print out the leftovers and see just to make sure I'm not lying to you guys. We'll save this, compile, and run, and the output is 1. What are some other cool things we can use this modulus operator for? At first glance, it seems kind of weird, and when would we ever use this stupid thing? Well, there's actually one really good example, which, whether this is a good example or not is ultimately up to you, but you can use the modulus operator to figure out whether something is even or odd. For example, if you have a number such as 17, and you take the modulus of it with 2, the output will be 1. And this has to do with the definition of an odd number. An odd number is 2 times any number plus 1. Let me make these comments so they're not all colorful. Now you don't have to memorize the definition of an odd number, but you can think about it. The reason we have 1 left over is because we're dividing by 2. The opposite of multiplying is division. So if we take the modulus and there's a leftover of 1, we have this plus 1. This is in contrast to an even number, which is something like 2 times any number by itself, just like that. So if you take an even number, such as 18, use the modulus with 2, the result is going to be 0. So later when we talk about conditionals, you can check to see whether a number is odd or even using the modulus operator. And if I totally lost you with these comments, that's okay, just ignore me. So yeah guys, those are the arithmetic operators. These are all binary operators, meaning they work with 2 operands. See up here, we have the operator, and the operands are pieces of pizza and number of eaters. In the next video, we are going to learn a unary operator. So I'm really looking forward to that. Be sure to check it out and be sure to subscribe. Thank you. You know, time is so much more valuable than stuff. Like, think about it. If this laptop got stolen after I recorded all 100 of these, I think I'd rather pay for a new laptop and get my videos back than get a free laptop and remake the videos. You know what I mean? Oh, it's still recording. Welcome back, everyone. This video, we are going to be talking about the unary plus and the unary minus operator. Now, before you close out of this video, just hold up, okay? These are different than the binary arithmetic operators we talked about in the previous video. Yes, there was a plus and minus in those operators, but these ones are not the same thing. So to illustrate this, we are going to create a new file. Alright, so to illustrate my point for this video, we are going to need 2 variables to start with, and then we are going to do some calculations with those variables. The data type for these are going to be integers. The first one is going to be int money, and we'll set that equal to 25. The next will be a bill, and we'll set that equal to 15. So a bill is just an expense. So after we pay the bill, we should have $10 left. You could just as well use double for your data types, but I'm going to be using int in this case just because I think working with ints is a little bit simpler. What we want to do though is calculate the total after we pay our bill. So we are going to make that int total, and we're going to set that equal to money minus bill. So this is essentially 25 minus 15, and that's going to equal 10. But what if we change this a little bit? You know, I like to mess with stuff. You know, I like to mess things up. And you know what? When I get bills, I go to the bill company and I'm like, yo, you're going to pay me this money, right? So if I got a bill for $70, I basically just got paid $70. So if you have no idea what I'm talking about, just follow along, right? I ain't paying no bill. So I am going to make this a negative bill. Now what we have is no longer 25 minus 15. We have 25 minus negative 15, which if you're any good at math, you should know that that is the same thing as 25 plus 15. I know, this is a pretty dumb example, but I can only think of so many examples, so you're just gonna have to deal with it. So let's print this just to make sure that everything is working as expected. And the output is 40, just like I like it. Ain't no one gonna give me no bills. Gosh. Let's go back in our code, because I need to repent. I apologize. This is not really how I go in and pay my bills. In fact, I think it's an honorable act to pay your bills because you are the one who has acquired the bill. But for illustration's sake, let's just go with this. One thing I need to make crystal clear to you, though, is that when you do this, you are not changing the bill. The bill itself stays the same. So what I mean is that if we go in here and we add another printf statement, you could put them together, but sometimes it's clearer just to have two. And what we want to print now is the bill. Let's print it. You can see that the value is still 15, not negative 15. What this shows us is that operators do not always change the value of the variable. Sometimes they do, but not in this case. Arithmetic operators don't change the value either. For example, if I did something like x plus y, after this addition is done, x and y still have the same exact value. As we get into some more advanced operators, there are some that do change the value of the variables. And once we get to those, that'll make a little bit more sense. All you need to know now is that these operators are changing the expression. So if we go back in our code, we are changing this expression right here. The value of the variables kind of just get plugged in. Like I said, the value of money is 25. We're subtracting negative bill. Bill itself is 15. So yeah, guys, that is how you use the unary minus operator. But what about the unary plus operator? Well, it's kind of useless to begin with. I'm not really going to talk about it. It's kind of like in math, if you did something like 25 plus positive 15, the positive there is redundant. It's just assumed. It works the same way in C. There are some uses for the unary plus operator, but they are beyond the scope of this series. If you want to learn more about them, I would encourage you to look them up, specifically the unary plus operator. That will help you expand your knowledge and understanding of C programming. So that's all I got for you in this video. Thanks for watching, and I will catch you in the next one. Hey guys, welcome back. It's Caleb from Caleb the Video Maker 2. Now, continuing from the last video, we are going to be talking about more operators. In the previous video, I mentioned how some operators change the value of the operands. That's what we are going to be showing in this video. And we are going to be talking about two of the most popular and most important operators in programming. So please pay attention. These are called the increment and decrement operators. So whenever you want to increment a value, you can actually use this operator. And incrementing a value actually just means to increase the value by 1. Decrement means to decrease the value by 1. So if we have a variable called pizzas to eat, and we'll set this to a reasonable number, the hard way to increment a value is to do this. Pizzas to eat equals pizzas to eat plus 1. And the way this works is it's going to take the value of pizzas to eat, 123, add 1 to it, and then assign the whole thing back to pizzas to eat. So you end up with 124 in the variable pizzas to eat. But there is a shorthand way to do this. All you have to do is say pizzas to eat plus plus. This is a shorthand way to do just this. This is very good if you just want to add 1 to a variable. This format is a little bit better if you want to add more than 1 to a variable. Let's say you wanted to add 5 to a variable. Up here it would be very easy because you could just say plus 5. But if you wanted to do it with the plus plus, you would literally have to put the statement 5 times. And you get the point. That would just be slow and cumbersome, and we don't want to do that. But whenever you just need to add 1, you're always going to want to use the plus plus, because that is a standard convention in programming. At first it takes a little bit to get used to this, but once you see it 1,000 times, you'll be able to read it as if it literally just says add 1 to this variable. Now this operator, it is a unary operator, which means it only takes 1 operand. The operand is the variable. It doesn't need 2 variables, it only changes 1 variable. Now, I want to play some trivia. Let's play a little game, okay? Let's try to guess the output of some code. Let's get rid of this line here, and then we're going to print something. Well, what are we going to output? Well, we're actually going to make another variable, and we are going to call it output. And we are going to set it equal to pizzas to eat plus plus. And just to make this clear, let's get rid of this line too. And we will also set the value of pizzas to eat to 100. We just want this to be as simple as possible. So I want you to figure out what will happen when I print output like this. I recommend you give it a try. You got 5 seconds. 5, 4, 3, 2, 1, 0.5, 0. The answer is 100. It actually outputs out 100. Why 100? This is one of the trickiest parts to understand about the increment operator. When we do something like this, pizzas to eat plus plus, we are saying we want the plus plus to happen after the value of pizzas to eat is assigned to output. What that means is that pizzas to eat at this point down here equals 101, but it only outputs 100 because the increment didn't happen until after output got the value. To change this, we can actually put the plus plus before the variable. Now, let's run the code and I'll show you. You can see that output's 101. If we put the pluses at the end, you will see that the output is 100. Let's save it. Right there, 100. In addition to the increment operator, there is also a decrement operator, and that just looks like minus minus, and it works exactly the same way. And we need to update this comment. Don't you hate when comments are outdated? All right, let's try this. The output is 100. That's because the decrement doesn't happen until after the assignment. So let's print out pizzas to eat after this point. So pizzas to eat. And also I'm going to change the string here just so the variables don't get confused here. We're going to say this is output. We'll write that and now let's run it. So output is 100 and pizzas to eat is 99. The decrement operator is literally the same thing as doing pizzas to eat equals pizzas to eat minus 1. Just like that. If this stuff is a little bit confusing to you, that's okay. This is one of those barriers you have to get past to become an efficient programmer. Don't worry about it. Just watch this video a couple thousand times and click subscribe. Do a ton of research on incrementing and decrementing. I promise you this is going to come up again, so don't neglect it. Thanks guys, and I will see you in the next video. Welcome back everyone to Caleb the Video Maker 2. Hopefully you guys are quite enjoying this series. I am personally enjoying it quite a bit. So let's get started, okay? So the very first thing I want to do is I actually want to work with the file from the previous video. But I'm going to expand and start introducing some more operators. So if you type in ls, and assuming you've been following along this whole time, the file that we just worked on in the last video was increment decrement. I'm going to rename that to better explain what I'm trying to do. So I'm going to move that, and I'm going to move the increment decrement file, and I'm going to rename it to increment decrement assignment.c. You know, we just got to make it longer and longer. And now when you list your files, you'll see that it is now appropriately named. So let's open that. In here, you can see that we have a value. We're assigning that value to output, and then we're decrementing that value. Now, if you remember, in the last video, I mentioned this was kind of like doing this. You're taking the original value of pizzas to eat, subtracting 1 from it, and assigning it back into pizzas to eat. Well, the benefit of this line is that you can actually decrement by larger numbers. For example, I could subtract, 30. That's way better than having the decrement operator 30 times. This is actually going to come up a lot where you need to decrement by some certain value or increment by some certain value, but you don't want to have to type out the variable name twice and do all this crazy stuff. Anytime you type out something twice, you increase the chance of typos. So I'm going to be teaching you the shorthand in this video. So let's get rid of this line, and we'll also get rid of the output. So now all we have is the pizzas to eat. Now, in any reasonable situation, eating only 100 pizzas, that is totally not enough to fill the average American. So we need to increment that by 100. So the longhand way to do this would be pizzas to eat equals pizzas to eat plus 100. Oh man, I nearly died typing all that stuff. I do not want to have to type that again. So the easy way to do this is to actually say pizzas to eat plus equals 100. That is the same exact thing as this line right here. The thing is though, it takes only one variable name. It takes a little while to get used to this syntax, but once you get used to it, it makes a whole lot of sense. Basically what you're saying is that the new value of pizzas to eat, we're going to add 100 to it. That's all it really means. So let's get rid of this top line here, and let's print the value after we increment it by 100. And to do that, I'm just going to copy this value up here using YY and then P. Perfect. And now let's save it and run it. Boom. There you go. 100, 200. The technical term for this increment operator is called the plus equals operator. Totally didn't forget there for a minute. And it is not the only one of the fancy assignment operators. There's actually ones for other, you could say, other arithmetic operators combined with the assignment operator. So let's go over those now. Pizzas to eat minus equals, that will subtract the value a certain amount. Pizzas to eat multiplied equals, that will multiply the value by some value. So at this point, we add 100, then we subtract 100, and then multiply it by 2. So we should be at 200 if we've done everything right. Next, we have the division equals. So this one will actually divide the value by some number. So we could divide it by 4, and this will give us 50. Now the last one, this one's a little confusing, but once you figure it out, it's very powerful. We're using the modulus equals. So it's pizzas to eat % equals, and then you can divide it by some number such as 5. And this will give us the remainder, and the remainder is actually 0. These operators are great because once you are familiar with them, they more clearly express what you're trying to do. They also reduce the chance of errors. So there's just a whole lot of good things about them. Please try to familiarize yourself with them. And as a last thing, I'm just going to print the value just to make sure I didn't go wrong. All right, let's run this and just make sure we didn't do anything crazy wrong. Okay, we have some errors. Oh, I just forgot a semicolon. So at the end of this, we need to add a semicolon, save that. Got those fixed. Now let's try this. And there you go. The final output is 0. So thanks guys for watching. If you've enjoyed this, please click like and subscribe, and I'll catch you in the next video. Hey guys, what's up? Welcome back to Caleb the Video Maker 2. I just got back from eating some tacos, so I am ready to go. And now my dog is eating his dinner, so if you hear him, don't let it bother you. This video, I am going to be talking about operator precedence. So I've mentioned before that some operators have a precedence over others. For example, multiplication and division have precedence over addition and subtraction. But how do you know? Well, here is a chart that I would recommend. And this also goes to show how slow my internet is. Oh, this is absurd. All right, so this is the page. You can see that everything is kind of grouped into sections. So these are numbered. These have the highest priority or the highest precedence. These have the second highest precedence, and so forth. Things within a group like this, these have the same precedence. So how do you know which one happens first? Well, that is called the associativity, and it says which direction they are evaluated. So for example, if you scroll down here, you can find, where'd it go? Here it is, the addition and subtraction operators. These are evaluated left to right. So you start at the left and go to the right, and you just evaluate them as you see them. Some of them are actually evaluated right to left, and we'll see some of that soon. So if you want to know what has precedence over what, you go in here and you find the operator. So let's say we are looking for the unary plus and the unary minus. You can see that that has a higher precedence than addition and subtraction. So if you're adding something that has a unary minus with it, it's going to be negated first, which means to take the negative of, and then it's going to be added. And if you have an expression that has both a positive and a negative, then it's whichever one comes first from the right to the left is going to happen. So let's see some of this in practice. Let's say we have two integers, x and y, and you can declare two integers just like that. We can also assign values on one line, just like that. Now, these are actually assignment operators. So which one happens first? They're on the same line, so we need to know the associativity. So if we look back at that chart we had, the assignment operator is right here. And obviously, if you have two assignment operators, they are going to have equal precedence. But then we have to look at the associativity, and it's right to left. So that means our expression gets evaluated like this. First, the right side, and then, once that is done, then the left side. Now, obviously, the result is going to be the same either way. But you could think of this as y equals 5, and then x equals y. I'll leave those here as a comment for you guys to see. Now, let's look at a situation where the precedence and the associativity makes a difference. When we have a situation like this, where we have int z, and let's just say y is equal to 2, and x equals negative y plus z. This is that situation I was talking about earlier. And just in case it's driving you crazy, I will minimize this. There we go. If you didn't have that chart, there is essentially two ways this could be evaluated. The first way would be x equals, and then the plus operator happens, so we have y plus z, and then that whole thing is negated, just like this. Or we could have this, where x equals negative y plus z. We'll probably want to give a value to z, obviously, because we can't use it until it's initialized. Let's say the value is 20. This would make the end results be either x equals negative 22 or x equals 18, depending on which one happens. According to our chart, the negation actually happens first, as we mentioned. So the second one is actually how it works. And just to see that this is true, we can print the value of x, like so, and then we could save it. And we'll run this sucker, if I can type it out. And the value is 18. And is that what we expected? Let's go back in our code and find out. Yep, that is so. So what I'm trying to teach you from this video is not that you need to memorize this entire chart. What I'm trying to teach you is that there is a systematic way as to figure out how expressions are going to be evaluated. And as always, if you're unsure of how it's going to work, always use parentheses. You can throw parentheses in here yourself to force certain precedents. So this will automatically make the inside happen first. So thanks guys for watching. Hopefully you've enjoyed this video and this series. If you have any comments, please leave them below. And if not, just click like and subscribe. Thanks, and I will see you in the next video. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. This video is going to be talking about strongly typed and loosely typed programming languages. And I'm going to say how C kind of ties in with all of this. So C is what's known as a strongly typed language. What strongly typed means is that... Goodness, boy! What strongly typed means is that every piece of data has a specific type. You can think of strongly as strict. So C is strict in the sense that when we declare variables, we have to say what type they are. And once we say what type they are, they're always going to be that type. The variable, that is. We can take the value and we can cast that value. So for example, you could do something like this. which will change the 5, which is an integer, to a double, but the actual variable x will always be an integer. To illustrate my point, let's imagine that the only data type we have are strings. So a string is a sequence of characters, such as hello. And no longer do we have data types like integers and double and all that good stuff. In this situation, we would have to represent a number like this. Now what if we said, hey, let's add 5 plus 5. Should this be interpreted as, oh, obviously that's going to be 10, or should it be interpreted as 5, 5? The combination of two strings like this right here is known as concatenation, for a fun fact. You can see kind of how ridiculous this is. Like, why would we always use strings? Well, I was showing that to illustrate what it would be like if we didn't have various data types. A strongly typed language prevents confusion like this because of data types. Now, the opposite of a strongly typed language is called a loosely typed language. Now, a loosely typed language doesn't... Onyx, boy. Boy! Hey, boy. Hey. Boy. Now, a loosely typed language doesn't go so far as to only have one data type, kind of like everything is strings, but they're not quite as strict. So rather than having integers and floats and doubles and signed and unsigned and longs and all that stuff, it'll just have like number. So the data types are much more vague. So to illustrate the difference between a strongly typed language and a loosely typed language, let's consider an example. 1 divided by 3. In C, this is going to equal 0. That's because these are both integers. In a loosely typed language, that's probably not going to happen. The result will probably be 0.333 and so forth. You can see that C is much more strict in that you have to be very specific in what you want to do with your types. This has the obvious downside of weird results like this, but there are a lot of plus sides. If you know what you're doing, there is less chance for unexpected results. This concept altogether is kind of hard to grasp when you're first starting, so I have a beautiful illustration that'll show this perfectly. There is a popular programming language known as JavaScript. JavaScript is one of the most popular loosely typed languages. The way JavaScript considers types is very interesting. In fact, it has its own name that a lot of people call it. It's called duck typing. And don't worry, I'm not going to give a tutorial series on JavaScript right now, but I'm doing this to illustrate the difference between loosely typed and strongly typed languages. This kind of stuff is important to know. So why in the world is it called duck typing? Well, the philosophy goes, if it looks like a duck, if it talks like a duck, it's a duck. The first benefit of this is that a lot of different types can be treated the same because you can treat everything like a duck. But there's a downside in that not everything is going to qualify as a duck in whatever sense that means, whether it be it being a number or a certain type of number. Quack, quack. Quack, quack. Example A. Here is a classic duck. Surely this is a duck. Obviously. Here you can see this one resembles a duck and it looks like it talks like a duck too. So, must be a duck. And lastly, this one, obviously that's a duck. And clearly it's quacking, so must be a duck, right? I hope this example goes to show what duck typing is. In C, this problem's not gonna happen. If something is a duck, we know it's a duck. In JavaScript, we can even have functions expecting a duck. So it's like, yeah, they're gonna pass in a duck. And this language is so loose, you could pass in a potato and it's not gonna care. So you have to do all these extra steps to make sure you're getting what you're expecting. When it comes to types, you can't always be sure the type is in the right form. We could have the form in a duck, the Mona Lisa, or an alien. Well, I mean, a duck and a duck, right? In C, these would all probably be different data types, but it's not easy to convert between the three. Because of this, we need typecasting. Typecasting is used to convert between data types. This is how I feel a lot of people approach finding a mate in life. A girl will say something like, oh, he looks like a nice guy. He says nice things to me. Therefore, he's a nice guy. Until you figure out he's an alien come to eat your life. So when it comes to finding your love, do not be loosely typed. Simple as that. So yeah, guys, that's all I got for this video. Hopefully the illustration helped you clear this out in your brain. In the upcoming videos, we'll be talking a little bit more about data types and typecasting, and we'll be getting into more depth with that. So if you've liked this video and this series, please click like, subscribe, and I will see you in the next video. Thanks for watching, guys. I really appreciate it. What's up, guys? Caleb the Video Maker 2 up in the house. This video we're going to be talking about typecasting. So in the previous video, I mentioned how C was a strongly typed language. The reason I taught you all of that was primarily so you would understand the content in this video. So we need to imagine the C programming language as an old grumpy man. You owe this man $1. So you go up to him and you're like, hey man, I finally got your money. Here you go, here's 4 quarters. And 4 quarters are going to add up to be $1. But the problem is, you didn't borrow 4 quarters from this old man. You borrowed a dollar bill. So he was expecting a dollar bill. And this, my friend, is unacceptable. So he beats you over your head with his cane and says, yo bro, give me my money, even though you gave him the correct amount of money. You're probably wondering what this has to do with anything, but it'll start to make sense in just a minute. Essentially, he wanted $1, but you gave him $1. And it seems like the same thing, but if you think about it, the data types behind these numbers are different. This is considered an integer, and this over here is considered a double. So to fix this problem, you can go over to the bank and exchange your quarters for $1. So you hand your quarters in, and out comes $1. Now that you've got an actual dollar bill, you can go back, give it to the old man, and he's happy. In computer science terms, you could say that your dollar was typecasted to $1, and this one being of a double data type to an integer data type. You probably could have gone without the story, but the moral of the story is that C is very picky when it comes to data types, so we often need to typecast things. There are 2 main categories of typecasting, implicit and explicit. When it comes to implicit typecasting, this is something that can happen automatically. We don't have to tell the computer to do anything, and you can think of the result as being lossless. So when I say lossless, essentially what I'm saying is you could typecast an integer of 1 to a double of 1.00, and you can see you didn't lose any data at all. You're essentially storing the same exact thing, just in a different data type. The other type of typecasting is explicit, and what that means is you have to tell the computer to do it. You explicitly say, yo bro, I want you to typecast this. And you can think of this as lossy, I think is the word. You can imagine starting with a double of 1.85, for example, and typecasting that to an integer of just 1. And you can see you've actually lost some data. That's why it's explicit. You have to tell the computer. The computer doesn't just assume what you want to delete and all of that. You have to be very specific and say, hey, I wanted to typecast this value to an integer. It doesn't happen automatically. A great example of implicit typecasting is if you do something like this. You can see in this situation we are assigning an int to a double, so it's automatically going to get stored as 1.0. I'm sure you really want an example of an explicit type conversion too. So an example of that is if you have a value such as 3.5, wrong side, and before that, in parentheses, you put the data type you want to convert it to. And this is going to convert this value to 3. We had to specifically say, hey, we want to convert this. The next video is going to go over examples of this concept and also go over some problems you're probably going to encounter and how to avoid those problems. So thanks guys, please be sure to subscribe to support this channel, and if you enjoy this content, please be sure to subscribe to support this channel. Thanks. And don't forget to subscribe to support this channel. Alright, bye. Hello world, welcome back to Caleb the Video Maker 2. This video we are going to be talking about implicit type promotion. And I know, it's a bunch of big words, so let's break this down. But first, let me advertise the previous video. The previous video is going to give you the foundation to understand the content in this video. So make sure you go check that out. So to get started, we're going to create a file, and we will just call this implicit type promotion.c. So we set up the standard beginning file, and now when you start to study implicit type conversion, I can guarantee you there is a certain topic you are going to come across. And that topic is called promotion. And I have an article to share with you guys. Here is an article that talks about implicit conversions. And inside of this article, there is a section on promotion. And you can see there's scattered throughout. This promotion section talks about what data types can be converted to other data types without loss of information. I'm going to give you an example of a cast that does not lose data. So let's get rid of this article. Let's create a float variable, and we'll give it the value 50.0. Now, if you want, you can put an F here just to specify, hey, this is a float. It doesn't really matter though. If you don't put it there, it'll get stored as a float. So either way is fine. Now, let's print this value. And we want to print this value as a floating point value. And the value we're going to pass in is x. Now, the interesting thing here is that printf takes a double. What that means is that when this function was created, let's say it's down here somewhere, just as an example. It was probably way more complicated than this, but just for simplicity's sake, pretend this is the printf function when someone created it. So when someone created this, they accepted arguments into what are known as parameters. So the parameters are the variables that store the values passed into the function. So in this situation, this gets stored somewhere, and this gets stored somewhere. So the parameters might look something like this, for example, but don't really worry too much about it. I'm just showing this so it makes more sense. Essentially, this argument gets stored in this parameter. This argument gets stored in this parameter. The data type of the parameter is double, but we are passing in a float. So in this situation, you can say that the x is promoted. He used to be a float, but now he's a double. But do keep in mind that this does not change the original data type of x. X will always be a float. But in this situation, this x is a different x. So we could actually rename it just to make it a little more clear. Okay, so now x is promoted, and what that means is that the value of x is stored as a double in pizza. Essentially, the value of x, 50.0, is stored as a double. You can use the %f conversion character for both floats and doubles. So if we went up here and made this a double, well, the same exact thing is going to happen. The reason that works is because in this situation, we would take the value of x and store it as a double. So either way, we're working with a double. So we don't need two conversion characters. It's always going to be printed as a double. When we use this %f, we're basically telling the printf statement how to interpret our data. And it only makes sense to have one of them because no matter whether we put a float or a double into the function, we're going to get a double. The other common example of implicit conversion is when we're doing assignments. So for example, if we did 50.0 with an f, well, that is a float value. The f at the end is basically saying, hey, here's a constant that is of the data type float, and it's getting stored as a double. But the cool thing is that a float can fit inside of a double because a float is a smaller data type than double. This is a super simple example, but unfortunately, when we're converting data, it's not always so easy and we risk losing data. And that situation of losing data is often caused by explicit typecasting. And that is what we're going to be talking about in the next video. So go check that out. Thanks, guys, and I will see you in the next one. If you've been enjoying this series, I do ask that you subscribe to support the channel. All right, peace, guys.
Welcome, world, to Caleb the Video Maker 2!
Okay, let's get started. We're going to be talking about typecasting. Now, I started talking about this in the previous video, so make sure you watch that video. But we're going to be covering some more stuff and go over some examples in this video. So let's create a file. Now you know I love my pizza. So let's make a variable. We'll just call it int slices equals 17. So that's the number of slices of pizza, of course. Now, unfortunately, you have to split this pizza with a friend. So let's create a new variable, and we're going to call it a double. And this is going to be set to slices divided by 2. In this situation, we are splitting the pieces of pizza with our friend. And we're trying to figure out how many pieces each person is going to get. Now, I know this issue came up in a previous video, but we are going to do a quick review. You see, in this situation, slices is an integer from right here, and 2 is an integer. That means the result is going to be an integer. There are 2 ways to fix this. The first way is to add 0.0 to a constant. This will work if we just put 0.0 right there. But the problem is this is not always going to work. For example, let's say the value 2 comes from a variable. So let's go up here and create a new variable, and we'll call it people. And then in our calculation, we have divided by people. Exactly the same thing. But now in this situation, we can't just put .0. It doesn't make sense. Just to show that, I'll prove it to you. Let's save it. And you can see when I compile, there is an issue right here. So basically the compiler looks at that and is like, what is this garbage? This is not code. So we need to figure out a different way to do this. So the second way to do this, the one that's a little bit more useful, is explicit typecasting. So to do that, all we have to do is put a cast before one of the variables, just like that. And now when we compile, you can see there's no compiling errors. Now the important thing to know is that typecasting does not affect the original variable. People is still equal to 2. The casting here is actually just another type of operator. You can think of double as a unary operator that does not change the value of the variable. Essentially what I'm trying to say is once you define a variable as a certain type, for example in this situation it's an integer, you're stuck with that data type. Another thing with the fact that this is a unary operator is that it only works on one operand. So what operand does it work on? For example, let's look at our code here and let's change a little bit. I want to put this at the beginning. So we're going to put it over here. This operator has a precedence just like every other operator. So you need to ask yourself, is this double going to work on this or is it going to work on just this? And it ultimately comes down to, does the division have higher precedence or does the typecasting have higher precedence? If the division has higher precedence, we're going to have 17 divided by 2, which is going to be an integer because they're both integers, and then we're going to cast it to a double. If that was the case, essentially it would look like this, if we had to make it very clear. But that is actually not the way it works. The way it works is it actually has higher precedence than the division operator. What that means is that the double typecasting works on the operand immediately to the right. If you wanted to force it to be the other way, yeah, go ahead and put those parentheses back in. But this is not going to give you the result of 17 divided by 2 as what it should be, which would be 8.5. It would actually be 8.0. That's because we would get 17 divided by 2, which will be evaluated as 8, and then we're typing 8 to a double. So if you want to visually see the correct way of how this works, it would be like this. Boom. Double is affecting just the operand to the right. So just to show the difference, let's output some data, or data, if you're fancy. So we are going to print half the pizza. Now, as always, we need to put this inside of a format string. So we'll throw that in right here. And this will be printed as a double. And then a new line, save, and we'll compile this and output it. and you can see that the result is 8.5. If we do it the other way, where we take this parentheses here and move it to the end, now we save it and run it, look what happens. The result is 8.0. Alright, this video is not over. I still have some more information for you guys. Specifically, I want to have some trivia. So let's make some more code. Double C equals 25 divided by 2 times 2. And now we're going to say double D equals 25 divided by 2 times 2.0. And I want you to guess what this is going to output. All right, so here is our code. What do you think this is going to output? Great, yes, you're right. I'm just playing. Let's see. All right, let's compile and run. Okay, so the first number was from the previous junk we were working with. And then we have 24.0 and 24.0. Let's figure out why. Let's go back in our code. Essentially, what I'm trying to show here is that just because one of the values has a 0.0, essentially it's a double, doesn't necessarily mean all of the arithmetic is done with double arithmetic. It's step by step. So in the first example, we take 25 and divide it by 2 as integers. So the result is 14. Then we multiply it by 2, which is 24. And then we take 24 and store it in a double, which is 24.0. Now for the next one, we do the same exact thing. 25 divided by 2 as an integer, which is 14, times 2.0, which is 24.0. It has the extra 0 on there because it's a double. But we store it as a double, so it doesn't really matter. So essentially, the result is exactly the same. So just because one of the operands in your entire arithmetic expression is a double, doesn't necessarily mean you're going to get the results you're expecting. Make sure you watch every single step. Another thing that you need to remember is that the decimal is always truncated when you do integer division. So if you got something like, let's just say you have some crazy math, and you end up with 0.999999, and then you convert this to an integer, the result is going to be 0. Additionally, if you had something like 23.98999, whatever, that is going to be truncated to 23. So hopefully all that information was helpful, and if you knew all of it already, well then hopefully it was a great reminder. Thanks guys, and I'll see you in the next video. If you've enjoyed this, please be sure to subscribe.
Welcome back everyone, it is Caleb, and this is your C programming tutorial series. Now I admit it has been a long time since I've done this series, so it may take me a couple minutes to get back in the hang of things, but fortunately for us, this video is going to be a review of the last 40 videos. So I believe that having that information down is essential to go forward in making more complex programs. You're going to want to have that information down pretty good. So this video and the upcoming videos, I'm going to have some miniature quizzes for you guys. I thought I'd switch it up. I don't think I've ever done anything like this, but essentially I'm going to ask you some questions, wait a couple seconds, and then tell you the answer and tell you why. First question is, if we have something like this, 5 plus 5, what is this entire thing called? So that's one question. Another question is, what is this called? And also, what are the 5s called? So there's kind of 3 questions here. The answer. So the entire thing is called an expression. The plus sign is an example of an operator, and the 5s are what are known as operands. The operator does something with the operands. In this case, it adds them together. An expression gets evaluated to some value, in this case, 10. What are the 3 groups of operators? Now, if you're not really sure where to start, the groups are by how many operands they have. Okay, so the answer is unary, binary, and ternary. So this is 1 operator, this is 2, and this is 3. What do you call a language if it does not care about extra spaces between commands? The answer, white space insensitive, where white space are spaces, tabs, and new lines. Now where those extra spaces do change things is if you're trying to do it inside the middle of a keyword. For example, if you had if like this, it's not going to work. Or if you're within some kind of string, well, any kind of space here is going to be inside of that string, so it's not going to be disregarded. This question's a little vague, but let's say we have something like this. What is this called? The answer, variable declaration. When we have a variable declaration, we're literally just saying, hey, this variable exists, but we're not assigning anything to it. When we do something like this, after that, what is this called? This is called a variable initialization. And as a reminder, you can do this on one line, like so. All right, so what is the word used to describe the way you type out commands and where curly braces go and all of that stuff? The answer is syntax. When you go from one language to another, you'll often have the same capabilities, but you might have slightly different syntax, so different things might go different places. Okay, so what are printf and scanf examples of? The answer, they are examples of functions, specifically I/O functions. So I/O is short for input output. Now when we put something into this function, that process is called passing. And the thing we pass, goodness Onyx, what are you doing? The thing we pass in is called a, or an, the answer, argument. And that will be assigned to a parameter variable. So often you'll hear argument and parameter. And that is just referring to the data passed in and used within the function. That's all I have for this little quiz video. In the next one, we're gonna have some more questions for you. Hopefully this has been helpful, and let me know if you like these quizzes or if you just think they're a big waste of time. Thank you, and I'll see you in the next one. Oh, and guys, please be sure to subscribe, as that'll help me out. All right, thank you. Welcome back to your second quiz. This video is going to start off right away. So what is casting? The answer is that casting is a way to change the data type of a value. For example, you can have something like this, and we can cast that to some data type. Now, when we do this, is this value here truncated or rounded? And also, what's the difference? Truncated is when we just crop it off and keep whatever is right here. Rounded is where we either go down or we go up, depending on the value right here. The answer is that it will be truncated. So even if we have 5.999, if we cast that to an int, it's going to be 5. If you have a character array, what is the last thing you put in here to make it a string? We've only talked about this very briefly, so if you're not sure, that is okay. It is called the null character, or the terminating character, or the null terminator. And if you were to write it out, it would look like this: a backslash and a 0. Okay, so the next question. What's the difference between a primitive data type and a complex data type? The answer is that primitive data types are foundational to the language. They come pre-created, and you can use these primitive types sort of as building blocks to make more complex data types. For example, you could have a complex data type such as coordinate, which is made up of 2 integers, x and y. You could even go more complex than that and build something like a linked list or some other data structure. All right, when you are printing, what is the format character for an integer? The answer is a %d or a %i. What are the format characters for floating point values? The answer is %f, %g, or %e. When using scanf, what is special about the value you pass in here, known as the argument? You have to use a special operator before the variable name, and that is the ampersand. It looks like, oh, I can't draw this. How's it look? Sort of like that. And that is known as the address of operator. So what that means is we're passing the address of whatever variable we're throwing in here. What is the ASCII code for A, capital A specifically? If you don't know, you could look up the ASCII table, or you could start printing different characters as integers. The answer, though, is 65. What is the difference between A and A? like this. Well, these are both considered constant values, which just means they're just a value. But the main primary difference is you can notice the difference in the quotes. So this is a single quote, and this is a double quote. When you have a single quote, you're working with a character. And when you have double quotes, you are working with a string. So if you have a function that takes a string, you could just pass in an A like so. That's all the questions I have for this video. Please be sure to check out the next one and be sure to subscribe. Welcome back, everyone. This is your third quiz video before we go on to some more advanced topics, more like intermediate. The first question is, what is this operator called and what does it do? The answer is that this is known as the modulus operator, and it does so many magical things. But at the foundation is it gives you the remainder of some division. So if you take 5 modulus 3, that's like doing 5 divided by 3, and you get 2 left over. So the answer would be 2. This can do a lot of crazy things and is actually used in a lot of algorithms out there. When you first learn about it, it's like, well, that seems kind of useless, or you might use that rarely, but it's actually a pretty cool operator. Next question is, what is the difference between I++ and ++I? The difference is when the thing gets incremented. If we used this, it's going to use the value of I first, and then it's going to add 1 to the value of I. If you do this, it's going to add 1 to the value of I first, and then it's going to use I. So this is important when you're doing this inside of a function call, for example. You want to make sure the correct value is being passed in, so just be really careful on which one you use. Okay, next question. What does this mean? If we have j plus equals 5. Well, this is actually like doing this. J equals j plus 5. It's going to add 5 to whatever the value of j is. Or you can think of it as going j++ 5 times. It is a shorthand, and you can actually have a lot of other shorthands, such as multiplication followed by an equals sign, which is going to multiply a value by some number. The next question is, what is the word used to describe what order operators are executed in? So if you have multiple operators in a row for some giant expression, how do you know which one to do first? What is the term called to decide which one goes first? The answer is precedence. Different operators have higher precedence. In this situation, these operators have higher precedence than these two. Okay, next question is, what is the word used to describe if you have 2 operators of the same precedence, which way they are evaluated, either left to right or right to left? The answer is associativity, which makes a lot more sense when you just go through an example. If you had 5 times 2 divided by 10, we know that we're going to do this first and then this. But if the associativity was the other way around, it would be like this, where we do this section first and then this. Different operators have different associativity. So just to make sure you understand this, if I asked you what is the associativity of the division operator, what would you say? You would say left to right. Okay, so this one's going to be a fill in the blank. C is a blank typed language. So this is dealing with the data types. The answer here is strongly. And what that means is it's really strict when it comes to data types. And every single value has to have a data type. Okay, so now let's say we want to do a little bit of I/O. We want to take some input, do some output. How do we go about doing that? And no, I'm not looking for printf and scanf, but those are related. If we wanted to use printf or scanf in our code, what do we have to do? The answer is we have to have an include statement at the top of our file. That would look like this, where this is the file allowing us to use those functions. Now, what if you wanted to use the bool data type? What would you include then? Well, the include would look like this, where this allows us to use the bool data type. All right, that's all the questions I have in this video. And as always, I just ask that you subscribe to support this channel. Thank you.
Welcome back, everybody. It has been such a long time since I've worked on this C programming series, so I am glad to be back because I promised you guys I'd have these videos out, and here I am to fulfill my promise. So where did we leave off? Well, so far I've covered a bunch of basic stuff, and we've done some question and answers in the previous videos, and now we're doing a little coding challenge. And this challenge is relatively easy. I mean, if it takes you some time, that's okay, but if you're really struggling to grasp the concepts with the programming here, then that is an indicator that you probably need to go back, make some flashcards, and make sure you know what you're doing just a little bit more before you dive into some more complex stuff coming up in the next videos. So what is this here? What is going on here? So this is a text editor. It's sort of like Vim, but I decided to try a different text editor so you guys can get some more experience with different text editors. So you're still welcome to use Vim if that's what you would prefer, but this here is Visual Studio Code. It allows you to open your code in a more conventional manner where you can click around and you don't have to worry about commands. So whatever you prefer, that is okay. I'm not going to judge you. So once you get Visual Studio Code downloaded and opened, you can go into the help and you can type in terminal, and you can get this integrated terminal. And what this is going to do is allow you to use the terminal inside of the application. So now you can just worry about doing everything in one location, and it's a lot more organized. And I also figured out that this is a great way for me to advertise. So if you're fresh to this series, please be sure to subscribe because I'm trying to grow this channel, and it would just be really appreciated. So here is the challenge. I want you to create a program that takes two doubles as inputs and uses those to calculate the hypotenuse of a right triangle. So just so you can visualize this, if it's been a while since you've done some math, this is a right triangle because it has this box here, 90-degree angle. And we are going to pass in the values of A and B, and I want it to output the value of C. You can do this with this formula here, the Pythagorean theorem. So in order to do that, you're going to need a square root function. And I'm not going to tell you a whole lot about it, but you'll want to look up square root, SQRT. You're going to want to figure out how to use it and how to include it in your coding projects. And I'll just give that as a little hint because I want you to try to figure it out yourself. So what I'm going to do is I'm going to jump to the answer and I'm going to walk you guys through it. So be sure to pause the video here and try to figure out how to get some progress on this application. So let's do this. All right, so here's the solution. And as you can see, I zoomed in a little bit more, but I'm also going to clear up the screen a little bit. So if you ever need to access your files, you can click this right here on the left hand. Now, I'm going to hide that because we don't really need it and the file is open. And I'm going to keep the terminal open. So that's the first thing you're going to want to do is you're going to want to create a file, name it something, codingchallenge.c, and you're going to want to do the standard include standard io.h. But you're also going to need to do this include math.h, and this is what's going to allow you to use that square root function. The next thing you're going to do is have your main function, and you're going to have two variables in there, a and b. So those are the shorter sides of the triangle, and we need to calculate the larger side. So the first thing we do is we put some output to tell the user what to do. With this app will calculate the hypotenuse of a right triangle, and then it's going to say enter the first value. And it's going to read in these characters as LF format character, which is the double format character. So we are reading these in as doubles. So we're allowed to use decimals. The next thing we're going to do is get the second number using the same thing, scanf, and we're going to assign this one to B. So the first one was to A, this one's to B. The next thing we're going to do is calculate C. The way we're going to do this is with this formula here. We're going to take the square root of A squared plus b squared. And that's simple to figure out using the formula from earlier. Let me get Chrome back up here. So if you wanted to make this just c, you would take the square roots of both sides, and the square root and the squared would cancel. So you would have c equals the square root of a squared plus b squared. So the square root of a squared plus b squared. Simple as that. And then what it's going to do is it's going to print the hypotenuse using the printf, and we're passing in c as an argument. And then it's going to return 0, which means the program is over. So we can execute this just like any other way with the console. We just need to go to that directory. So we, this one for me is in documents. Oh, okay, I guess I'm already there. So I traveled to users, Caleb, documents /C. So once you're there, you can just run this like gcc codingchallenge.c. And you can see it works. And inside of our files, you can see that it's actually going to create a.out, which is the output name for our file. So everything works exactly the same inside of this code editor. So no worries about that. So to run this, as usual, /a.out. And it's going to ask for the values for the shorter sides. A very simple example that you can use to make sure that this is working right is you can use one side being the value of 3, the other side the value of 4, and the answer should be 5. So if that's the answer you're getting, then you have done the math correctly. The reason why is because it's going to take 3 squared, which is 9, 4 squared, which is 16, add those together, which is 25, and take the square root, which is 5. And here is an example so you can visually see that. One side being 3, the other side being 4. The length of this, the third side, is going to be 5. Now, obviously, this has taken us a while to get here. This is video 40-something, and we are just doing basic input and output. In a conventional college or something, this might be brought up a lot sooner, where you have to create an application like this on the first week. But I believe we are in a much better stance than most because we've done a lot of the extra work to really understand what's going on behind the scenes and how to structure our code in a clean, proper manner. So if you were able to do this application fairly simply, then I would say that you are in the good stance to move on to the next videos where we are going to get into some more advanced concepts. So thank you guys for watching. I really appreciate it. If you've enjoyed this content, I just ask that you would subscribe, and please be sure to show your support by liking this video, as that really helps my channel out. So thank you guys. I will see you in the next video. Welcome back, everybody. This video we're going to be diving into a new topic. About time, right? So far we have gone over basically all the beginning stuff of C programming. So I would say if you were able to complete the coding challenge in the previous video, you have a pretty sustainable beginner foundation. But really you can't build awesome programs with the skills you have so far. You need more complex programming concepts. Specifically, we're going to be talking about branching. And essentially what branching is when a program splits based on something. So right here, this branching point, we're going to put an expression. And I think I told you guys this, but if I didn't, I'll just go over it one more time. An expression is something that gets evaluated to a value. So we are going to be working with what's known as Boolean expressions. And a Boolean expression is going to evaluate as true or false. So you can see that there's 2 states, true or false. So we can ask some question. That would be the expression. If it's true, we're going to go down one branch. If it's false, we're going to go down another. And this is the basis for what's known as Boolean logic. Boolean logic is integrated into a lot of fields. This is not just computer science, but computer engineering is huge with Boolean logic. And essentially it allows you to build complex expressions that will ultimately get converted or evaluated to true or false. And we're going to talk about that in this video, which is going to build the foundation for more complex programming where we can branch, do loops, all kinds of cool stuff like that. So let's get into it. To begin, we need to make an expression. So let's say we wanted to build an application where you had to be at least 13 for people to use. Well, you might have a variable age. And you would say age is greater than 13. And you ask this question, is age greater than 13? And if it's true, then you let the person in the application. If it's false, then they do not have access to the application. So this is a simple expression. But this is not really enough to even make really complex applications. This will allow for simple branching, and in fact, you could basically do any branching you needed because you could branch multiple times, like this. But sometimes it's easier to do what's known as a compound expression. So a compound expression is going to ask 2 questions and combine them together, and will ultimately come down to true and false. and we can write all this out in what's known as a truth table to visually see what's going on. So let's make a truth table. And truth tables are huge when it comes to Boolean algebra or Boolean logic, as it allows us to easily come to conclusions with what the values are. So we start with our first expression. Age is greater than 12. I think it was 12. Basically, if you're a teenager, you can access this application. But what if we wanted to only let females use this application? Well, then we would do something like sex is female. And now we want to evaluate on both of these. So what we do is we create a table and we put all of the possible values for these things. And then what happens is at this final column, we have the combination. So age greater than 12 and sex is female. This double and sign is known as a logical operator, and it allows us to combine multiple expressions. So now what we do is we write down every single possible value for the left-hand side. The final right-hand column, that's just the result. So we'll have to do some thinking for that. So what we do is we start with true, 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 false, false, true, and false, false. And then we think about the result. So if with and signs, if they're both true, it's true. If one's true, one's false, it's false. If one's false and one's true, it's false. If they're both false, it's false. And this is kind of like the structure: true, false, false, false for the ands. So we basically just put the end result of combining these together. And this allows us to see how our stuff is going to be evaluated. So the only time that we're actually going to be able to get access to our application is in this case, when age is greater than 12 and sex is female. Obviously, it's really simple to see in this situation, but sometimes we have more complex expressions that are combined together using operators. And in that situation, these truth tables can be really helpful for debugging and building out our application to figure out what our branching is going to look like. So in this situation, in our branch, this case right here, this would be one branch, and then any of these three would be the other branch. Just so you can kind of visually see that. One of the key takeaways here is to realize that the end result is always true or false. So it's a single value. This large expression gets evaluated to a single value, which is what we ultimately branch on, whether the answer is true or false. All of this concept that we've talked about so far can be applied to what's known as control flow. A control flow statement is basically a computer science term for that branching or looping. So within the control flow statement title, we have if statements, we have fors, we have whiles, any kind of structure that allows us to make more complex applications. So in the upcoming videos, we are going to begin our discussion on control flow statements and how to use these expressions that we've built inside of these control flow statements to make more complex, awesome applications. So yeah, that was cool. Thank you guys for watching. This stuff is really fun, and this is really super useful information just to try to think about this at a more conceptual level when we do truth tables and all of that, because not only is this applicable to computer science, but if you ever do computer engineering, you're going to have logic gates like such. This is an example of an AND logic gate. You're going to have OR. All of these have truth tables that represent their values and the end result. And you can combine all these operators, what are known as logical operators in computer science, you can combine them to make circuits. So it's not just computer science, but also computer engineering, and I'm sure lots of other fields. So really cool stuff. Thank you guys for watching. Hopefully you've enjoyed it. If you have, please be sure to subscribe as I'm trying to grow my channel and whatnot. So thank you, and I'll see you in the next one. Welcome back everyone to your C programming series. This video we are going to be talking about your first control flow statement. So control flow statements are loops and conditionals, anything that can branch our program. And these are like the foundation for more complex applications. So literally, you're going to see these in every application you work in or work on. If you don't know what these are, you better get used to them. So the first one we got is the if statement. So the if is really simple, but if you're new to programming, it can take some time to really wrap your brain around how it works. So the way it works is you just type out if. And then, now I'm gonna get some specifics on what these characters are called, because I see a lot of people say these things wrong, and it's not like a big deal, but just for your sake. So then you put a left parentheses, and you leave some space, because we're gonna put some stuff in there, and we close it with a right parentheses. Then what you do is you use a left curly brace and then a right curly brace. And then inside of here, you can put your code. By the way, these are called forward slashes, not backslashes. They're forward slashes. Yeah, that's a big one. Okay, they're forward. So you got that down, cool. So now that we know what these characters are called, we just gotta describe what's going on here. Inside of these curly braces, we are going to put an expression. And if you remember from the previous video, what's going to happen is that this expression gets evaluated, and it's going to evaluate to true or false. So this is a Boolean expression. If the expression evaluates to true, we are going to execute everything within these curly braces. If it's evaluated to false, we are going to skip these curly braces and continue the evaluation of the code beyond these curly braces. So just so you know, this is often called a conditional. And the reason it's called a conditional is because this code here only executes if a certain condition is met. And that condition is this expression being true. And we will be going into some examples in C programming in just a little bit, but for now we're just trying to get the concept down so you really understand what's going on here. So this is a conditional, once again, conditional because this is only going to execute on some conditions, which is when the expression is evaluated to true. Some people call this section of code a code block. And the reason it's called a code block is because it's within these curly braces. So this here, it's like I'm using a curly brace to put the curly braces in it. So this here is often the start of a code block. And the thing that makes it special is really that things inside of this code block are a little bit different than things outside of the code block. And it really has to do with something called scoping. And this will make a lot more sense when you get more into variables and their lifetime and all of that. But essentially, if you put something in this code block, like defining a variable, like let's say we do int x equals 5, well, this is inside of the code block. This is inherently different than if we did int x up here. These variables would have different scope depending on where you define them. But don't worry too much about scoping, we'll get into that later. Just know that that is the reason why an if statement has those curly braces. It's because we are creating a new code block to execute some section of code. To make this easy, we are going to first look at the easy cases. So for example, if we had an if statement, and inside of the parentheses, we just put a Boolean variable, such as Caleb is fat. All right, so whether that's true or false is a little subjective, but this can kind of illustrate how an if statement works. And because this is a Boolean variable, we don't have to do any kind of comparison. We don't have to say Caleb is fat is true or Caleb is fat is false. All I have to do is put that variable there. And essentially, this is going to either look like this: if true or if false. because it's going to get evaluated. This is essentially going to be replaced once the code is executing with the value true or the value false. And the curly braces are only going to get executed on the true case. So the key takeaway from this, and this will come in handy, is that if you have a Boolean variable, you do not have to do anything except put the name of the variable in those parentheses. That is enough to have it evaluate to true or false. And that's the magic of an expression. It's kind of like you can fill it in with values and it just kind of magically evaluates to something. Sort of how 5 plus 5 will ultimately evaluate to an integer. And then anywhere an integer is expected, this 5 plus 5 will work. So the same thing here. Because the if statement expects a Boolean, we can pass in a Boolean variable and it works. So that's really cool. So what we can do next is if we want to make our application a little bit more complex, we can make an if statement, use our curly braces, and then put some code in here such as exercise. And this function here, this could just be a custom function that we create. And it doesn't really matter what it does, but this kind of illustrates the purpose of an if statement. Because if the person is not fat, you might not want to exercise. I mean, in real life, yeah, exercise is great. But maybe this is an extreme form of exercise to really lose weight or something. So we only want the person to exercise if they're overweight. That's how an if statement works. If the person is not overweight, then this never gets executed. You can basically just pretend it's not even there and it will continue going down here. So that's that. That's an if statement, the very first control flow statement. In the next video, we're going to be talking about something else. Specifically, we are going to be doing some of this stuff in code, in C, so now we can actually apply what we've learned. So check it out, guys. It's going to be really cool and hopefully really helpful. Thank you, and I'll see you in the next one. Hey guys, it's Caleb coming at you, and welcome back. This video, we are going to go in a little bit more depth with the if statement. So make sure you watch the previous video because that's going to give you the foundation needed to understand this video. The previous video was purely conceptual. I used a chalkboard just to explain the if statement and how to write it out and all that good stuff. This video, we're going to focus on just a little bit more details and some variations on the expressions that we put inside of the if statement, so we can just kind of get a better feel for the if statement. That's because literally the if statement will be in every program you write, probably. So the first thing I always do is I just build the structure. So I say if, put the parentheses, and then I put the curly braces. That gives me the structure to make sure I don't forget anything. Because for example, I could skip out and accidentally forget to put this and just start typing code here, and that's going to cause issues. So I like to just kind of build the structure and then fill it in. All right, so we have the structure. Now we need to put an expression in here. And I'm just going to kind of bank off what we learned in the previous video with Boolean variables. So let's create a Boolean variable. We'll say bool. And the reason we can use this bool variable once again is because we are using this include statement standard bool.h. So make sure you have that before you proceed. So the thing we're going to name this variable, well, it's really controversial. So the question is pizza healthy? Because, you know, if you think about it, pizza has, you know, it's got your oils, it's got your breads, it got your vegetables, if you get some veggies on it, it's got your dairy, your meat, you know, it can even have some fruit if you get some pineapple or something. So it's basically like everything in one. So, you know, you could just eat it like every meal of the day and be very nutritious. Obviously, it's not that controversial because everybody knows that pizza is healthy. So we're just gonna go with that. Pizza is healthy, and we'll set that to true, obviously. And then we're going to put that variable name in the if statement. And the question is, will this code run? And what code exactly? Well, right now we don't have any, so let's just do a printf. And we're going to say, welcome to my pizza app. So yeah, if you like pizza, you get access to this awesome app. If you don't like pizza, then, you know, we take your GPS coordinates and show up at your house and force you to eat pizza until you love it and then get access to the app. So yeah, you really want to make sure you say yes to this one. So let's run this and see what happens. Welcome to my pizza app. And it looks terrible, so let's Let's make this a little prettier. Awesome. Welcome to my pizza app. Now, this is kind of silly because if you think about it, this is always going to execute every single time. That's because pizza is healthy is always true. I mean, you could literally just think about it as literally just typing the value true here. Just that constant true, not even using that variable. This code is going to run exactly the same. You can see when I run it, still runs as true. So what exactly is the benefit here? Well, if you remember from the previous video, I said that if statements are often known as conditionals. That's because they only happen on certain conditions, meaning they don't execute all of the time. The reason this is useless right now is because it's executing all of the time. So in order to make this useful, we have to have something that changes. Generally, this value here that's being conditioned on, well, that is something that we're going to have to get somewhere else. So for example, this value could come from a database, it could come from an Excel file, it could come from a text file, or we could get it from user input. That introduces that level of variableness, variability, what's the word for that? Variety in the inputs that we get. And as a result, the application can only execute this if statement sometimes. So that's the key ingredient of an if statement. Something has to be changing in order for it to be conditional. So let's go back, and what we're going to do is we are actually going to put the variable back in here, and we are going to take this value from input. So how are we going to do that? Well, the first thing we're going to do is we're going to ask a question. Do you love... No, let's make it stronger. Do you believe in the power of pizza? And we are going to do a scanf. Now, how do you actually take in a Boolean value? Well, the easiest way is just to take an integer and then check that integer value. So what we could do is say 1 is true and 0 is false. So what we need to do is we need to create an integer. We could just say int temp, for example. And then what we're going to do is we are going to read that value, and we can use the format character %d, which will take an integer. It's a little bit different than %i when we're talking about scanning data in, and it's generally preferred to use %d if you want to force only integers rather than hexadecimal, for example. Then we're going to put a comma, and we are going to put temp, but you have to make sure that you use the address of operator in order for this function to work correctly. So save that, put a little space there just for readability. Now let's run it. This obviously isn't going to work because what happens is we're not assigning the temp value back to the pizza is healthy. So we need to do pizza is healthy and set that equal to temp. There we go. We can get rid of that value here since it's going to come in from input. Now let's save it and run it. So we'll say 0. You see nothing happens. It just ends. That code does not get executed. But if I run it again and put a 1, now it says welcome to my pizza app. So now you can kind of think of it as having two completely distinct outputs depending on the input. That is the power of branching. With if statements, you can make really complex applications, but it's going to be better once we get into loops and everything else like that to really make some cool programs. But this is foundational to everything we're going to be doing in the future. So let's try to break this. Let's put a value like 20. So let's run this, and let's put 20. And you can see welcome to my pizza app still shows up. Why is that? Well, if you remember, a Boolean is either true or false, and 1 is generally known as true, and 0 is generally known as false. But for C, 0 is known as false, and anything else is known as true. So what that means is I could put in the value -1. It still lets me in. It'll let me in no matter what I put in here as long as I don't put in 0. In that case, it's not going to let me in. The next question is, what if we have an if statement that doesn't just have a Boolean variable right here? What if we actually have like a number like 2.31? Is that going to be evaluated to true or false? Let's try it. If 2.31, let's run this thing. There we go. it doesn't really matter what our input is because the input is not being used for anything. It's getting assigned to pizza as healthy, and then it's done because we're not using it for the if statement. So input doesn't matter, and it still lets me in. That goes back to the same principle. Because this value is not 0, it's evaluated to true. So true as long as not 0. There we go. So that's really cool. But what if we wanted to make a little bit more complexity and only pass this as true if somebody's... Welcome back, everyone. This video, like I said in the previous video, we were going to talk about comparison operators. But, I think I just decided to throw a little video in here that's going to take a step away from that just to talk about some coding best practices. I want to get this down before we move on to something else because this is where a lot of people start to break down. And I have reviewed a lot of beginners' code, and the same issues always show up. So I'm not just saying this just to fill my video count or anything. This is legitimate stuff and a concern of mine to ensure that you develop in the best way possible. So this really has to do with the way you code, the way you type things out, and the way you structure your programs. And this is the basics. So we're not talking about huge complex programs. We're talking about how do you type out code in a proper way. And the very first thing I wanted to talk about was indentations. So indentations, like this is an indentation. When you press the tab or use like 4 spaces or whatever, that is an indentation. And these are really, really important to keep consistent. And when do you know when to use them and not use them? Well, the secret is that anytime we have a new code block defined by these curly braces, everything within that code block gets indented. And that's consistent. So even though we have another code block down here, this code block is within the other code block. So it also has to be indented. But this code here is in that second code block, so it gets indented once more from this code block. So hopefully that's pretty clear. I mean, it's obvious when you look at it here, but it gets really confusing when you have like 30 indents and at the end you have like 16 curly braces and you're trying to figure out where they're all supposed to go. And you get an error like you have one too many curly brace or like something like that, and then you have to figure out what's going on, and you don't want to de-scope things by deleting a curly brace here, for example. We could have a printf statement like this. And what could happen is I could accidentally put an extra curly brace and delete this one because I have an error and I'm trying to fix it. And what happens is that this code is going to compile and run. So this needs to be, let's make this false here. Run this. And you can see that if I put, it doesn't matter what I put, it doesn't say the end, even though it's supposed to say the end all of the time. So this is just kind of like an illustration. Kind of got a little off topic, but the point is that make sure you follow your indentations. And the easiest way to do that is to do it before you have issues. So if you know you're going to be doing an if statement with 3 if statements inside of it, here's what you should do. You should make the first one, and then you should make the inner ones. Like this. Yep, there you go. So anytime you open something, you always close it before you start typing in it. So I would avoid doing this. If you're going to say if true, some people will type it like this. And then they'll type the ending. It filled it automatically for me because of my code editor, but you can envision typing it out like this and then putting the end one and then opening it and typing all their code and then closing it. And when you do that, you're asking for some serious problems because you're going to forget what you need to do to close all your curly braces and your parentheses. The next thing I wanted to talk about is comments. So you can see I use a lot of comments to illustrate things, and I just am asking for you guys to be consistent with where you put your comments. So for example, if I want to describe a variable, I could say this is a true or false on whether you like pizza. So that's right after the definition of the variable. So that's clean, very easy to follow. What is confusing is if I put this down on the next line. I mean, in my opinion, but it's all about convention. So if you want to comment about the previous line, by all means go for it, but just be consistent, because if I do this, This is a temp variable. See, this one is now commenting on top. This one's commenting on bottom. And then if I were to get rid of some of these spaces, okay, this is confusing now because you don't know if my convention was to comment on top or bottom. And you can see it's in the middle of two variables. So you can see how it can get really confusing. So what I always do is I will restrict myself to commenting after on the same line, just like this, or I'll put it above like this. Either one is fine for me. I prefer not to use comments at the end just because I feel like it gets a little lost. And you read the code before you read the comment explaining what the code does. This is much more helpful to me where it says, oh, here's what's about to come. And this is helpful for me too because I know it's on the same line so I can see it readily there right beside the variable. So those are my versions of best practices. Another couple things that you can consider is where you put your parentheses and curly braces. So for example, if we go back to these if statements, a lot of people will write their if statements like so, where they put the first curly brace on top. That's perfectly valid. I'm not going to say you can't do that. It's totally fine. But it does get a little bit more complicated when you're trying to line up parentheses. Because if you look at this if statement, for example, the starting parentheses, or the starting curly brace and the ending curly brace are the same level of indentation over. Very easy to see the start and the finish. Whereas this one, it's diagonal, so you have to look at the start of the if and the curly brace, which is just a little bit more harder to see in my opinion. Additionally, it can get a little bit crammed when you have a lot of code. I like to space it out a bit more. Some people prefer to condense their code in as little space as possible, and in that situation, people will often do this, or sometimes they'll even put it in the line like this. I guess you can't do that, so we'd have to do like that. So all of those are different options. The most important thing is that you stay consistent with whatever you decide to do from the beginning to the end of your project. And if you have a team, it's really, really important that you guys have some kind of standards on how to do this kind of stuff. Otherwise, you're asking for disaster. So I know this was a little bit of a ramble, but just wanted to get that off my chest. And now we can move on back to the if statements. Thank you guys, and I'll see you in the next video. Please be sure to subscribe. Welcome back everybody. This video we are going to be talking about operators. So to kind of ride into this a little bit, the previous video we were talking about if statements, and inside of the if statement you put some kind of expression, and sometimes you want to be able to say if this value is less than this value, equal to this value, etc. Well, to do that we need to have these operators, less than, greater than, equal to. These are known as relational operators in C. You may also hear them as comparison operators. Another way you can think about this is that in the previous video we were using Boolean variables or values, true and false. And you can kind of think of it as 0 being false and 1, or anything else basically, being true. And it was like kind of like this black and white spectrum. But what if we wanted to kind of change the spectrum and say what was considered true and false? That's kind of confusing, but let me just kind of explain. Let's say we wanted to make a variable to contain how much somebody liked pizza. And we could say that the high is 10. And we could say that we're trying to determine if someone likes pizza. And we could say that anybody that has 7 or higher on this scale likes pizza. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. Anything past here would be considered true. Or you could just make this 10. You could make it infinity. So basically anything that is greater than 7 is considered true. So we still kind of have that true, false, black and white concept. But now we kind of expanded on it by enabling sections of this to be true and false, rather than just true or false, right? Like you like pizza or you don't like pizza. But now we have a range. So a person who likes pizza 7 out of 10 likes pizza. A person who likes pizza 8 out of 10 likes pizza. And I know this example was like the most practical example you're probably ever going to use in your life. And 9 out of 10 is good, and 10 out of 10. Or we could just say anybody, 7, 8, 9, 10, 11, 12, 13, 14, etc. Anybody above 7. By the way, why is 7 afraid of 8? not how it goes. Why is 6 afraid of 7? Because 7, 8, 9. Get it? Oh boy. Well, in order to do this, we need these relational operators. And it's really simple, so it's not too complicated, don't worry. So to write this out, it's gonna look something like this. We're gonna say if, and then we'll just make some variable name, pizza rating, I guess. And if that's greater than the value 6, we want this code block to execute. So this here is the operator. This is an example, and this is specifically the greater than. So it would accept 7, 8, 9, 10, 11, anything greater than 6, and this will run. So this is just an example of one of the relational operators. Let's talk about some of the other ones. So let's get that one first. We have greater than, which looks like that. We have less than, which looks like this. Greater or equal to, and that's actually going to be a little bit different than what you're used to. So in math class, that would look like greater than or equal to. But in computer science, the way that's represented is a greater than and then an equal sign. And it kind of reads how it sounds. Greater than or equal to. We also have a less than or equal to, which is very similar, less than equals. The last one is whether or not something is equal to something. So that would not allow for greater than or less than. It has to be exactly the same number. And that is actually 2 equal signs. And you have to remember that it's 2, not 1. The reason it's 2 is because if you think of what the individual equal sign is in C so far, this is used for assignment. So you would say x equals 5. So this is the assignment operator. So instead of making this and this the same and just contextualizing what the meaning is depending on what's around it, that would be a little bit more confusing. So the end result is that we have 2 equal signs. That makes a lot more sense rather than the compiler trying to figure out if you're trying to assign to something or if you're trying to see if something's equal to something. So we have the double equals. So to see this in action, it would be like this. 6 is equal to 6. That is true. 6 is equal to 7 is false. So if you wanted to be very specific, only the people that get in are the people who have a pizza rating of 10, exactly 10. Well, then what you would do is replace this value here, that looks terrible, with equals 10. And then someone puts in a value, let's say 6, well, this would be false, and this code block would be skipped, and we would continue from below. So these are the important operators that you need to know about. There is one more thing you should know, and that is, in general, you can use this exclamation mark, which is the negation operator, which is going to basically flip the true or false value of anything. So this could be applied to something in parentheses. So if you had some expression, let's say likes pizza, or actually you don't even need the parentheses in this situation. Well, you could put that exclamation mark there, which means does not like pizza. So it basically flips the value. So if likes pizza is actually true, when we put this exclamation mark, it would have to be false. It gets a little confusing, so don't worry too much about it. But the reason I'm calling that out is because there's actually another one you should know about, and that is not equal, which looks like this. And it's odd because you actually only have 1 equal sign here. So you just got to remember that. It's 1 equal sign if you're using the negative. It's 2 equal signs if you're using no negative. And that works because when this equal sign is connected directly to that exclamation mark, it's easy to tell that this is a different operator than just the equal sign. So we don't have to worry about it. But it does kind of confuse me sometimes because, like, why does it have to be 1 equal sign when it could be 2? I don't know, it's confusing. So just memorize that 1 equal sign goes here when we are doing the not equal. Now I'm going to bring up something known as precedence here, and I'm just going to touch on it a little bit. So I'm going to give you a little example. As you build more complex expressions, you have to understand precedence of these operators. So for example, if we did this, it's greater than 3 plus 3. This is a little bit confusing because you could think of it as this, plus 3, or you can think of it as this, where pizza rating is greater than 3 plus 3. Which one actually happens is dependent upon the operator precedence. So in this situation, the plus sign has a higher precedence, which means it happens first. So this is actually going to get evaluated to pizza rating greater than 6, which will then ultimately be evaluated to true or false depending on the value of pizza rating. And that makes sense, because if you think about it, if you did pizza rating greater than 3, let's just say it was true, and then you had plus 3, this doesn't really make a whole lot of sense. I mean, you can think of it as 1 plus 3, but it just doesn't make as much sense to me. It would make sense to do the math operators first and get a value to then compare against. So that's just a taste of operator precedence, which you're going to get a lot more of as you do C, so pay attention to that. Thank you guys. That's all I got for this video. In the next video, we're going to be applying some of this stuff to a really cool software game that we're going to make. It's going to be really cool. I mean, it's not like GUI, shoot 'em up or anything, but it's still pretty awesome. All right, check you guys then. Peace.
Welcome everybody. This video is going to be so super cool because we're finally making like a cool little application, and we're using all the fundamental knowledge that we've built up over the last like 49 videos. So it's really cool to see this stuff come together. The one thing I wanted to warn you guys is that we are going to get into some new stuff. So if you don't get everything, don't freak out and run around the house screaming. It's going to be okay. Just trust me that it works. I just ask that you entrust me with your programming. And I assure you that nothing will go terribly too wrong, okay? Just maybe a little bit wrong. So what are we going to do? We are going to make a guessing game. And let's just kind of write out the point of this game. We are going to create a game where the user has to guess a number from 0 to 5. Then what we want to do is output whether or not the person is correct. That's where we'll start, and then we'll try to get a little bit more complex from there. All right, so where do we even begin? Well, the first thing is, we need to give some output so the user knows what is going on. But let's do some kind of maintenance stuff and get some variables ready beforehand, just to get some of the harder stuff out of the way right away. So one thing I wanted to do is generate a random number. And this is actually surprisingly complicated for a computer. So what ends up happening is we have what's known as a pseudo random number. So pseudo means fake or like false. So essentially it resembles a random number, but it's not entirely random. And this is actually a really cool thing to study on, because some of the ways people make these random numbers are insanely complex, right? So if it's like a secure system and like we can't let people get access because we have something secret, what we can do is we can make some sort of random number. And the way this random number happens, we'll take something from the time, it'll take something from the temperature of the machine, or anything really, and it'll basically mix all this stuff together and get some random number. If you're really, really, really talented, you could decode this number and get access into that machine, but generally these random numbers are random enough that it doesn't really allow access. So that's just kind of like an extreme example, but most of the time we just need a random number for a stupid game or something. But with that, all of that stuff that goes into building that quote random number is known as seeding the number. So the number gets seeded. So to write this out, we'll have what's known as a pseudo random number generator, which is a really long word, but that's okay. And this thing gets seeded with some data. It outputs a result. So let's just clean this up a little. There we go. Okay, so let's do this. So our random number is going to be based off of a value, and that value is known as the seed. In our situation, our seed is going to be generated from the clock. The reason it's generated from the clock is because the clock on the computer changes so rapidly that it can really make it easy to get a random number. It's one of the most common ways to build a random number. So what we're going to do is we're going to type some stuff out, and then I'll explain it. So we're going to call a function srand and pass in another function called time, and then put null. And essentially what's going on is we're calling this time function, which gives us a value, which we then pass to this srand function. And essentially, we are telling the random number generator where to get the seed value from. We're getting it from the time. All you need to know is that the time function does work without passing in something explicit here, specifically a pointer. It just works with null, so it's good. Next thing we need to do is we need to create a random number. So we're going to say random number, and then call a function rand, and that's where we're actually going to get that value. So at this point, let's just print that random value to see what happens. All right, we have a warning. It's not the end of the world, so we'll just run it. Segmentation fault 11. Okay, it didn't like that. No matter how many times I run it, I get this segmentation fault. So segmentation fault is basically when you're trying to do something you're not allowed to do, specifically accessing some area of memory. So part of the issue here is that I looked into it a little bit more, and you can see we have this warning, implicit declaration of function rand. So what that is telling us is that we are basically trying to define a function out of the blue that doesn't exist. So C is not recognizing this rand as a correct function, something that already exists. And the reason is because we didn't include an important include statement. So what we need to do is we need to say include standard lib.h. Save that. Now let's give it a try. All right, we're getting closer. Now it should run in theory. Okay, still an issue. All right, so let's see if I can work with the format strings here. All right, so I got another similar issue when I was working around with this, because now it's saying that time is invalid. So in order to fix this, I actually forgot another include. Gosh, I'm slacking today. And this is time.h. So when you're getting these weird errors when you think things are supposed to be working, the chances are you just forgot to include something or you typed it wrong. All right, let's give it a go. I'm just going to keep that %d to format it as an integer. It should work. Awesome, and we get this huge number. All right, so I'm going to add a new line just to make this a little prettier. And there you go, you can see the number right there. And as I run it more and more times, you can see that the number continually goes up. It's almost like it's counting, which, by the way, it is. It's tied to our clock, so that's really good. So we are getting a pseudo-random number. The issue is that it's humongous. And if you look back at our original guide, it said pick a number from 0 to 5. So how in the world do we kind of convert this into a random number with the range 0 to 5? That's the next challenge of this little coding project. And this is a great time to talk about the use of the modulus operator. So the modulus operator looks like this, and I believe I brought this up to you guys before. It essentially just gives you the remainder of some division. But the cool thing is that you can use this remainder to do a lot of cool tricks. So for example, if you need a number within a range, you can use the modulus operator to do that for you.
If we wanted a value 0 to 5, all we would need to do is do modulus 6. Oops, not, gosh, I said 6 and I typed 5. So we need to do modulus 6. And the reason we do modulus 6 is because that would allow for a remainder of 0 to 5. It's going to take that huge number, divide it by 6, and whatever's left over using integer division is going to be assigned to random number. So then what we're going to do is we're going to ask the user for an input, and if that input is the same as the random number, then they win. Otherwise, they lose. So the first thing we need to do is we need to ask the user for some input. So we're going to use the printf and just say something like guess a number 0 to 5. And I was also thinking what would be kind of cool is instead of really restricting this to just 5, we could still use 5 and we could still hard code it for now. But I think it'd be a little cooler if we used a variable. So if we did something like max value and set that equal to 5, and then we reference this variable. So if we wanted to change the number in the future, we could just go back and change this variable. So instead of 6 here, we're going to use max value plus 1. And instead of 5 here, we're going to use %d, which will output the value max value. And we'll just add a colon. It should be good to go. So let's try it out. Okay, the random number is 1. We'll leave that there just so we can kind of see what's going on. And it says guess a number 0 to 5. And
it's not getting an input because we still got to do the scanf. So what we need to do is we need to define a variable for the user input. So we can say input, and then we can use scanf for various other functions. And we're going to go with type %d because it's a number. And we're going to store that using the address of operator input. This will allow it to change the value of input. And then we're going to do the comparison. So if input is equal to random number, they win. Otherwise, they don't win. Sorry. This should work, and let's just give it a go and see what I missed if I forgot anything. Guess the number is 0 to 5, and it says 1, so let's put 1. It says you win, and I'm going to add some new lines just to make it a little prettier. And now let's try again where we don't get the right answer. So it's 4, let's go with 5. You don't win, try again. So there you go, that is how you make a simple guessing game. The cool part here is that we can actually change this max value to like 50. And we should also probably change our documentation. There, so now it's more general. Okay, let's run this. And you can see now the value is 25. And it still works. So there you go, guys. That's a simple guessing game. Now, if I wanted to expand upon this, which I would if I felt like it, what I would do is I would make a system to where, oh, and also, by the way, in the actual final product, you're not going to want to print the random number. That kind of defeats the whole purpose. But in the production one, I would probably say, oh no, your number was too high, try again. Or, oh no, your number was too low, try again. And I would make this in a loop system. And we haven't really talked about loops, but we'll be getting there in future videos. But basically, you could create a loop to keep asking it as long as their number is not the correct number. And as they get closer, like let's say the random number's 25, they say 28, it says too high. And then they say 24, it says too low. And it makes it a lot easier to get to the final answer. So hopefully this was cool and helpful for you guys. I did mention that it was pretty complex at the beginning, and it's not too bad. The only thing is this random number stuff can be a little bit much sometimes. So hopefully you guys understand how this all works, and if you do, then good. That makes one of us. Thank you, and I'll see you in the next video.
Welcome back, everybody. This video is actually a continuation of the previous video where we talked about the if statement and we also talked about the relational operators. This video we are going to be talking about the else clause. So we're specifically going to look here at line 32. The primary issue here is that we have two return statements, which is going to basically exit the program and just stop running. The reason we have one in here is because we're exiting the function, the main function right here. And we're saying 0, which actually means everything worked fine. So that's going to stop execution. This means we're not going to be printing this you lost down here. But the issue is that this return prevents us from executing more program and just makes the program end entirely. What if we wanted to go on in our program and do some other stuff? Well, the first solution idea would be to delete this return 0. But then the issue is that once you win, it's going to come down to line 36 now and start executing you lost, which is not what we want to do. Another way to think about this is if you had something down here, let's say, let me put that return 0 back in here. And let's say printf, thank you for playing. And you can see that this applies to whether you won or you lost. You want to thank the person either way. But now you will never be able to do this. Even if you delete the return 0, it's an issue now because it's going to say you win, you lost, and then thank you for playing. That's silly. So the solution to this is to say else and then put another code block with brackets and move anything that you only want to happen if you lost into the else section. So like this. So now it's only going to say you lost if you lost the game. So let's give this a go. Let's run it. And you can see that it says you win, thank you for playing. And the you lost never gets executed. But now let's play again and try to lose.
you see it says you lost. Thank you for playing. This is really where the magic of branching happens, because now you can continue the application and kind of make one branch here in this if statement and the other branch in the else statement. And then those branches can come back together and do some code either way. So this will always execute regardless, unless you did do something like return 0. In this situation, in the else, you're going to stop executing, and this would only be executed if you did win the game, because it would hit this and then it would jump down to 41. You can see just the different options of breaking out of the game. You can return, or you can just wait until the end of the code and it'll automatically return, but I also just put a return here just for clarity. And for branching, you can return within those branches. So return here is going to end the game only if you win, and return here is going to end the game only if you lost. So keep those things in mind. So for example, if we have some kind of conditional, and let's just say it's a Boolean like is valid, right? And you could say valid entry. Otherwise, you could say return -1 or return 1 or something else other than 0. And what that does is the calling program is going to deal with that in some way. So for example, let's just say return -1. And I don't know what all the numbers mean, but you can basically just pick something other than 0, and that is a potential issue. Let's say if false. That'll always be false. And now let's execute. You lost. And you can see nothing really happens, but that's because nothing is doing anything with this number. But what can happen is you can actually call this program from another program, and then you can check to see if it executed correctly. So imagine inside of another program, we could call guessinggame.main like that. The return values do actually mean something, and they're important. So you can use them for your benefit, but most of the time, you're not really going to need to worry about them unless you're writing some kind of shell script or something where you have to run a bunch of these other scripts and the return result has to be 0 for every single one in order for everything to be successful. So yeah, I kind of went on a tangent there with the whole return values, so apologies for that, but hopefully that was some good food for thought. And speaking of food for thought, I'm getting a little hungry, so I will catch you guys another day. Thank you guys for watching. I'll see you in the next video, and please be sure to subscribe.
Welcome back. It is a new day here for me on the Intertubes. I'm super excited to get some new videos out. We are going to be talking about logical operators. Now, we've talked about this a little bit when we started talking about logic, but I wanted to go in a little bit more depth and also some of the syntax stuff for C programming on how to do logical operators and how to know what the end result is going to be. So let's get started. All right, so logical operators. These things are used to build complex conditionals. The easiest way to understand these conditionals is to write them as an expression within an if statement. And since we know what the if statement is, we're going to use that as an example to wrap our mind around this stuff. So let's say we want to build a website where you have to log in, and in order to get access to everything, you have to have either a verified email or a verified phone number. So when you sign up, they send you an email or a text message with a code or a link that you have to click, and that'll verify your account and give you access to the full featured website. So that would look something like this, where you have if, and then you would have some kind of conditional in here, and then you'd have a code block which would grant access. So the question is, what are we going to put inside of here? Well, it's a little bit dependent upon the way you've coded this, but we're just going to use some English for right now, and then we're going to talk about the truth evaluation for this expression. So what we would do is say, if email is verified or phone is verified. And this would be on a user by user basis, meaning we're talking about one specific person's email and one specific person's phone number. So some people are going to get access when they execute the code, but other people are not going to get access because they don't have either of these verified. So it's convention to capitalize this here, which is the English word for the logical expression. The syntax for this, though, is just 2 vertical bars. That is how you write OR in C programming. And what we're going to do now is we're going to talk about the possible things that can go here. So I'm going to erase this part here just to have some extra room. So the 3 logical operators you need to know
are or, and not. These logical operators enable these smaller pieces of this expression to contribute to a bigger picture. So this one, email is verified, is going to get evaluated, and it will return some result. Once we know the value of this, something can happen called short circuiting. So what that means is we don't necessarily have to evaluate this one because we might already know the answer based on this one, but that's not always the case. So in that situation, if we don't know the answer yet, we're going to verify this one, and then these can have some value. So let's say true and true. And then depending on what goes here, one of these two here can go between these. This is going to contribute to one final result of true or false. In this situation, whether you put the or the and, it's going to get the same result. How do I know that it's going to get the same result? If we already verified both and we only require one with the or, well then it's also going to grant access. So in this situation, it's very obvious, but there are some miniature truth tables, if you want to call them, that show the possible values for these two operators. So what I did here is I set up these mini truth tables where we have one operand, so email is verified would be A, and another operand, photo is verified, and then we have A or B. And then what we do is we put every possible value, and then we just think about what the value is going to be here. And if you don't know, you can just kind of memorize, but it's fairly simple. If either of these are true, the result over here is going to be true. So true, 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 and then false. The last one's false because they're both false. And works similarly, but a little different in that they both have to be true. So let me write this out. So this one, only the first one's going to be true. The last one, not, works a little bit differently. So this is a unary operator in that it only takes one operand. So it can only work on one thing. So what I mean by that is you can have email is verified, or you could put phone is verified, but you can't put both in the column here. You would need one of these binary operators that work on two operands. So now we have the opposite of whatever this value is over here. True or false, and it's going to be false and true. These are the basis for building more complex truth tables. And this kind of lets you look at these conditionals in a more established way, because this is the traditional way to represent logic when we're working with computer engineering and so forth. Now there is another operator that we can talk about when we're talking about logic in general, but there isn't an exact operator in C programming, and that is exclusive OR, XOR. And you will see that a lot when you're doing logic for computer engineering, but in computer science, at least C anyways, there is not an operator already defined. So there is a way to mimic this, but first I'm going to talk about what the truth table is for exclusive OR. So the thing that's different about exclusive OR is that they both can't be true. So this is going to be false. What in the world? It's going to be false, and then this is going to be true, and this will be true, and this is going to be false. Now, the way you can kind of trick C into doing this is if you consider this to be either true or false, and this to be either true or false, then the only situation when they are true is when they're different. So what you could do is you could say something like A is not equal to B. And in this situation, when they're not equal, it's going to be true. So if you put email is verified is not equal to phone is verified, then they would have to one or the other be true, but they couldn't both be true. In this situation, it doesn't really make a lot of sense, but there are situations when that's going to come up. So here's how you can do something like that. So that was exclusive OR. The name for the other OR is usually just OR, but if you wanted to be a little bit more specific, it's inclusive, which means you are allowed to have both true. And when I learned about this in school, a good example that was given was if you allow a child to have dessert and you say something like, you can have ice cream or you could have cookies. It's kind of implied from the adult standpoint that you get to pick one of them, but not both. You know, you can have ice cream or cookies, like your choice. Which means you are implying exclusive or. Inclusive or, when you tell a child you can have ice cream or cookies, and they come back with both, that would be inclusive or. So if you're young, you're watching this video, next time you get that situation where your parents say, hey, you can have this or this, grab both and tell them, oh, I thought you meant inclusive or. Welcome back everybody to your C programming series. This video we are going to go over another example of a complex conditional, but we're going to step up our game a little bit and make it a little bit more complicated. As a reminder, we need to know what relational operators are and logical operators. So for example, we could have something like this. Int x equals 5, and then we could say x is less than 5. This is really super simple, and you can kind of just see it as 5 is less than 5, since the value of x is 5, which is obviously false because they're the same number, so one can't be less than the other. But if we did something more obvious, like x is greater than 1, this would be true. And then when you have logical operators, you can combine these things. So for example, if we had x is greater than 1 and x is greater than 2, these would both have to be evaluated as true. And in this situation, we can actually simplify this expression. Because if you think about it, x is greater than 1 has to be true, and x is greater than 2 has to be true. Well, if we had something like x is 3, if we work backwards on this one, x is greater than 2 is automatically going to make x greater than 1. So this could be simplified to just x greater than 2. And you can kind of use those intuitive simplification skills to make complex conditionals smaller and easier to read. And when we are dealing with Boolean logic, there's like tons of tutorials and stuff on taking a really large expression and simplifying it down to the bare minimum. And that process is done to make the most simple circuits. And it's really cool. I'm terrible at it. I barely survived. I took a computer engineering class, barely survived. I managed to get a good grade, but it was kind of, it was very challenging for me. But this stuff is fairly easy in the beginning, but when it gets to some more complex things, it can get a little complicated. So here we have a crazy complex conditional. Don't freak out. It's actually pretty simple once you start looking at it, and there's some things we can simplify to make it a little smaller. So one of the first things you're going to notice is that there's 3 parentheses. So I use parentheses very liberally, and basically anytime I could use a parentheses, I will use one because it helps organize and it helps make sure you're understanding what you're asking. And honestly, when you get into some kind of complex conditional like this, it's very easy to not really ask the right question. And as a result, certain entries of x and y are going to get into the code block when they should not. So in my recommendation, avoid complex conditionals like this. If you need to, you can do the same thing with nested if statements. So for example, we could have a first if statement talking about this first expression, and then within this code body of this if statement, we can have another if statement talking about the next expression. Obviously, that's going to make your code larger and maybe a little bit more cumbersome to go through. But as a result, it's sometimes a little bit more clear on what you're asking. You can kind of see it as you have a group of valid options, and as you go in to each of the if statements, you start severing off invalid results until you just get to a small result set that gets inside the code block of the final if statement. That to me is a little bit more easy to process than having just a ton of values and just saying any values that don't meet this rule are severed off. That's really confusing to me. So in general, I try to avoid complex conditionals beyond just a few simple things. And I usually try to avoid mixing ors with ands, as it can be challenging to really know what you're asking for. But just for laughs, let's look at this and see if we can wrap our mind around it. Let's say x has the value 5 and y has the value 10. When you're evaluating something like this, you always want to work yourself from the inside out. So what that means is you find the innermost parentheses and start there. So, for example, we could start here, at this line right here. It also helps to kind of think about what's going on here and where the parentheses are lining up. So you see this if statement opens and then it closes down here. Within that we have two parentheses, 2 here and then 2 here. So what's going on is we are grouping this one with this one out here, which doesn't really need to be there. So in this situation, you could cleanse your code by getting rid of these parentheses. But before we dive into that, let's just think of some ways we can simplify this. So looking at x is greater than 0 and x is not equal to 0. This is redundant because if x is greater than 0 and both of these have to be true, then what's going to happen is we have to have x greater than 0. If we had a -2, for example, or a negative anything, this would fail. If we had the OR operator instead of the AND, if we had OR and we had -2, it would pass because it would say x is greater than 0. Well, -2, that's not going to pass. So that one would be false. But x is not equal to 0 would be true. That would not pass. But there's one other thing attached here with this AND. Y has to be greater than 0. So if y is 10, this whole section would pass. And don't worry about writing all this out. I just kind of want you guys to listen and intuitively think about this kind of stuff. So this expression here, let's just pull that out. This could be rewritten as x is greater than 0 and y is greater than 0. So all that's saying is both of the numbers have to be positive. This is another thing here. So we have a not operator with a comparison operator in parentheses. This could actually be rewritten as x is less than or equal to y. Because what it's saying is x is not greater than y because we're inverting it. So originally we had x is greater than y and then we want to flip that so x is not greater than y. But if something is not greater than y, it's automatically less than or equal to. So this could be cleaned up by replacing it with x is not equal to y. Oh, and look at that. X is not equal to y. We already have that in our expression. So x is not equal to y or x is not equal to y is redundant. So we could actually get rid of this second one here. So originally we were going to just start evaluating, but now we just simplified things a whole lot. So I'd love to rewrite this thing, but I probably won't be able to with just my pure amazing memory. But essentially you can see what's going on. Once we started to evaluate it, then we can think about what is going to be evaluated as true. And you want to work from the inside out. So for example, we have this in parentheses ANDed with something else in parentheses. So this whole expression has to be true and this whole expression has to be true. And then there's another one. This whole expression has to be true and this whole expression has to be true. So it kind of starts with these sections that all have to be evaluated to true in order for the whole thing to pass. So essentially what this is asking, x modulus 2 is asking if it's even, because anything that's even when divided by 2, the remainder is going to be 0. So x has to be even, y has to be even, and they both have to be greater than 0. And when you add them together, it has to be greater than 10, and x has to be less than or equal to y. So that would be the smaller, simpler expression, which would only have a set of numbers that would pass as true. That's kind of how you go through the process of simplifying and processing this kind of thing. So this video was a little odd in that it's not really something you have to do a whole lot. Just kind of wanted to give you some time to really think about these expressions and try to understand what's going to happen when you have something like this. Not entirely practical for every certain situation, of course, because you're most of the time just going to have something really simple like this rather than everything, but still helpful to go through and think about it. So hopefully this was helpful to some of you. If not, go to the next video because I think we'll get into some more fun stuff. So thank you guys for watching. Please be sure to subscribe, help me out. I'll see you in the next video.
Welcome back, everybody. This video we are going to be talking about a really cool concept called short circuiting. And what this is when you have a large expression, you can actually evaluate the expression early without having to go through the entire expression. So how exactly does this work, and what's the benefit? Well, first let's talk about the benefit. The benefit of this is that when you are executing your code, and let's just say you have some huge expression, and, or, and, not, you have a bunch of these operators in this large expression. Well, the benefit is that if this is able to short circuit halfway through evaluating this expression, then we can save computing time because we don't have to worry about the other half. So this is going to speed up your programs. So the way this thing works is that there's these rules that allow us to know whether an entire expression is true or false early. And this is built on the foundational ands and ors. If we look at the truth table, I'll show you what I mean, and you will be able to see how this works. So if you remember, we have two inputs for these, and then we write all the values, true, true. And sometimes this is easy to think about if you look at the odd one out. So we have or, and then we have and. And you'll see what I mean by odd one out here in a second. So for or, the odd one out is this bottom one, where the value is false. All the other ones are true. For and, the odd one out is the true, which is the first one. So all the others are false. So the way the short circuiting works is that anytime for or that there is a true, we know automatically that the end result is true. So here's a true, here's a true, here's a true. When they're both false, we know it's false. The opposite kind of happens with the and. Anytime there's a false, we know that the value is going to be false. So I'll box these here. We have a false, and a false. Okay, so what that means is that the only time that the true happens is when they're both true. So you kind of think about it in a different way than you normally do. You just think about what the bare minimum requirements over here are in order to know the end result. And when you're reading this from left to right, sometimes you can know the end result before having to look at both of the inputs. The circling and squaring is just kind of making things a little confusing here, but I thought it'd be helpful. There we go, that's a little bit easier to see. So the greens have the trues, which automatically make these true, and the purples have the falses, which automatically make these falses. But not all of this is going to be useful, only the ones on the left. So if you're reading this from left to right, and you see a true here, and we're working with the or, then you automatically know that the end result is true. So true, true, and that's all we're able to do. For the one down here, what's going to happen is it's going to evaluate this first one, and it's going to be false, and then it's going to be like, well, I can't know for sure because the next one might be true. And in that situation, it requires us to evaluate both of these to see if the second one is true. And works in a similar way. So it can go through here, and anytime it sees a false on the left, false, we know the end result is false. False, we know the end result is false. For this one here, it doesn't work quite the same way because it requires us to evaluate the first one, and it doesn't give us enough information. And then once we get to the second one, it can know that the end result is false. So that one's not able to short circuit. So to wrap this up, the first two here, when we have true, true, and true, false, we are able to short circuit to true for the ors. For the bottom two down here, false, true, and false, false, we are able to short circuit the ands and know that they're false. That truth table allows us to build some fundamental rules for Boolean simplification, essentially. So let me just write a couple of these out. So here's the first one. When we have true or x, well, we automatically know that when we hit a true, the whole expression is going to be true. So this just shortens down to true. If we have false or x, well, this doesn't tell us enough information. That means this one has to be true. If it's true, the end result is true. If it's false, the end result is false. So that means that the output is actually just x. So whatever x is, the output is the same thing. Now for the ands, if we have true and x, well, we don't necessarily know if this one is true right away, so we have to evaluate the whole thing. So similar to this one, we have the value of x. The last one here is false and x. For this one, False is enough information to know that the end result is not going to be true, because they have to both be true in order for the end result to be true. That means if we hit a false on the left, this is just going to be false. So what I would do is I would write these down on flashcards and put the end result on the other side and just practice to memorize these associations. So this can come up if you always have values that are true or false, which isn't going to happen a whole lot. Most of the time, these are going to be some variable, and you can just kind of think about this as the evaluation of that variable as true or false. So if you had email verified and evaluated to true or false, you can then think of what the short circuiting is going to be. So that's how you can think about this in computer science. So in computer science, we don't really have to do the simplification. We don't have to worry about taking the expressions I just gave you on the left and changing them to the result on the right. That's all going to happen at runtime when the program is executing, because the value is going to be evaluated on the left and it's going to allow us to just jump to the end result. The whole idea behind Boolean simplification, that's something you can do for usually circuits, and what that does is it allows us to make more simple circuits. It applies a little bit less in computer science, but the same concepts apply, and you can use those same concepts to simplify large expressions if you need. But the primary use of this is at runtime. We don't even have to worry about it. So for example, we can write an expression, it'll short circuit if it can, and it will not short circuit if it can't. There is one thing you have to worry about though, because this can actually come up where the short circuiting causes your application to not execute something that you wanted to execute. So if you remember, inside of an if statement, you put some kind of expression here. And generally this just gets evaluated to a value. But sometimes you're going to put functions in here, and that can change. If it short circuits, not all of the functions are going to get executed. So earlier in another video, I had something like this, where we have a function on the left and then or a function on the right. If this one passes as true, this one on the right is never going to get executed. 99% of the time that's going to be fine. But if something happens in these functions that you need them both to execute, then we have an issue, because this one's only going to execute some of the time, and that's if this evaluates to false. This can cause an unpredictable result to happen where a function's only getting executed sometimes within this if statement, and that's kind of unpredictable. Welcome back everybody to your video over logical operator precedence. Now in the previous video I gave you this huge expression with a ton of parentheses, and the reason we had all these parentheses was so we could visually see which things were being evaluated first. Because when you have multiple parentheses, the things that are on the inside the most get evaluated first. What that means is that we can use parentheses to kind of force the way things are going to be evaluated so it's really clear what's happening. But if we were to get rid of these parentheses, things are still going to be evaluated, but it's not nearly as clear what is happening. So this video we're going to be talking about what happens when you don't put those parentheses in some crazy expression. So let's get started. So here we have a very simple expression. And let's say y and z are Boolean values when they are going to be evaluated as true or false. So this has an or and it has an and logical operator. So the question is, which one of these is going to happen first? And it actually matters because you can kind of represent this two different ways depending on the answer. If the or happens first, so we'll do that one up here. So or first, and then the next one's going to be and first. If the or happens first, it's going to look like this. Because if you remember, parentheses always cause things to be evaluated first. So true or y. If and happens first, it's going to look like this. And then this one will be evaluated, which will be ORed with true. In this first one, this value in parentheses, true or y, is always going to be evaluated as true. And the reason why is if you look back to our truth tables, and we have two inputs, A and B, what's going to happen is the output is going to be true for all possibilities when one is true. Let's just look at that. So we wrote down every single possibility, but we only need to look at these two because in this situation, A
is just the value true, which is always going to be true. And in the end result of our truth table, both of those rows are true because it's true, 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 false. So what that means is that this is automatically just going to be true. So we can actually simplify it, true and z. So what that means is we can actually simplify this even more because true and z is just going to be z. And you can see that as well in a truth table. So for example, if we do our two inputs A, B, A and B, and then we fill in all the possible values, true, false, false, and false. And once again, we only have to look at these first two rows here because A is true, because we have this is the first input and this is the second input. So when we look at these two, you can see that the output is always B. So B is true, the output is true. B is false, the output is false. So we can actually just get rid of A. This is all part of Boolean simplification, and it gets, you know, a little bit out of the realm of this video, but it's kind of cool to go over. So this will be simplified once more to just Z. This one's a little bit different because if you remember just a minute ago, we had true or something else. It's automatically true because one of them is true. So this one is always just going to be true because we have true or something else. So when simplifying, this is going to be just true. As you can see, the results are completely different. This expression is simplified in two different ways depending on the operator precedence. Well, I'll tell you what the precedence is. Of our three operators, the not operator is first, then and then or. So this is the result here. If we had a negation, that would happen first. So this would be false. And then we would do the and version first. So it would look like this, ORed with false, which would simplify just to Y and Z. You can see that this gets pretty complex pretty quickly when we don't have those parentheses. So you always want to make sure you have those parentheses. Be sure to subscribe and it's going to be awesome. So I'll see you guys then. Peace out. Hey guys, welcome back. In this video, we are going to be talking about a new concept, and in the next video, we are going to be applying this concept to an example. This video, we are going to be talking about else if. So thus far, we have talked about the if statement, and we have even talked about using an else. This is a traditional if-else, and else-if is a little bit different. So with an if-else, what you're doing is you're essentially taking your program, and then what it's going to do is it's going to branch two different ways, right? With an else-if, we are going to branch three different ways. So it would look like this, where the first one is the if being true. The next one is basically another if, the else-if, and then the third one is else. So what does this look like? It's actually really simple. Let's say we're building like a weather app or something and we want to do some kind of conditional on the temperature. So let's just say we have some variable temp, which is really confusing because traditionally temp means a temporary variable. So you might want to use temperature, but #rebel or something. I'm just going to use temp. All right. So if temp is less than 50, and then you might say it's cold, and then you close that. Now what you do is you put else if, and this is actually going to need another condition. So you put another pair of parentheses with another condition in here. Now, you're not restricted on what you can put in here, so you can use different variables than the if statement. Usually though, you're going to be using similar variables, but just in different ranges. So you might do something like this. Temp greater than 90. In other words, it's super hot. And then you do another curly braces pair, and then do whatever code you want for that. So now it's super hot. Lastly, we have the else. And you don't need curly braces for that. You do need the block of code, and I guess this would be average. So this is how an else if is structured. It looks exactly like the if, where you have the parentheses. The only thing is you have else space if. So basically we've given 3 variations. The if with no else, if with an else, and then the else if. Also, you can have more than one else if you would like. So for example, you could make else if here, put another condition, and then have else. So you can branch in essentially as many directions as you like. To visually see this, it might look like this. Here's some condition, and if it passes as true, you're going to execute some extra code. If it's false, it's just going to continue executing. And eventually this is going to go back onto the same branch. So just this extra code is executed, and then we're back to normal. This would be a traditional if statement. This doesn't consider the else. If with an else is going to be a little bit different in that we can branch this way as well. And now we have to go one of these ways. So we're either going to execute this one or this one, but not neither. We have to execute one of them. It's the only way to continue on in the program. The else if is a little bit different, and if I had to structure it this way, I'd probably do something like this, where we have another condition if the first one's false, and then this one can break into true and false. So my drawing has kind of gotten a little unbearable, but essentially now we have to go one of these ways. So one's going to be true and one's going to be false. And this isn't a complete illustration, and it's kind of crappy now that I think about it. After I've written it, I'm just like, this wasn't that great of an illustration, but it works. So it's just kind of a way to illustrate it, but one downfall here is that you can actually have an else if without the else statement. So you could have if with the parentheses, else if, parentheses, and both of the curly brace sets, but no else, and that'll work just fine. So this is kind of an incomplete picture, so if that doesn't help you, just ignore it. I just kind of made it up, so yeah, that usually turns bad. Thank you guys for watching. If you've appreciated this video, please be sure to give me a like and subscribe to this channel, as I'm putting a lot of effort into getting these videos out. And it's cool to have some subscribers and followers, so I really appreciate when you guys follow and watch my new videos, because that really makes my work feel valuable. So thank you. I will see you in the next video. Hey guys, welcome back. This video we're going to be talking about how to use the else if statement. So this is where I left off in code the last time I was on the computer. I'm just going to make a new file and just call it, I guess I'll follow my convention of capitals, else if. And, oh shoot, I need to name it .c. And basically what we're going to be doing is we're going to be creating a menu. And essentially a menu is going to be something that a user is going to come across when they use your application, and it's going to give them a select number of options. And this is usually done with an else if statement, or tied to an if, so an if else if statement, or something known as a switch statement, which we haven't talked about, but that is coming up in the upcoming videos. Generally, I like to use switch statements for menus, but it's really super easy to convert an if statement to a switch statement, so not a problem at all. Definitely recommend you watch this video and understand how to create a menu. So just to kind of give a context of a potential app, let's say we're making an app for a doctor's office. And we're going to do the standard boring outline. There we go. And we're going to have basically 4 menu options. And we're going to take numbers. So the first one is going to be, I don't know, let's go with add a patient. 2 will be to view a patient. And we're not going to code the actual stuff to do this stuff in this video, at least. We're just going to make the menu. So sorry if your job is to make doctor's office applications and you're hoping to get all your answers here. Search patients. And lastly, we're going to have exit. And after this, you will be a menu pro. First thing always is to give the user something to do, so they know what they're expected to do. And I'm going to do a new line because I want each one of these numbers on a new line. And I'm going to put them in different printf statements as well, just for clarity on my sake. And so it's easier for me to not go insane. And basically, I'm just going to copy this stuff up here. So the first option, add a patient. The next thing we're going to do is the if statement. And we're going to, actually, no, we're going to get the user input, obviously. So we need to say user input, and we're going to scan F. And we've done this 1,000 times, so if you haven't seen this yet, you might want to go watch all the other videos I've done. And like I said, we got to use the address of, because we're going to be giving it a pointer, and then we can condition on that. But let's just compile just to make sure everything's good so far. Okay, we have an error because there's nothing in here, so that's good. If we put true, it should compile. Oh, no, because we have to use the header. So let me just try 1. There we go. Okay, so then what we need to do is we need to basically input equals 1. We use the else if to do multiple possible ways of branching. So if input equals 2, if input equals 3, then we're going to do this. And lastly, else exit. Okay, so let's just, I'd say we should print some stuff out just so we can see this in action. In this situation, we're adding a patient, viewing a patient, searching patients, and then lastly, we're exiting. And I'm going to talk about this else statement in just a minute because it's kind of funky. So let's just run this and make sure everything's good to go. All right, so which do you want to do? Let's go with 1, adding a patient. 2, viewing a patient. 3, searching patients. And then 4, exiting. And it works. So we efficiently, effectively, and awesomely made a menu. Now, I want to talk about this else statement because in this scenario, if you type in anything other than 1, 2, or 3, it's going to exit. So if I put G, it exits. If you don't want this behavior, you need to use an else if and do the same exact thing. Input equals 4. And then say else, and in this scenario, they didn't put the right input, so you could say that. The way you do it is totally up to you. In this situation now, we have to put 4 in order to exit, which in my opinion would make more sense than just any number or any letter other than 1, 2, and 3 exits. That seems a little silly, but eventually once you get into loops, you can basically put this menu in a loop. And if they don't put any of these values, then you could loop it and ask them again. So this else statement would basically be converted to a loop and say, hey, you put in the wrong data, try again, and it would output the same menu, and then they could choose one of the options again. So hopefully that was a little bit helpful on else if statements and how to use them in code. And hopefully it's clear that when you hit this if statement, only one of these is ever going to be executed. They're not going to be able to do multiple. In that situation, you would need to have multiple if statements or put some code down here. Switch statements, they're a little bit interesting, and once we get to them, there's something called the break, which, yeah, I'm not even going to talk about that now. But hopefully you guys got a good understanding, and if you've enjoyed this, I would encourage you to check out the description because I am releasing a C programming crash course, which might be of interest to you guys. So check that out. Thank you, and I'll see you in the next video.
Hey, what's up everybody? Welcome back. It has been quite the while, but I have oathed to finish this series this weekend. So it's going to be pretty crazy, and hopefully we'll see if it actually happens, but that's the goal. This video is going to be pretty simple. It's nothing too crazy. I just wanted to clarify something that when I was a really beginner, it confused me a little bit, and I just want to make sure you guys got it before we proceed into new concepts in programming. So the main thing I wanted to talk about is what is the difference between having two if statements versus having an if-else statement. And the answer is really simple once you got it. So if you already know, sorry, you can move on to the next video. So the whole idea with an if statement is that if this condition is evaluated as true, the section inside of the curly braces is going to be executed. And when you have two if statements in a row, those are both going to be evaluated. So if we're going line by line, the first if statement's going to be hit, and that's going to be evaluated as either true or false. If it's true, we're going to go into the code block. Then we go on to the next if statement, and that one is evaluated. And if that one's true, we go into that code block. So what that means is that when you have multiple if statements in a row, you have the potential that both of them are going to execute. This is different than how the if-else works. So for example, if we replaced this if statement, if we replace this with an else statement, now only one or the other is going to execute. And the reason I bring this up, even though it's fairly simple to understand, is just so that you are clear when you're doing these conditions if something is going to execute more than once or something that you're not going to want to evaluate. So for example, let's say we wanted to build an application that would tell you if you are an adult being over the age or 18 or older, or if you were a senior being like 65 or older. If you're not careful in how you structure your if statements, you might have a little bit of an issue. And it also kind of depends on what you're trying to do in the application. So, what would our condition look like? Inside of our if, we would probably compare on age. So we could say if age is greater than 17. Or if it's clearer to you, you could say greater than or equal to 18. And then we could have something in here that says, hey, this person's an adult. And then if we had a second if statement where we have if age is greater than or equal to 65, well now this person is a senior. And the way this is structured is if somebody is a senior, both of these are going to be true, which is technically true because if you are 65, you are also over the age of 18. So the way you want your app to function depends on how you do these if statements. If you want the 65-year-old to also execute this line of code or this section of code and this section of code, then you would structure it like this. So for example, if you had an application where it's a game for kids. I don't know, this is a stupid example. If it's a game for kids and if you're between the age of 13 and 17, you just get like the normal price. Or you get like just a standard price. And then if you're 18 or older, you get maybe a discount. Okay, and then if you're 65, you get a senior discount, right? If you structured your code like this would be the adult discount. And this would be the senior discount. I could have just wrote discount, but yeah. So this is the adult discount and this is the senior discount. With this structure, if you're a senior, you're going to get both the adult discount and the senior discount. In some situations, this may work. It doesn't necessarily have to be with ages. It could be like membership status. So for example, there's a lot of crowdfunding apps, and what will happen is you can do multiple tiers. So the first tier might be like, oh, $1 a month. And if you get that, you get these rewards. And then if you do $3 a month, you get extra rewards plus all of the previous rewards. So the way you structure your if statements determines how your app works. If you want it to be one or the other, instead of using multiple if statements, you would use an else statement. So you could have an else, and actually in this situation, you would want this to be an else if, because if you just used an else, if someone was like 6, they would also evaluate in the else statement. So we would have an else if, and it would be age greater than or equal to 65, and do this stuff. So very simple differences, but you just got to really be careful when you're coding your app to make sure you're actually saying what you want the app to do. Because coding languages don't have intuition, so what you code is what's actually going to happen. So yeah, very simple, but that's all I got for you guys in this video. Be sure to check out the next one because we're going to go into some new stuff, specifically something known as a switch statement. So a switch statement is very similar to an if statement, but it allows you to code it a little bit differently, and sometimes it's more clear depending on the application that you're working on, if you want to use an if or a switch. So please be sure to check that out, and also apologize if this video was a little rough. Getting back into it for the day, so usually my first one takes a little bit of warming up. All right, see you guys, and thank you for watching. Be sure to subscribe.
Hey guys, welcome back. This video, I wanted to talk about what I like to call a single line if statement, and I guess that's what it's called. I don't know if there's an official name for it or not. But basically, we have done if statements like where, you have if, and then you have the condition, and then you have the body. Well, a lot of people like to simplify this, and they just get rid of these curly braces. And what they do is they put the body right next to the if statement. And that's what I wanted to show you guys today. It's really simple, so this video is not going to be too crazy complex, but I'm going to create a one-line if statement that is very easy to read and very easy to write. So we're going to do a printf, and this is our if statement. Oh, gosh, why can I not type? Golly. Okay, so this is our if statement, and it is a working if statement, and I'll show you that it is. So let's compile this. And I got an error. Okay, so if true, I got to include the standard bool. So, or you could just put 1 there if you'd prefer. Okay, so it outputs true. And I can tell you that it is a working if statement because if we put false here, it's not going to do it. See, there's no output. So it is a functional if statement. And these are interesting because they, in my opinion, they do make it easier to read because it's just very simple. It keeps the line count lower and it's just really easy to see what's going on. One issue though, and this is when I would say to not use one of these if statements, is if you decide that you want to put this on the next line, that is where, I wouldn't do that if I was you. And you can see it still works. So I could still execute this as if it's a normal if statement. And I see a lot of if statements like this. And I would say that this is a very bad coding practice. And the main reason is because one day you're going to say, oh, you know what? Since this is true, I'm going to do this plus something else. So you might go down here and let's just say, I don't know, let's say we have a score or something. We might say score plus plus. But the thing with these if statements that don't have the curly braces is that it only executes the first one after the if statement, which means this is going to happen all the time. The first statement is the only one evaluated. The second statement happens all of the time. So if we print out score, let's just try this with true and then try it with false. So it's true, it prints out 6, if you can see it right there in that bottom. And then when I make it false, I'll also do a new line here. You can see it also prints 6. So either way it prints 6, which is definitely a problem. Like if you know what you're doing, it's not a problem, but the issue is it's indented, so anyone's going to look at this and assume it's supposed to be part of this if statement, when in reality it should be back here. And it's just something that can really easily happen if you're not careful. So my rule of thumb is that the only time I ever use these if statements is if I put the statement that I want to execute on true on the same line, because I've drilled that into my brain. Thus, anytime I see like this here indented, I know something's not right. It's giving me this odd feeling, and I should probably bring that back here. Or if I actually do want this to increment when it's true, then I would use curly braces like a normal if statement. So those are your options. It's up to you if you guys think this is a good coding practice. And also, just wanted to show you guys one other thing, is, we might put a semicolon here like this and put this print statement right here. And let's say this is false. Let's execute this and see what happens. So this gives us a warning. Now let's run it. You can see that it prints true and 6. It prints true even though it's false. And this is interesting because this is a legitimate statement. So as a result, if this is true, and we output it, it still executes true, because this is the only thing that's happening when this is evaluated as true. So this is not going to run in other programming languages. Like if you were to do this in C#, it probably isn't going to work. And as a result, C is a little bit more dangerous. So just be really careful not to accidentally put a semicolon there. All right, that's all I got for you guys. Hopefully that was nice and clear, and that you understand the single line if statement. All right, thank you guys for watching. If you've enjoyed this series, please be sure to check out the description where I'll have a link to my C programming crash course, which is a whole series of fun and brain explosion. So definitely something you'd be interested in. Basically, it's going to encapsulate all the content from this series, but it's going to do it a lot quicker and without a lot of the fluff. So not that I'm intentionally fluffing this, it's just that I like to explain things in a lot of depth, but the crash course is more for review and prep for interviews, so it's going to be straight to the point. So thank you guys, and I'll see you in the next video.
Welcome back, everybody. This video we are going to discuss the switch statement. Now I got some code up here, we'll look at that in just a minute, but before we start I just wanted to clarify that switch is very similar to if. It's different in structure, but it serves the same purpose, right? So the purpose of a switch statement is to branch based on certain values. And when you use an if statement versus a switch really depends on what you're trying to do. Switches are very good for comparing, like let's say we have a simple number like level, like for a video game or for like a gym membership, what level are you at? And we have different values like 1, 2, or 3, or 4. It makes it very easy to branch on those different values. If statements allow us to do more complex comparisons in the condition section of the if statement. So if you are trying to do something a little bit more complex, an if statement might be better. Personally, I think switch statements are easier to read when we're branching on some very clear variable. So with that, when do you use which? It's ultimately up to you, but after this video, hopefully you have a clear understanding of what a switch statement is and what it does and how to use it. Okay, so let's get started. So we have a variable int level, and its value is 1. And what we do is we create a switch statement by just saying switch, that's a lowercase s, and then in parentheses we put that variable name that we're going to kind of break or branch our program on. And then we put the curly braces similar to the body of an if statement. But it's a little bit different because inside of these curly braces, what we're going to do is we're going to have different cases. And the cases are like the different value possibilities for this variable. So for example, we might have case 0, and then we put a colon, not a semicolon. And then after the case 0, we can put the code of what happens if the value is 0. I'm just going to put a comment, code. And then at the end of the case, you use what's known as the break keyword. And this is a little odd, but you have to put the break keyword, and basically that says, hey, I'm done with case 0. We can break out of this entire switch statement and proceed to whatever's after the switch statement. Then what you do is you can put the next case. So you could say case 1. And then you put the code, and then you have a break. So after every case, you need to have this break keyword. And it's vitally important because if you don't put this break keyword, the code is going to go through the cases continually, even though you may have already executed one of the cases. So the break is important to stop the execution of the different cases. And if you don't do it, it's a common mistake, and it's called fall through or something like that. Basically, your code's going to fall through all the different cases, even if you don't want it to. Once you got all the cases written out, you're going to have what's known as a default. This is very similar to the else statement attached to an if statement. And it works the same way. And you even actually have to, well actually I don't know if it's required or not, but you have to put in my rules, you have to put break at the end. I don't think it's required, but it's a good programming practice because the actual order of these cases doesn't matter. So one day you might decide, hey, it would be more clear to me if I put that default case at the top. So you might cut and paste that up at the top. And if you don't have that break statement, you might forget to add it, and it's going to fall through from the default down to case 0, which you don't want to do. So just for best programming practices, every single case, including the default, needs to use that break keyword. Some different languages are going to require the break keyword, even if it's at the default at the last. So just keep that in mind. It's the best thing that you need to do. Now, where do you put the code? Always right before the break. So the code would go here, it would go here, and it would go here. And you can put any code you want, just like within the curly braces of an if statement. So this is the structure of the switch statement. And you can see it's very simplistic in this situation. All we're doing is we're looking at the value of one variable, and just a very simple integer, and we're looking at whether it's a 0 or 1. You could have more cases if you wanted, but just for illustration's sake, I'm just using 0 and 1 and a default. Now remember, the default is going to catch if none of these cases happen. It's going to be like a catch all. So this is the equivalent to the else statement of an if, else if, and then an else. So if we wanted to basically convert this to an if statement, I'm not going to write it all out, but I'll kind of give you a structure. It would be like if level is 0, that would be this case. And then else if level is 1, oh, I'm running out of room. You guys probably can't see that, but it's okay. That's going to be this case. And then lastly, we'll have an else here. So that's all I got for the switch statement in this video, but be sure to check out the upcoming videos because we are going to go through examples of switch statements and get some hands-on practice with that. So thank you guys for watching. Please be sure to subscribe and be sure to, check out the next video. By the way, I wanted to do a quick announcement that I'm intending on releasing a C programming crash course, which is going to basically take all the content in this course, condense it, cut down anything that is repetitive or that's not really necessary, and give you the nutshell important stuff from this course. And I'm going to be putting that on my website. So please be sure to check out the links in the description if that's something you're interested in. If you need to learn C programming quick to get a job or to learn for the job, that's the course for you. So thank you guys for watching. Be sure to check that out, and I'll see you in the next video.
Hey guys, welcome back. So this video we're going to be talking about the switch statement. Now, this is totally random, but the other day I was talking to my friend about how luxury cars have heated seats, and I was thinking, wouldn't it be cool if you could get luxury laptops with heated keys? Because I always get like cold fingers and then my typing gets terrible. That's just my excuse for not being able to type a sentence without a mistake. But anyways, the switch statement is very similar to the if statement, as I've mentioned, and basically we are going to ask, in this little app scenario, we're going to ask the user, this is a diet app, by the way, so we're going to ask the user how many slices of pizza they've eaten, and we're going to rate their diet and tell them if they're doing a good job or not. Yeah, totally useless, I know, but kind of cool. And this is like the basics, once we get this foundation, you can generalize this to actually building a good diet app. So these are just the basics. But what we're going to do is we're going to start with just hard coding the number of slices that the person ate, and then eventually we're going to get that from input. But I just want to focus on the switch statement for right now, so I don't want to get distracted. So the way you write a switch is you say switch, and then you put the parentheses, and then you put the variable you're doing the conditioning on. And then everything goes inside of these curly braces. So what you want to do is you have different cases. So case 1, you do something. Case 2, you do something. See, it's some cold fingers. I can't type, gosh. And then case 3, oh man, my hands are freezing. And lastly, we're gonna have a case 4. And When you have all these cases, this works, but there's something you always got to remember. Once you finish your cases, you need to put a default. I mean, actually, I don't think it's required, but if you want to do like a catch-all, then you would want the default. Okay, now before you start coding, there's one other thing you need to do, and that is you need to put a break statement after each one of these cases. The break statements prevent fall through, and we'll see that in just a moment. And even on the default, I like to put a break. Okay, so inside of here is where we can actually do code. So all your code needs to go after the case label and before the break statement. And here you can compliment your users for doing a very good job for only eating one slice of pizza. But clearly you can see that they actually ate 3, so that one's not going to be the case. And then I'm just going to do a couple different versions. Two next time. And then case 4, well, you know, I'm not even going to say much for that. Oh, shoot. Okay, print F. You're a disappointment. Okay, and then the default is, you know, if the slices is greater than 4, I guess technically if the slices was 0, the default would be hit. But in my brain, this switch is only ever going to get hit if the person says that they ate pizza, which assumes that slices is going to be at least greater than 0. So let's go into this default and make a printf saying that you really need to eat less pizza. Okay, so now what I want to do is I want to run this. And see what happens. You did a bad job. Try to eat 2 next time. Okay, so that is because we hit case 3. And you can see that this case number correlates to the value of slices. If we put slices to 1, which who would want to go down in their pizza consumption? That's ridiculous. Now it says you did a great job. And lastly, let's go to the default case, which is, you know, when you're really hungry. Enjoy your heart disease. And you could go add new lines if you felt like it, but I always have to end up adding new lines because I forget and it takes a bunch of time and it doesn't really serve much benefit just for the sake of learning how to use a switch statement. Okay, now let's try getting rid of these break statements and see what happens. And let's and also we're going to change slices to 1. You did a great job. You did an okay job. You did a bad job. See, the program can't make up its mind on what to do because what happens is it goes into case 1, executes this, and then it falls through and ends up executing all of these lines. And I think that's all that I wanted to cover. I did want to get this from user input though, so I'm just going to do that. If you've seen this before, then you can go ahead and move on to the next video if you want, but just for fun, I'd suggest you do it as well and for some practice. So we're going to have int slices scanf. So yeah, we've done that about 1,000,000 times. And we need to tell the user what to do. And then eventually I think I'd like to make a calculator that kind of calculates some of the calories. So I'm going to do calories per slice and set that equal to 250, which maybe that's something the user could configure, or maybe depending on the type of pizza that could be changed. And then maybe down here we can just print out you had X calories. And by x, I mean we're going to pass in the calories per slice multiplied by the slices. And then do a new line. Whoops, okay, and then A dot out. How many slices you eat? Let's go with 3. You did a bad job. Try to eat 2 next time. You had 750 calories. So that is how you create a switch statement. Now, a while ago, we created an if statement for, what was it? Let me see, this coding challenge maybe? Oh, nope. Maybe it was the else if. And here we did something very similar where we created this menu. And this, I said that it would be very easy to convert this to a switch statement. So my coding challenge for you is to go back and watch my hands-on video on else if, make sure you got this menu written out with if statements, and go through the practice of converting this to a switch statement, trying all of the possibilities of input, and making sure that things work out right. Once you got that down, you should be pretty solid with switch statements. They're not too crazy. Just make sure, please, for everyone's sake, don't forget to put the break in after your labels. Okay, that's all I got for you guys. Be sure to check out the description for my C programming crash course, which is going to contain all the content from this video in a condensed, more manly version. It was the first thing that came to my mind. Okay.
So I don't know if you guys saw my puppy, but she is getting huge. Say hi. Say hi. Welcome back, everybody. This video, we're going to be talking about whether you should use an if statement or a switch statement. So when I introduced the switch statement, I said there were some little differences between ifs and switches. But in general, they can do some similar things. This video I'm going to go in a little bit more depth and just talk about the situations where a switch statement is not a good choice and you would want to use an if statement. But, sorry, I'm out of breath. But before I get started, I just wanted to tell you guys that I am actually releasing a C programming crash course. So it's going to be all of the content in this series, or maybe not everything. It's going to be the majority of this content in this series and maybe some extra condensed into a nutshell crash course video that is going to give you what you need to review everything in C programming that we talk about in this course, as well as prepare for any C programming jobs, or just to refresh your skills if you know C, but you don't necessarily want to watch a 100-part series to refresh yourself. So be sure to check that out. I'll leave a link in the description, and hopefully if you guys want to pay me millions of dollars, it'll be a good, valuable tool for your education. All right, moving on. So the switch statement is good for integral numbers. Integral variables, I guess I should say. So integral means integer type. So that means you can't use a switch statement for a double, for example. So the first thing is integer data type. So that's number, oops, I wrote that in the wrong spot. Meant to write that up here. So here is switch statements. The first thing, you want to use it for ints. The second thing is that it's not suitable for ranges. And the third thing is that it's usually suited for a limited number of options. So you might be wondering, well, so far I haven't heard of any limitations of the if statement, so why would we use a switch statement? Well, that is actually a really good question. And honestly, there is no reason that you couldn't just program using if statements. There is nothing that a switch statement offers that is not possible with an if, else if, and else. That being said, personally, I believe that the switch statements are clearer for certain situations, such as menus, and I'll talk about that in a minute. But, and also you're going to run into switch statements when reading other people's code or picking up open source projects or whatever. They're very common, so it's important to know how they work even if you don't necessarily use them. But as a noob, as a beginner, you don't need the switch statement. So if you're overwhelmed with things to learn, you can just forget about the switch statement for now and just know that it exists and understand the if statement a lot more in depth. But once you got the if statement down, you're going to want to come back and learn the switch statement. So let's just dive into these a little bit more. So the first thing
is it's for integers. You can also use character data type because if you guys remember from the previous videos that characters translate to integers by the ASCII table, so you can check that out, and I did videos on how to convert between the two. So this is suitable for ints and characters. Inside of a switch statement you have the cases and then you have a number. So you could say something like case 3 and then you put a colon. Well, this is one individual number and it's not a range. So with an if statement you can do something like this. X is equal to 5 and y is greater than 10. So you can see two things in here. For one, there's two variables, and for two, we have a comparison operator. Comparison operators are not suited for switch statements, but only if statements. Switch statements just use one value for the case. Because of this, it makes the possible uses very limited. So usually with a switch statement, you'll have a finite number of cases and then possibly a catch-all default. But the finite number of cases usually correlate to something that each one has some kind of meaning. So a good example of this is a user menu. So when you're writing a console application, you might start the application and you might ask the user, hey, would you like to load a file, or would you like to, let's say it's a game. You could play the game from the beginning, or you could load a game, or you could save your game that you're working on, or you could exit, or you could look at high scores. There's a finite number of possibilities, and usually that is best represented with a switch statement where you can say, case 1, they enter the value 1, let's play the game from scratch. Case 2, they enter the value 2, let's load a game, and so forth. You can do the same thing with the if statement, but the switch statement is just that much clearer. So hopefully this video helped you understand a little bit more about what the switch statements are not going to help you with. And in the next video, we're going to be talking about some new stuff, so please be sure to check that out. And let me know what you guys think in the comments. Thank you, and I'll see you then.
Hey guys, welcome back. This video we're going to be going into some more on the switch statement and just talking about some different tips I got for you guys. So a couple videos ago we talked about this switch statement where we basically get the input of how many slices of pizza someone ate and then we judge their diet to make them feel bad about it in the case to follow, in the switch to follow I should say. And basically, I wanted to talk about some other things. So if you remember from a long time ago, I talked about how characters were directly translatable to integers. And in fact, they're one-to-one, essentially, because off of the ASCII table, every number has some integer. So to see that, what we can do is we can print a number as a type character. So, for example, using the C for the conversion character, we could pass in the number 65 and see how it prints as a character. And I'm also going to do a couple new lines just so you can see it clearly. Okay. So you can see that this outputted the value A, because on the ASCII table, A is directly convertible to 65. And with a switch statement, you can use any data type that's directly convertible to an integral data type or something of type int. And the three are integers, characters, and enumerations, which I don't think we've talked about. An enumeration is basically a data type that allows you to choose from various options. And that's not something we're going to get into right now. We're just going to focus on characters, but just want to be clear that because characters are directly convertible to integers, you can use them for switch statements. So for example, I could say switch, and the thing we're going to be testing on is, well, I guess I should make a variable, and v equals v, creative I know, right? And we can switch on that variable. And then the cases, you could use the numbers. I don't know what v is, so let's just go with capital A. And we could say switch on v. I'm just going to change it all, make it easier. Case. And let's say the value is, you can either use the character, so for example, case that it's A, then you can do something, or you can use the numeric equivalent. So I could use case 65 here because that is the equivalent for A. And don't you forget that break statement. And you can see it does hit that case because the value of A is most definitely A. But just the same, you could do this. And that'll work the same way. And it works. So that was my first tip, is that you can use a switch statement for character data. The second tip that I have is that you can actually have multiple cases for one section of code. So I'm going to go to the pizza example that we have below because we already have a nice switch written out for us. So let's get rid of all this stuff. So let's say in this dieting app, anything under 3 pieces of pizza, or 3 or under, let's go with that. Anything 3 or under is considered good, which, you know, that's in my diet app, it seems pretty good. So what we're going to do is, instead of having these different options for 1, 2, and 3, we're just going to say you did a decent job. Or we're just going to say a good job. So anything 3 or under is good in this diet case, in this diet app. What we can do is we can just get rid of these other blocks and just have them all as one, like such. So let me X out of this and compile. How many pizza slices you eat? And if we put 1, you did a good job. And it says you had 250 calories. If I do the same thing and I put 2, it says you did a good job. You had 500 calories. And lastly, if I put 3, you did a good job. You had 750 calories. So the main thing I wanted to show you here is that you don't always have to have the same line of code repeated. Because if you couldn't do this and you wanted to say you did a good job, you would have to take these 2 lines of codes and paste them for case 1 and case 2, which in this case, pun intended, you're not going to have to do that because you could just put them for case 3. So I think that was basically everything I had to say. So hopefully that was helpful for you guys and helps you get a little bit more familiar with the switch statement. Thank you guys, and please be sure to subscribe and also check out the description because I have a link for a C programming crash course, which is basically all the content in this video series condensed into one really awesome package. So check it out. See you guys.
What's up, everybody? This video we are going to be talking about some of the... Hold up. I just wanted to mention before we get started, I am releasing a C programming crash course, which is going to be basically everything from this series, but condensed into everything you need to know as fast as possible. But it's a really great way to learn if you're rushed on time or you're preparing for a job or you just need to review your C programming skills, but you don't feel like watching a 100-part series. So please be sure to check out the link in the description if that's something you're interested in. And now let's get started. This video is going to be talking about some of the more complex parts of C programming, specifically something known as the input stream. So when we type in the console, that goes to a temporary location. It allows us to temporarily store data to be assigned to variables, and that is known as the input stream or buffer. So that really didn't make any sense. Let me visualize it. So this is our keyboard. We have all these keys and we're pressing them and we're typing words. Well, this goes into the buffer, which then gets used to assign to variables, for example, like the variable D or whatever. And you can think of this, this stream as a sequence of characters, right? So let's say we create an application and it asks for your age. Well, let's say we put in the value 32 and then we press enter. Well, what actually gets put into the input stream is a 32 and then the new line. So when we're using input functions
they're all going to work with this input stream slightly differently. And so far we've talked about scanf. It's the most simple input function, but it's not the best for protecting against user input issues. So it's okay for beginners, but as you start making more complex C programming applications that are going to be released to the public, you might want to look into some of the different input functions. In general, I think there's some other more important things in C programming that you should focus on first because you're a beginner, so I wouldn't get so tied up on how the best optimized way to get user input until you're actually legitimately releasing an application. Right now, scanf is going to serve you just fine, and that's probably what I'm going to be using for the upcoming videos. So how does scanf work? Well, if we say scanf, and then we pass in a string expression such as %d. This means we're going to get some integer data. You could also use %i. And then we're going to store that in the variable d. Well, what's going to happen is it's going to take this number, assign that to d, and this new line is going to be stuck in the buffer or the input stream. So what that means is if we do another scanf, there's a possibility it might just grab this new line character and it's not going to ask the user for more input. And this is really annoying and really confusing because it doesn't happen all of the time. And this is what I'm saying. This is like, why the heck does it have to be so complicated? Why can't it just be consistent and make sense? You have to know you have to understand it at a pretty deep level to really make sure you're getting user input right. So for example, if we asked for another integer data, it's going to look at the input stream, see this new line, and it's going to ignore it, and then it's going to ask the user for more input. So we could say 23 the next time. Well, it works fine in that scenario, which is great, but what if we asked for a character? So instead of a number, we asked for a character. Well, now this new line is a perfectly good character, right? So it's going to grab that character and assign that to whatever variable we're using in this function. So in that situation, it's not going to ask the user for more input. And half the time it works. When you're getting numbers, it works. And then when you're getting characters, it doesn't work. So what you need to understand is that when you are using scanf multiple times in your program, sometimes you have to flush the input stream and basically get rid of any new line characters. And you can do that with a function called getChar or getChar. And what this is going to do is it's going to just get the one character from the input stream. So assume we haven't entered this in yet. We just put in 32 and then press enter, and then we run getChar. Well, it's going to grab that new line. So you're going to want to put this in between any scanfs where you assume there might be an issue. So in this situation, if we wanted to get a number and then we wanted to get a character, we would want to flush that input stream using getChar or getChar. I like getChar because it sounds like you're going to go get a car. That's all I got for you guys. Hopefully that was helpful. Very odd. I would encourage you to do some research on this because I'm sure I'm not giving the best explanation and I'm not giving the fullest explanation because this is by no means my expertise. Also, I would encourage you to explore some of the different input functions and how they are different than scanf. So thank you guys. I'll be sure to keep in mind when we can utilize these new learnings in upcoming videos. And that's all I got for you guys. So thank you for watching. And don't you forget to check out my C program. Hey guys, welcome back. This video, I wanted to talk about nested if statements. And I'm going to be building off of the code we had from a previous video where we talked about else if statements.
And if you didn't watch that video or you're just jumping in because you need to know about nested ifs, that's okay. It's nothing too crazy. Basically what happens is we ask a user to select a menu item, and I can just show you what happens when we run this code. So, oops, gosh, there we go. Okay, and then we run it. You choose a menu item, and depending on what you click, it prints out a different statement. And let's just go with 4, for example. It says exiting. Well, what I want to do is I want to basically create a system that saves our changes. And I'm not actually going to save our changes in like a file or a database. That is something you could do if you so wanted to. It's not too crazy complicated. You could just write down the state of your program in a text file, and when you open your program back up, you could read from that text file. But I'm going to simulate that, and what I need to do is basically say, oh, you hit the exit, so do you want to save your changes? If they say yes, I'm just going to print F saving changes. If they say no, then I'm just going to say, well, fine, forget you, and then I'm going to exit the program. And this will basically enable us to practice our nested if statements, because you see, we have an if statement and we only want to execute this new saving if statement if we're in this else statement, or this else if statement. So we're going to have an if inside of an if. And honestly, it's not too crazy. If you just kind of pretend you're not in an if statement right now, you're just by itself, then you just write everything as if it's normal. So we first ask them if they want to save. My cold hands are acting up. And what we do is sorry, I keep saying I hate that. Man, I watch videos and people say and I'm like, gosh, that's so annoying. We're gonna make a variable. I'm just call it Q for quit. And it's gonna be a character actually, so Q. And we're gonna scan from the input. It's gonna be type C. And another thing in this video, we're actually going to be talking about an issue with the input stream, which we talked about in the previous video, and we're gonna get some practice fixing that. So hopefully that'll be helpful for you guys who need to know more about input and output. So we're gonna take this character and we're going to store it in Q. And what now? We're going to basically condition on that. I'm gonna use an else if because I wanna have an interesting else statement just to show that you can do all 3 of these inside of any other code block. Okay, so what we need to do is we need to compare the value of Q to what would be considered yes, which would be a Y, or if Q is equal to a lowercase y. Because if you remember from the ASCII table, it has uppercase characters and lowercase characters. So these are 2 distinct characters. So you might want to say yes or no, but sometimes people just will put the lowercase version, and that'll be all they do. In this situation, we're going to print saving changes. Else if, let's say Q is equal to capital N or Q is equal to lowercase n. This situation, we're just gonna say fine, whatever. And lastly, if they put something else in, you can basically assume they're trying to be a hacker. So we're just gonna call them out. Hacking detected, self-destructing in 5, 4, 3, 2. I know, I'm so childish. All right, let's give this a go and see if we got it working right. We want to quit.
Okay. What is going on? It's just spitting all this junk out. Oh, man. Let's try to figure what is going on here. Exiting. Do you want to save? Yes or no? And then it just barfs everything. Well, this has to do with that input stream issue. And in order to fix this, because if you scroll up, you can see we do a scanf here, and then we do another scanf down here. Well, the way the input stream works is like, let's say I put in the value 23, and I'm just commenting it out. 23, and then I press enter. Well, that's going to put a new line. And then I try to get another character. Well, the variable is just going to grab this new line. And that's going to just really mess up our program. So what we need to do is we need to get rid of that new line by getting a new car. All right. So to do that, we just say get car, and that's all we got to do. Oh, and the location where you put it is actually pretty important. You definitely want to put it before the second scanning. So we can put it right here. Now let's try and see if this works. 4, exiting. Do you want to save? Let's try yes. Saving changes. And lastly, I'm going to make this a little prettier. There we go. Now let's try it again with no. Fine, whatever. And lastly, let's try it with something else. Hacking detected, self-destructing. Boom. There you go. That is how you do nested if statements and also clear out the input stream when you are trying to read a character. So hopefully that was helpful for you guys. Please be sure to check out the description where I'm going to have links for the C programming crash course, which would be great for you guys for a review after this, or if you're trying to prepare for an interview or a job, or you just like spending money and helping content creators. Go check that out for me, guys. Really appreciate it. And definitely don't forget to subscribe. I'll see you in the next video. Hey guys, welcome back. This video, we're going to be talking about the ternary operator. I'm in a new C file called ternary, and you can follow along. So what is the ternary operator? So this is essentially another way to do an if statement. Very suitable for small-sized if statements. So I'm going to basically write an application that will tell you if you have enough money to purchase something. And we're going to start with an if statement, and then we're going to basically convert this to a ternary operator. And it should be fairly simple because the comparisons and stuff are not complicated by any means. So the very first thing is we're going to have 2 variables, and they're going to be of double type. Or type double, I guess I should say. And we're going to have another one, cost. And obviously, the way life works is we never have enough money, so gonna make that one more. And in the if statement, what we're gonna do is say, if money is greater than cost, then you can afford it. Otherwise, well, I guess you can't. And also in here, I just want to kind of tell them how much more money they would want. Or need, I guess I should say. And the format character we're going to use for this is LF. Just like that. Okay, so let's just give it a try. Oh, more? Oh, duh. All right, we need to actually put that in there. And the way we figure out how much more money we need, we take the cost and subtract how much money we have. Sorry, bro, you need 5 more monies. Perfect. So we have the if statement, and it works. But now I want to convert this to a much, much simpler ternary operator. This is also known as the conditional operator, by the way. And the way it works is you first put the condition. Or at least this is how I think about it. And then what you do is you put a question mark. It's kind of like you're asking a question. Is money greater than cost? If it is, what comes next is what happens. So we could do a printf statement here, and actually I could just copy this whole line. Sometimes when I go to copy things, it's probably just faster to type it out because it takes me forever. Like, seriously. So this is what's going to happen if it's true. And notice I deleted that semicolon. You don't want to use the semicolon, but you do want to use a colon. Now you put what's false. So you just take this printf statement and paste it there. And I'm going to just comment out this other if statement so I can keep it there for reference. And now let's see if it works. Sorry, bro. Same exact output. So let's just change this up and see if we can get the true one to work. You can afford it. Yay. Awesome. So you guys can see how the ternary operator works. The thing with the ternary operator is, at least for me, I can never remember the syntax. Like, even making this video, I was like, oh, I have to reference, which is sad because it's really simple. And honestly, I never really even thought of the whole asking a question thing with the question mark until just now, which actually kind of makes it pretty easy to remember. You just have a question, and then you have the true with a colon and the false, and the semicolon goes at the end. So if you can get the syntax down, awesome. If you can't, you might just want to consider sticking to the basic if-else statements. Either way, it's up to you, but obviously the first line, much more condensed, much more to the point, versus this with all the new lines and the curly braces. So hopefully that was helpful for you guys and that you have a really good understanding of the ternary operator now. And if you've enjoyed this series, please be sure to check the description for a link for my C programming crash course, which is going to give you basically everything you need to know from this course in a condensed manner, designed for hands-on prep for job interviews or just to get a review of everything we talked about. So thank you guys. Please be sure to check that out and also be sure to subscribe. And I'll see you in the next one.
Hey, what is up everybody? It is Caleb. In this video, we are going to be talking about loops. So up to this point, our programs have been fairly linear or like one step after the other going in a straight line. And we can branch, which just allows us to go straight in like a different direction. But now what if we want to like go back and do something again? Well, that is done with a loop. So loops allow us to do some section of code as many times as we would like. And by the way, I want to throw out there that, you know, if you're enjoying this series, but you would like to get the crash course version, be sure to check out the description in the description below. Did I just say that? The link in the description below. That's going to give you everything you need to know in a reasonable length of time. And yeah, that's going to be great if you need to study or prepare for a job. So be sure to check that out. You can get all the notes and the crash course down below. Okay, so this video we're going to be talking about loops. Now loops, they are dangerous because you can create what's known as an infinite loop, where you basically just execute the same line of code over and over and over again until your computer explodes, which is what we don't want to do, right? So we have to be very careful in how we structure our loops. There are 3 things you need to consider when making a loop. And then we're going to be talking about the different types of loops, and then in the upcoming videos we're going to be doing hands-on with these loops so you can get to practice making them. So the very first thing is the initialization. The next thing is the comparison. And then the update. And one of my computer science teachers explained that I could remember this ICU, which I don't know if that's going to help anybody or not, but it works. So what exactly does this mean? So when we want to do a loop, we need to figure out when we're going to start and stop the loop, right? So like, let's say we want to execute something a certain number of times, we need to say when we're going to stop. So the first thing we do is we set the value of some variable to a number, like let's say I equals 0. That is initializing because we're saying, hey, I is 0. We initialize the variable, and if this doesn't make any sense, just wait, it will. I is 0, and then we want to increase I until we get to I is less than or equal to 10, for example. So this is the comparison, and then the update is
I++. So here are all of the pieces. We start at 0. We're going to keep doing the same thing until I is less than or equal, or while I is less than or equal to 10. And then every time we do it, we're going to increase I 1 time. So you can see how this makes a loop. We say where we're starting, how we know if we're continuing, and what we're going to do after each time so we get closer to finishing. So these are the 3 pieces, and it can be a little bit confusing at first, but once we go into the next videos, we're going to be talking about the for loop. You're going to be able to visualize all this very simply and create a simple loop. There are also 2 other loops, which is the while loop and do while loop, which what all of these have in common is they all need these 3 things to not create an infinite loop. So guys, go check out the upcoming videos because we're going to be breaking down loops and making them very simple. So far we've talked about if statements, switch statements, and ternary operators. All of that is very important, but that doesn't allow us to create complex applications. Because for example, if we wanted to make a menu that asks users what they want to do, and we want to be able to do this forever because they can use the application as long as they want, we need some sort of looping system. So go check it out. Thank you guys. Hopefully this video just helped you understand the 3 points of loops. Once again, just to repeat, we start somewhere and then we increase some number until this condition is no longer true. You can think of it like going around a race car track. We start with 0 laps. Every time we go around, we increase our number of laps, and we stop when we get 10 laps. So as long as it's less than 10, we keep driving. So thank you guys. Hopefully that was helpful. Please be sure to subscribe. Definitely helps me out, and I appreciate every time someone subscribes. So thank you, and I'll see you in the next video. Today, we are going to be talking about for loops. But before we get started, I just want to do a quick interruption by our wonderful sponsor, me. This video was sponsored by my C programming crash course, which you guys can check out in the description below. It'll give you everything you need to know in a reasonable time frame. So it's cool. Okay, so back to the point of this video, which is for loops. Okay, so in the previous video, we talked about loops in general, and we described the 3 pieces of these loops, which is the initialization, the comparison, and the update. Now, the for loop allows us to very easily see this in code. That's why I recommend starting with the for loop versus the while loop or the do while loop, which we'll talk about in upcoming videos. So let's just write out a simple for loop that's going to execute some code 10 times. 10 times. Okay. So you start with the keyword for. Then you just follow that pattern. The first thing is the initialization. So you can actually create a variable in here. Typically it's known as I, and partially you can think of it as an iterator, because every single time we go through this loop, it's called an iteration. So each iteration, we can keep track of what iteration we're on using this variable I. And we'll see what that means in just a second. But for now, just know it's typically called I if it's something very simple, but you can use anything in these for loops. And my camera, you better not go out of get in focus right now. Oh, see, I don't use manual focus because then what happens is my video is out of focus the entire time because I literally am terrible at camera work and I can never get it right. So if you guys got some tips, leave them in the comments. Anyways, first thing, initialization, int I equals 0, and we end it with a semicolon. Then we do the comparison, while I is less than or equal to 10, and then we do the update, which is usually something like I++. So you can visually see the 3 points. The first thing, the initialization, comparison, update. Then you have curly braces, and this defines what's going to happen 10 times. And this here is what determines how many times we want to loop. So as long as this is true, it's going to execute. So we can put our code in here, and we can kind of just go through how this works. Very first thing is the initialization, and it only happens once. So we set the value of I to 0. All right, I put it on manual focus because it's driving me crazy. Okay, so the next thing is the comparison. If this evaluates to true, we execute this section. So this actually happens after this. So we execute all this code, and then we increment I. And after every time, this is going to increment. And after every loop, we then do another comparison. So we start here, initialization, comparison, loop, update, comparison. And we repeat that until this is evaluated as false. Once it's evaluated as false, we proceed down past the loop. Simple as that. Now, the variable I can be used to basically go through arrays or to change what's being executed in this code. So for example, we can print the value of I. And since the value of I is being increased every time, we can use this to count. So if we printed this out, it would print 0, 1, 2, all the way up to 9. 10 times starting at 0. If you wanted to do it from 1 to 10, you could just print I plus 1. And you can do all kinds of things. For example, if you have an array, well, you can access the index using I, and that'll allow you to iterate through arrays. So, very cool. Next video, we're going to get hands-on with this for loop and create one of our own. So be sure to check that out. Thank you guys for watching. And yeah, sorry if my camera has been a butt munch. Be sure to subscribe. Peace.
Hey guys, welcome back. This video we're going to be talking about for loops. So, a for loop is just a really easy way to loop through code a specific number of times. And all loops, like I said in the previous videos, are going to need an initialization. By the way, we're in a new program, loop.c, and you can follow along. It's going to need a comparison, and it's going to need an update. And this is very easily seen with a for loop. So the way a for loop is like this. And this first thing here is we're declaring basically a variable to increment as we go through the application. Now, I'm not positive, but I'm pretty sure in order to declare the variable within the for loop, you need to be on the newest version of C. So if you need to basically get around that, you can just declare it up here and then say I equals 0. But for me it works, so I'm just going to do int I equals 0, and that is our iterator. The next thing what we're going to do is we're going to do a comparison. So this is how many times you want to loop. And I'm going to do this as long as I is less than 10. Lastly, we need to have an update, and typically you'll see something like I++. Inside the body of this for loop, we can do whatever we want. Typically, I will be used within this for loop. Not all of the time, but often. So in this case, we could just print I. How about that? And let's execute this and see how it goes. Okay. Moron. I did them backwards. Okay, 0 through 9. So it printed 10 numbers, starting with 0 all the way up to 9. And you can change this by altering the start and the end, but typically I like to keep it in this structure where the first one equals a value and then the next one is less than a value. You can also do less than or equal to 10, like for example if you want to go all the way up to 10 and include it. Let me compile first. That's going to print out 11 values including 0. And if you want to get rid of that first one, you can just increase the starting value. And you can see now it starts at 1 and goes up to 10. There's different ways you can write these, and the most important thing is just to be really careful with the starting and the ending. Like I've talked about in other videos, edge cases are usually where programs break. So if, for example, you're working with a string or an array, and let's say there's 10 elements and you're starting at 0. I don't know if we've talked about arrays yet, but basically if you're going too far past just one past the end of the array, you're going to access an area of memory that you're not allowed to access. So just for consistency and for my sanity, whenever possible, I always try to keep this side on the less than, and this one just stays normal, so I can change this however I want. If I want to go from 1 to 9, it would look like that. If I want to go from 0 to 9, it would look like that. And the main thing is just consistency. If you truly understand the beginning and the end, then it's a lot easier. But I always find myself getting a little lost, and then I'll usually have to do stuff like try adding an equal sign or trying increasing this one. And as you get better, it becomes easier. Now I usually don't have any problems, but I'm not going to promise and say that I never have problems, especially when I'm using variables. Which, speaking of variables, it's very easy to get this value from a user. You can just do it like we normally do. So we can say the max value, and we can get that from scanf. And then instead of comparing to max, or to 10, we can compare to max. Okay, yeah, I gotta put this in a string, obviously. Okay. And then we can put in a value, 500. Or I only put 50, sorry. And it goes from 0 to 49. If we wanted to go from 1 to 50, like I said, just increases to 1, max plus 1. See, that's what I do. I put plus 1. Instead of comparing less than or equal to, I always keep it on the less than and just change the value over here. That is personal preference. You can do whatever you want. Now it's going to print from 1 all the way up to 50. So that's pretty cool, and I think that kind of covers everything we need to go over with the for loops. The main thing is that just be careful with the edge cases, and also know that once you get into some like while loops, for example, they're still going to have these same 3 things. It's just going to be positioned a little bit differently. I like to use for loops when I'm aware of what the max value is, and I typically use while loops when I just want to do it indefinitely until someone stops it. So thank you guys for watching. Hopefully that gives you enough information to get going with for loops, and I'll check out the next video. And before you go, just check out the description because I have a C programming crash course for you guys, and that's going to give you everything you need to know for C programming in a quick, consumable manner, hands-on practice. I think you guys would love it. So thank you guys. I'll see you in the next video. Hey guys, welcome back. This video I wanted to talk about more on the for loop. So we introduced it in the previous videos, we talked about how to code it, and we made this nice, pretty for loop. But the reality is, this is not the structure of the for loop you're always going to find in the wild. So I just wanted to help you understand for loops at a more deep level, and hopefully that'll help you write them better as well as understand them better. So the first thing I want to do is I just wanted to run this program so you guys can see what the output is. Okay, so it takes an input, and let's say we say 10. It prints out 10 numbers from 0 to 9. And what I want to do is I want to append to this program and basically say, hey, you printed blank numbers, and then use the I variable to say how many numbers were printed. So to do something like that, it's going to look like this. So you print it up to the number D. And you can see that, we're printing the value of I, and it goes up to 9. So in theory, this should make sense, but we're going to find some issues with this. And the variable we're going to use I. And I can tell you right now that this is not going to compile. And the reason this is not compiling is because we are referencing this variable I. And this has to do with variable scope. But we're declaring this variable inside of this for loop. So once the end of this for loop is hit and we go outside of it, all of the variables declared up here and inside of the body, they all disappear and they're no longer able to be referenced. Thus, in order to fix this, we must declare I outside of the for loop. So we could do something like this, int I, and get rid of the declaration inside of here. You could also say int I equals 0, and then just get rid of this altogether. But personally, I don't think that's quite as clear. I like it like this because to me, it makes it clear, what we're doing. We're starting I from 0 and we're going to max. So definitely clearer in my opinion. Now let's try compiling. Maybe. Oh, yeah. It's waiting for me. Oh, boy. It's been a long day. 10. Okay. So it counts from 0 to 9, and then it says you printed up to the number 10. So why is it printing 10? Well, just so you guys understand that the update happens after the body. Thus, on the last iteration, it prints 9, and then I is incremented to 10. So at this point, I is 10, not 9. So if you want to reference the last value of I with the for loop, you need to make sure you're doing I minus 1. That's the first thing I wanted to show you guys. Pretty simple and nothing too crazy, but just wanted to make it clear. You printed up to the number 9. Now, if you're trying to print the total of number of things printed, that's different. So you could say you printed %d numbers. In this situation, we don't want to use the -1 because it will actually have the right value. You printed 10 numbers. Perfect. So that is the first thing I wanted to show you. The other thing is that this for loop increments. It doesn't have to work this way. We can actually flip it around and decrement, so count down. So what is that going to look like? Let me just get rid of this. So we're going to basically, let's first look at the comparison because I like to think of, when are we going to stop? So as long as I is greater than, let's say 0. And instead of using I, let's say the max. So we're going to start with the max, and then we're going to decrement the max. And this comes from input. So the person passes in a max, and as long as it's greater than 0, we're going to decrement that value. Let's compile this and run it. And obviously, we did something terribly wrong. And why? It's because we're printing I, which is not what we're trying to do here. And in fact, I was never initialized, which is why we're getting some random value. We're just declaring it. Thus, there's no prediction on what is actually going to show up here. Okay, so what we need to do is we need to print max. And you could use a variable I just the same. I already had a variable max, so it was easier for me to read. Let me get out of that. Compile. Now let's try 10. And it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that is how you could count down. Another thing you could try doing is, and we don't need this I variable anymore, you could count down by 2. So for example, instead of decrementing, you could say max equals max minus 2. Now it goes 10, 8, 6, 4, 2. Awesome. If you wanted to include 0, you could put that equal sign there. And there you go, include 0. So another thing I wanted to warn you guys of is infinite loops. They're actually very easy to do. And it usually just comes down to you don't really think about all the possible inputs because naturally we're human. We only think about the things we're thinking about, but we don't think the same way as everybody else. So when someone else uses our program, they think things differently and they put in a different input. So for example, you might look at this and say, wow, this is counting all the even numbers. It's counting down by 2. Thus, instead of naturally thinking this, we might just say, hey, as long as max is not equal to 0, we should be good. And once it hits 0, it's going to stop. Let's run it. Put in the value 10. Yep, works perfectly. 10, 8, 6, 4, 2.
exactly what we want. And then what we might do is we might ship this application to millions of users and say that it's production ready. But what we don't think about is that, they might not put in an even number. If you put in the value 11, it's going to subtract 2, and it's going to skip the value 0, and it's going to continue to get less and less and less into the negatives, and it's just going to keep doing that forever. Obviously, that is a big bug, and it's going to not let you proceed with your application. So let's just try that. Let's just run it. Let's put in 11. And now it's basically just counting down forever. It's kind of cool if you think about it. Kind of makes you look like you're like a super hacker. You're just like type on your keyboard like as if you know what you're doing, but you really don't. So if you want to get out of this, you can hold the control key and press C. That's what I have to type on my Mac. If you're on Windows or something, it might be a little bit different. I'm not entirely sure, honestly. So if you're in that scenario and you can't get out of it, I'm sorry. That's all I got for you guys for some more advanced for loops. Hopefully it was some useful information, and be sure to check out the description for a link to my C programming crash course. My throat's kind of dying, so I'm having a hard time speaking into this microphone. Maybe I need to get closer. Check out my C programming crash course, because that's going to give you everything you need to know in a condensed, hands-on, practical format. So check it out. Thank you guys, and please be sure to subscribe, and I'll see you in the next video. Welcome back. This video we are going to be talking about the nested for loop. And essentially, a nested for loop is a for loop inside of another for loop. And it can be used to create output like this. So I want you guys to look at that while I take a drink. Well, that's some good stuff. That's almost as good as the content inside of my C programming crash course, which you guys are definitely going to want to check out. Link in the description. So what is going on here? Well, why would you want to do something like this anyways? We're counting down from this number, and this number counts up each time. So kind of pointless, yeah, I know. But this is actually really useful once we get into like multi-dimensional arrays and stuff like that. You're going to need for loops inside of for loops. Because if you think about it, what is a for loop inside of a for loop? It's when you want to do a loop for every iteration of another loop. So for every number here from 0 to 10, we want to count down from that number. So that is what is going on here, and we're going to try to recreate this here. So the first thing, let's focus on the outer for loop, and that is this number here from 0 to 10. And we've done something like that, so that's nothing too crazy. We just say int I equals 0, and we're going to go up to 11. And the reason we're going up to 11 is because it's less than 11, which means it's going to stop at 10. And every time we need to increment I. Now, just for our own experimentation and for our eyeballs, let's print out this number. It goes from 0 to 10. So we got that first number there, and we're on a good track. But now for every single one of those, we need to count down from that number. Well, that number is stored inside of I. Each iteration, the value of I goes up. So that is the number we're going to want to use as one of the inputs into our next for loop. So let's just comment this out here. Let's create a new for loop. Now, when you have a second for loop, by convention, just like this is typically called I, the one for an inner for loop is typically called K. And you can name it whatever you want. You can call it tacos if you want. I mean, if that's the kind of food you're into, I would much prefer pizza, because pizza is objectively a much better food than tacos. I mean, it tastes better, it's cheaper, it's probably not healthier, but it's not terrible. So there's really no argument about whether or not pizza is better than tacos. So, but for the sake of argument resolution, we're going to use K. And what are we going to set this equal to? Are we going to set it equal to 0? Or are we going to set it equal to 11? Oh, I don't know. Well, we're actually going to set it equal to I.
And the reason we're going to, why don't we just use I if we're just, why are we making a copy of I is the question. Because we're going to change K. We're going to start, like let's say we're on this one right here. We're going to make K equal to 10, and then we're going to decrement K down to 0. That's how it's going to work. So as long as K is greater than, I'm going to go greater than or equal to 0. And then what we're going to do is we're going to decrement K. And then we can just print K. Okay. And this isn't going to give us quite the right answer, but it's going to be close, and you'll see. Whoa, what is going on there? That is a mess. That's because we need to put a new line in this. But where are we going to put that new line? Well, it depends on what you're trying to do. So if you want that new line after every character, then you're going to put it on the inner loop. So we're going to put it here. Okay, we're getting closer. We are definitely getting closer. The only thing is we're going to put a space there. Or you could even, if you want it to be spaced out more, you could do a tab. There we go. But definitely like space is better. So I'm going to go back. There we go. We just copied this exact thing and we recreated it. Hopefully that helps you guys understand inner for loops. This one kind of gives you this jagged edge or a triangle-like shape. If you wanted it to be a square shape, then you wouldn't want to base it off of this variable. You would want to base it off of something else. So it's kind of hard to explain because we haven't really talked about multi-dimensional arrays, but in a 2D array, you're basically going to have a table-like structure, and the length that you're going to want to iterate through is going to be the same every iteration of this loop. So you're not going to want to have a dynamic variable that changes each iteration. So you'd want it to be like a length of one of the arrays, for example. Start it at 0 and go up into the length of one of the arrays. We'll talk about that another time. So hopefully I didn't get a little too sidetracked there. Thank you guys for watching. If you've enjoyed this, please be sure to subscribe. Definitely need the subs. I'm trying to catch up to some people, and man, they're slapping me hard. Yeah. All right. Talk to you guys later.
Hey, what is up everybody? Welcome back. This video, we're going to be talking about a little exercise we're going to be doing in the next couple of videos. So we've learned all these programming principles, and now we're going to kind of combine them to build a more complex application. That being said, the application isn't that complex, but just an exercise to help you get used to using for loops. Okay, so what exactly is the exercise? Well, it's kind of annoying that in computer science and programming, we often get stupid exercises that deal with numbers and prime numbers and Fibonacci sequences and all that junk, when in reality, most of the stuff we do in our career and when we're actually building applications really has very little to do with math and other hard things like that. That being said, some careers are going to be very math heavy, but it's annoying because there's not necessarily a correlation where all your exercises usually use math problems, but your actual job doesn't, which you just kind of got to deal with that. So to help you adapt to that, we're going to be doing some exercises with prime numbers. Now it's going to be fun. I'm going to make it exciting, so don't freak out. It's not like it's that hard. Prime numbers aren't that confusing. So a prime number is something that can't be divided into another whole number. So for example, if we have the number 9, well, this is actually just 3 times 3. So it's not a prime number. 7, on the other hand, if you go from 7 down to 0 and try to divide 7 by that number, you're never going to get a whole number. For example, you could take 7 divided by 2 and you get 3.5. There's nothing you can multiply to get 7 if we're just multiplying whole numbers here. So like for example, you could try 3 times 2. Doesn't work, it gives you 6. You could try 3 times 4. Not quite, that gives you 12. So 7 is a prime number. So hopefully you guys have a good understanding what prime numbers are. Basically, we are given an assignment, and I wrote down the requirements. Quote, from your boss.
we are in dire need to create a small application for our C-powered calculator, and it will take a number from the user and output all prime numbers between 0 and whatever number they input. At the end, it will say the total number of prime numbers. And the due date is today by lunchtime. P.S. You are a bad coder. Because you never really know what kind of environment you're going to be working in, and that's a totally realistic possibility in computer science, so. Well, we're going to show them. So let's create the application. So basically what it's asking is, hey, you give it a number, say 25, and it's going to output all of the prime numbers from 25 down to 0 and give the total number of prime numbers. So counting upward, that would be 2, 3, 5, 7, 11, 13, 17, 19, I'm probably screwing something up here. 23, and yeah, that's it. So it would print out that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 total prime numbers. And honestly, there is probably a very, very, very easy, simple way to do this. But we are going to do it a really complicated way of where we're literally just going to take this number and go downwards from that number and get all the prime numbers. Oh, and by the way, I just checked, and yes, these are all correct. Thank you very much for those of you who didn't trust my math skills. I got you there. So one thing we need to really be careful of when we're creating this application is something known as edge cases. And this really comes up with software testing. And building software is basically impossible in general. Therefore, we have to make a lot of tests, and people actually devote their whole career just to software testing. And a big piece of this is testing what's known as edge cases. So the edge cases are like the highest and lowest number we're going to be working with, and a little bit past that. So for example, if we put in, 25, the edge cases in this scenario would be like 2 and 1 and 0 and -1. Like how are those things going to differ? And the reason this is because in this situation it actually matters because 1 is not a prime number, nor is 0, just 2. So we have to be careful in that situation to where we don't accidentally consider 1 a prime number, and we can just do this by stopping at 2 if we're going down from 25. So this brings up, maybe sometimes we have to clarify with our boss exactly what they're looking for. Do they consider 1 to be a prime number? Obviously, in this situation, I'm saying no, 1's not a prime number, and I think that the general consensus is no, it's not a prime number. But there might be some disagreement amongst some generally assumed knowledge. So don't just assume if it's not 100% guaranteed. And maybe prime numbers isn't the best example of that, but if you generalize that concept to other possible programs you're going to be building, you will be much safer. So just something as simple as, phone numbers. You might build an algorithm to work with phone numbers, but then you might just assume they're all going to be US numbers or from a certain country. Well, that's not going to work. You have to talk about the edge cases of, hey, you might once in a year get a different format for a phone number for this application and, really break things. So I'm kind of getting off topic, probably not that helpful. So let's just get back to what we were doing here. So we are going to write pseudocode. Pseudocode is basically code that has no rules on syntax. It just has somewhat code-looking syntax. Basically, it's a way for people to write code without actually having to worry about getting all the syntax and keywords correct. So we start with the input. And in this situation, we're just going to assign it a value, but obviously, eventually, we're going to want to get that from input. And our loop is going to look like this. So we have a for loop. We need to initialize. Well, we already initialized because this is the number we're starting with. So you don't actually have to do initialization. You can just put a little semicolon, which skips the initialization because that already happened up here.
And now we're going to go down until the number is 1. So as long as input is greater than or equal to 2, we're going to keep going. Then we're going to, how are we going to get there? We're going to decrement input 1 after every iteration of this loop. So we're going to say input minus minus. And then we have our curly braces. And because this is pseudocode, I don't actually have to write out the algorithm. I could just say, figure out if prime, and then if num is prime, print the number. To actually figure out if the number is prime, we're going to use another for loop, and we're going to be getting into that in the upcoming videos. And also, if you need to keep track of how many prime numbers there are from 25 down to 2, then you will need a variable to increment as we go. So for example, we could have an int, maybe like num prime. We could start that at 0, and then if the number is prime, we could say num prime plus plus. Basically incrementing the count of prime numbers. And then when we're done, we can output that number's prime. And if we needed to, it would print out all of the prime numbers, and then we could say the total number of prime numbers is num prime. So yeah, that's all I got for this video. This is just going to introduce you to the challenge. And what I want you guys to do is I want you to start thinking about this and think about what algorithm we would need to do to figure out if a number is prime. And just think very simplistic about it. There are easier ways that you might learn in like discrete math, but we're just thinking very simple here. So this is the iteration 1 of our algorithm, and we're not necessarily doing optimization, so it doesn't have to be perfect. So that's all I got for you guys in this video. Be sure to check out the next one because we're going to be expanding on this. So thank you. Hey, what's up everybody? Welcome back. This video is a continuation of the previous video where we talked about prime numbers and how to make this application our boss wants. And this video is going to focus on how to algorithmically check to see if a number is prime. So let's just go through a simple example of 7. So any number divided by itself will give us 1. And any number divided by 1 will give us the original number. That's normal, but it's the other numbers between 1 and 7 that we can use, or between 1 and n, or whatever number we're working with, that we can use to check if a number's prime. So if we take 7 divided by 6, 7 divided by 5, and all the way down to 7 divided by 2, there's something in here that tells us whether or not a number is prime. And so you understand what a prime number is. It's only divisible to give a whole number with these two situations up here. All the other numbers are going to give us a remainder when we're doing integer division. So for example, if we had 2 people and we had 7 slices of pizza, handing out these pieces of pizza, we would end up with 1 left over. And we can't cut the pizza in half. I would throw the integrity of the slice of pizza into question. We can't do that. Okay? So that's not going to work. Same thing. Now we're splitting with 3 people, we're still going to have a remainder. All of these are going to give us a remainder. That means 7 is prime, because only these ones do we get no remainder. If you have 7 slices of pizza, 7 people, boom, everyone gets 1 slice of pizza. You got 1 person, that lucky person gets 7 slices. So basically, we can use the modulus operator. So instead of using the division here, the modulus operator is the percent sign. That's going to give us a remainder. And if it is 0, that means the division ended up with no remainder. In all of these situations, all of these scenarios, the remainder will not be 0. So we can basically do a test from the number down to 1, not including those numbers because we don't need those. We just need the numbers in between. If the remainder
for any of those is 0, then the number is not prime. So for example, 6, which is not prime, remainder with 2 is 0, because you could divide 6 by 2 to get 3, no remainder. So how's that going to look in code? Well, we start with the Boolean variable that we use as what I like to call a flag, basically a way to indicate whether something is prime, and we just assume it's prime until it's not prime, until we prove otherwise. And I like to call it a flag just because it's like an indicator. You can call it whatever you want. So we'll say bool is prime, and we'll set that to true. Then we have, a variable int I. Let's just put that in the for loop. Int I equals 2. We're starting at 2 because we don't have to worry about 1 or the number itself. So we just start at 2 because we're just getting those middle numbers. And then we're going up until I, as long as I is less than the number we're asking for. We'll just call that input. You could call it n, whatever you want to call it. And each time we're going to increment I. So here's how we basically test all of the numbers between 1 and that number. And then we just do an if statement. So if input remainder or modulus with I is 0, if that's the case, well then we know it's not a prime number because we had successful division with no remainder. So then we would say is prime is now false. Now, since we have this variable is prime, we could do an if statement down here after the for, and we could say if is prime, then we can do something with it. So we could output it, or we could increase the number of prime numbers that we're counting, whatever you want to do with it. This video is just focusing on how to tell if a number is prime. Now there is one optimization that I know of. I'm honestly not going to worry about it, but if you were actually going to do this in production with large numbers, you would want to do it. There is a way to tell if a number is prime without going through all of the numbers in between, where you only have to go up so high, and at that point it just works. I think it's like the square root of the number. It's something I learned in discrete math, but I suck at math and I don't really remember, honestly, but it's out there. So if you guys really want to make this program for legit or for like some kind of job interview, that is my challenge to you, to figure that out so you don't have to check as many numbers. So thank you guys for watching. Hopefully that was helpful. This is my second time redoing this video, and I actually remembered to press record on my audio this time, so I'm happy. Thank you, and if you've enjoyed this series, please be sure to check the description for a crash course version of this video. Definitely, I'm sorry, just for some reason, throwing chalk up in the air is very satisfying. Go check that out if you need to study for an interview or just review all the content in this course. Thank you guys, and I'll see you in the next video.
Hey guys, welcome back. This video we're going to be talking about determining if a number is prime algorithmically. So, like I've told you guys numerous times, I am no mathematician. I know it's important, and I'm trying to get better, but it's always been challenging, and because of that, I'm doing this for my own personal exercise. Brain exercise, not like physical exercise, of course. So just to prove to you guys that I know nothing, I even looked some stuff up, and I'm going to show it to you guys. In the previous video, I talked to you guys about an optimization we could do when checking if a number is prime. And I mentioned it had to do with like the square root, I believe. And basically, if we're checking using the modulus operator, if there's a remainder, we don't have to do that with all numbers up until the number. All we have to do is go up to the square root. And this guy explains it. If you guys want to know more, you can go to this website. And another thing is, you don't actually have to try all numbers. You only have to try the prime factors. So like if something's divisible by 10, it would also have to be divisible by 2 and by 5. So I could see us using this one fairly easily, but
since I'm just going to be using a simple for loop, I'm not going to be referencing a chart of the prime factors. I might not worry about this one, but we'll see if we get far enough to do the square root part. All right, but enough time wasting. Basically what we need to do is we need to just code away and see where we go. So the very first thing is we're just going to start with an input, and I'm not going to get this from the user right now. I'm just going to hard code it. And we want to know if this is prime. And I usually like to just assume things are prime to begin with. So we're going to use true and false, a flag basically, to say, hey, this is prime. And now we're going to go through the code to prove otherwise. So how do we do that? Well, we're going to use a for loop. And if for any number between, including the number 24, all the way down to 2, if it's divisible evenly by any of those numbers, then it is not prime. So that is the easiest way to check if a number is prime. So we're going to start with int I equal to, what did I put int 25. Gosh, I'm stupid. All right, input equals 25. Okay, int I equals input. I'm not going to code 25 twice because eventually we're going to be able to get that from user input. So int I equals input, and as long as I is greater than 1, we're going to decrement. So let's just print the number and we'll just see the range we get. Okay, so it's starting at 25. We don't actually want to test 25, so what we're going to want to do is do input minus 1, which makes sense, obviously, because 25 divided by 25 is going to work. And then it would say it's not prime, even though it is. Oh, well, this situation it's not, but that it could be. Yeah, never mind. Just ignore me. We just need to make it input minus 1. Trust me. Okay. And it goes down to 2, which is good, because if it was an even number divisible by 2, yeah, that would get it. So that is the good range. Now we need to basically do a test. And we need to use the modulus operator. So if input modulus I is 0, meaning there was perfect division, integer division with no remainder, then what we do is we say is prime is false. Then down here we could basically condition on the value of is prime. So if it's true, and because this is a Boolean, we don't have to say equals true. It's as good as is. Because everything evaluates to true and false in these if statements. So if is prime, we'll just print is prime. Otherwise, we're going to print the opposite. And I'm also going to put a new line before it just because that way it goes on to a new line after these numbers. So let's try it. Oops, there we go. Not prime. So let's try a prime number like 23. I'm getting the hiccups. Is prime. So it seems to be working. If we tried 24, it's not going to work. It's going to work, but it's going to say it's not prime. There we go. And now let's try some smaller numbers. 5. Awesome. So it's working. Now, where exactly does that optimization come in? Well, back to this article. So the square root is the highest number we need to check against. Comparing that to our code, we're basically saying, hey, we don't need to go all the way from the input. We could just go from the square root of the input. So that would look something like square root. And then I think you have to have an include. Let me just compile and see if it says anything. Yeah, so I think it's math.h maybe. Oh, yeah, it is include math.h. I just had a typo. Okay. And inside the function, I just think we use the input. And let's go with a bigger number like 25. not prime. How is this working exactly? Well, it's going to set I equal to 5. When we set the value equal to 5, what's going to happen is we have 25 checking the remainder with 5, and it's going to be 0, which is not going to work. Now, if we try a prime number, such as 23, is prime. It's cool. So let's go back to this here. Let's just grab one of these. So supposedly this is a prime number. Let's see if it is. Because our code is infallible. Get rid of those commas. And it's prime. Wow, that's actually kind of cool. So that's how you check if it's prime. In the next video, we're going to kind of finish out our application where we try to find all of the prime numbers from a particular input down to 0. So be sure to subscribe and check out that video. Thank you guys, and see you then. Hey everyone, welcome back. This is a continuation of the previous video. It's Caleb, and I am excited for this series to continue. Hopefully you guys are enjoying it, but if you're really enjoying it, I encourage you to check out my C programming crash course. I'm gonna have a link for you guys in the description. Go check that out if you want to help out this channel and also just get all the goodies from this course condensed into one good solid course. So check that out. By course, it's gonna be like one crash video, so yeah, it's gonna be sweet. All right, so far we have basically this algorithm to check if a number is prime. And what we're gonna do is we're gonna expand on this because we wanna take input from the user and we want to print all the primes from that number down to 0. So let me just write those out just so the requirements are very simple and easy to see. Get input from user. And then print all primes from that number down to 0. And actually, it just means down to 2 because 2 is the lowest prime number. Okay, so I know we haven't talked about making our own functions, but I'm actually going to do that in this video. And we're going to have a dedicated video on how to create functions soon. So if you have no idea how to do that, that's okay. You can just copy my code and it'll help familiarize yourself when we get to that point. If you do know how to use functions, great. Then this shouldn't be too hard. Basically, this is the algorithm to check if a number is prime. It's completely suitable for a function, so we can make it more reusable. So to do that, we're going to go up outside of our main, and we're just going to say int is prime. And I don't want it to be int, actually. I want it to be bool. It's going to return true or false. And then I'm going to take all this code in here and cut that and paste it right here. Now this input is actually going to come in as a argument, and we're going to create this parameter to store it, I guess is the technical way to say that. So int input, which means we can get rid of that line. We don't need this is prime variable because we can just return true or false. So if the number is prime, we just return false. Otherwise, we return true. So that should be our is prime number, or our is prime function. We can test that out down here by saying, let's say bool prime, and then we run a test, is prime number 25. Now I had an issue because I was trying to do this. Whoops, I was trying to do this, where the variable name and the function name were the same, and that's not going to work. So just make sure you're careful and call your function something different than the variable you're going to store the result in. So the way this works, it'll call this function, and it's going to store true or false in our prime variable. The rest should work the same. We just need to make sure we change that to prime. And now I'll compile and run and see if it works. Not prime. Also going to get rid of this printing statement. So it looks like it's working still. Let's try a number that is prime. Is prime. Awesome. Cool. All right, so now what are we gonna do? Let's work on this part. So let's cut this and bring it down to the main function. first thing, let's get some user input. There we go. That should be our input. And now what we want to do is we want to use a for loop. Get rid of that. And we're going to try every number from this number down to 2. So we need to start at input. So we're going to create an iterator and call that input. And then as long as I is greater than 1, we want to keep running, and we're going to decrement I each time. I is going to be the number we're checking if it's prime or not. So this code in here, we can bring inside of our for loop because we're going to execute that for every single number here. So bool prime equals is prime I. And we're going to print out that variable here. So we're going to say %d, and I'm not even going to print anything if it's false. So actually, I'm just going to get rid of that. There we go. Okay, what do you want to start with? Let's start with 25. Hey, I think it's working. Let's bring this terminal up a little bit. So we put in 25. That's not prime, so it doesn't say anything. 24 is not prime. It's divisible by 2. 23 is prime. 22 is not. It's even. And so forth. Yeah, it seems to be working. So that is how you would create this little application that was requested of 4 videos ago. So hopefully that was helpful for you guys. The main thing to understand here is that obviously when you have something that's really reusable, we want to export that as a function. What? Oh, this is some weird indentation issue here. That was really confusing me there for a minute. There we go. Okay, so anytime you have something repeatable, you can try to bring it out as a function just to make it a lot easier to read our code. Because originally I was trying to do this problem by just taking this code and putting it inside of this for loop, wherever this is prime was called, and it was just a disgusting mess. And I was like, ugh, I know we haven't talked about functions, but I'm going to use one anyways. So thank you guys. Hopefully it was helpful. Please be sure to subscribe and definitely check out that crash course in the description below. Also, don't forget, I do have C notes, so go check those out as well. Thank you guys. See ya. Hey everyone, welcome back. This video we are going to be talking about the while loop. Now, just to clarify up front, the while loop can be used to achieve everything that the for loop can achieve. So there's not real differences. Now, the way you structure it is different, and there's a little bit more flexibility, I'd say, with the while loop, and you'll see why in just a couple of minutes. So let's create a little while loop for you. And let's just start with incrementing. So we're going to print the values from, let's say, 0 to 9 or 0 to 10 or whatever we want to do. So it's going to look like this. And as long as whatever's in these parentheses evaluates to true, it's going to execute this code block here. So let's go from 0 to 9. So let's say int I equals 0, while I is less than 10. Print f, and we're going to print I in here. And then we're going to increment I. And my dog is running around in the background, so if you hear panting or chewing or anything, it's her. And now she's sitting in the corner. She looks bored. But I literally just took her out for a 1-hour walk, so what can you do? Okay, let's run this. We should probably compile. Okay, cool. So it goes from 0 to 9. So this is the exact same thing as the for loop because we have the initialization, we have the comparison, and we have the update. You can clearly see that the update happens at the end, which is one of the things that makes the while loop a little bit clearer. But this also does introduce the possibility for bugs if you happen to put the I++ at the beginning. So for example, if I put the I++ up here, well, you can see that the result is definitely different because the value of I is changed by 1 before we print the value out. So everything is 1 higher. So let's just put that back. So yeah, that's really all there is to it. Yeah. What else? Golly, I don't know. yeah, I don't know. I think that's all. One thing is that I like the flexibility of the while loop, that you can actually increment wherever you want rather than always doing it at the end of the iteration. So if we wanted to do something like that with the for loop, it'd be a little bit more complicated. So let's just write something out. K++. So you have some flexibility with the for loop because you could always alter this and do most of the work down here. The flexibility is definitely there, but I just think it's a little bit easier to see what's going on here and when it's happening. So for example, if I wanted to count by 2, I mean, I could do that right here very easily. But let's say I wanted to do 1 at the beginning and 1 at the end. I could cut 1 and paste it there. You could definitely do that here too, just I++. So it's still possible. I think it's a little more clear with the while loop what's going down, but it's ultimately up to you. What do you guys think? Which one do you think is clearer? And it's not so much that one's better than the other. I think that's what people always want. Hey, which one do I use? But it ultimately comes down to personal preference. Typically for me, what I do is when I have something that I don't know how long it's going to execute, I typically use a while loop. Because I always forget to increment my variables and I always put them in the wrong spots, or I just do something wrong. So if I have something that's like this, while true, and it's just going to keep doing this until change to false. And this would be in like some if statement. So if something, gosh, I can't type. If something, then change it to false. Obviously it's not going to compile, but that's okay. This makes more visual sense to me than trying to convert this to values here. So if it's like an infinite loop that ultimately ends, so if I'm going to show a menu, for example, where it's like, hey, choose a number 1 to 4, and if they put like some random, like a J or something, then it says, oh, you put the wrong value, try again, and then it displays it again, and it just keeps doing that forever. I would generally use a while loop for that. If I want to iterate through something where I know how many there's going to be, or if I get that from input, like do this 10 times, I think it's a lot clearer to use a for loop. But let me know what you guys think. And if you've liked the series so far, please be sure to click like and subscribe, and definitely check out the description for a link to my C programming crash course. Thank you guys, and I will see you in the next video. Hey, what is up everyone? This video is going to be talking about nested while loops, and we're actually going to be basically copying an earlier program where we did nested for loops. So if you didn't see that video, it looks like this. We wanted to create an application to output this. So it ultimately comes down to one loop to go from 0 to 10, and then another loop to go from that number down to 0. And this was the result we found. We're going to do the same thing with the while loop, and it ultimately comes down to just taking this and converting it to while loops, which I would encourage you to do as a coding challenge, so definitely pause it now. Okay, now that you got the solution, check out what I got and see if you got the same thing. So here's what I'm going to do. I just got this here for reference, just so I can make sure I got it right. I'm going to initialize 2 variables, and it's going to be int I equals 0 and k. I think I can do that. Yep, looks good. Then while I is less than 11. So this is the loop to go from 0 to 10, and we want to make it less than 11 so that we include 10 there. So as long as it's less than 11, we're going to print it. And I was going through this exercise earlier, and I forgot to do the update like I said I always do. And I'll show you what I got. I don't know why I put a D there. I want to put an I there. There we go. All right, let's compile and run. Yay, this is definitely not what we want. This is because I is eternally under 11 because we're not updating the value. So cancel that, and we need to do I++. Okay, the only other thing is that they're printing one after the other. So at the end of this, we want to print a new line, and we're putting it at the end because between here is where we're going to basically output the rest of the numbers. So we don't want it to be like 1 and then count down from 1 on the next line. We want it to be on the same line and then go down to the next line. So in here, we're just going to put a backslash in. Okay. All right, looks good. We got that. And then we're going to have a nested while loop right here. And we're going to basically count down from whatever the I value is at that time down to 0. So k is going to be the thing to decrement down to 0. So we're going to say, we're going to do that. Let's say while k is greater than 1, or not 1, while k is greater than or equal to 0. There we go. Then we're going to say k minus minus, and we're going to print out k. We need to initialize it still, so don't let me forget that part. Okay, so where do we initialize k? We're going to want to initialize k right here. We don't want to initialize k right here because we're doing a comparison on k, which that's not going to work the way we don't know what's going to happen in that scenario because we're comparing against an uninitialized variable, which is definitely bad. And we don't want to do outside of this while loop because the value of k changes for each iteration. So in the first one, it's nothing. Then we have 0. Then we have 1, and then we have 2, and then 3, all the way up to 9, and each time it goes down to 0. So we definitely want to do it right here. So we're going to say k is equal to I. And so we could actually probably want to do k equals I minus 1. So that way the first printing is 1 less than whatever this number is. So we count down. So it's probably all messed up, but let's give it a try. Okay, I got something messed up here. Gonna print k. Okay, what do we got here? Okay, see, it's harder to do with while loops. We got this increment here, which is changing the value of I before we assign it to k. So this k should just go up at the top of the while loop. So much more confusing to read while loops, in my opinion. There we go. Yeah, that would make sense because obviously we don't want to change the value of I prior to referencing it when we're trying to base it off of the original value of I. We could change everything to reference the new incremented value of I, but that just doesn't make as much sense in my brain. But everyone's different, so if you think differently, well, you're probably wrong. I'm just kidding. Thank you guys for watching. Hopefully this is the right output, and hopefully you guys understand everything with while loops. And in the next video, we're going to be talking about do while loops, which are a little bit different, but they're definitely cool. So definitely check them out. All right. Thank you guys for watching. If you enjoyed this video, please be sure to check the description for a link to my C programming crash course, which is basically all the cool stuff in this series condensed into one super legit crash course. Check it out. Thanks, guys. Hey guys, welcome back. This video, we're going to be talking about the do while loop. So I definitely recommend you check out the while loop video, and it's really simple if you're just jumping in and you know the do while loop. Basically, while something is true, do something. Very simple. The do while loop is different in that it's always going to do something at least once. This means the do while loop is ideal for scenarios when you need something to execute at least once, but potentially more. And the main use I can think of is input validation. So let's say you ask a user for a number 0 through 9. Well, more than likely, someone's going to try and put in pizza or something larger than 9, for example. And this can break your program. So in order to fix this, we can basically ask them once, and if they don't put something in that's correct, well then keep asking them until they do. So that is what I typically use do while loops for. But like I say all the time, programming is very dynamic and you can often do things more than one way, and it ultimately kind of comes down to personal preference, and hopefully you'll see that by the end of this video. So let's try creating a do while loop. First thing I want to do is I just want to explain where everything goes, because it's still going to have an initialization, a comparison, and an update. We just got to figure out where. So let's make a little comment section for a minute. So the very first thing we're going is to have the initialization. That's going to go first. My dog's making a bunch of noise. Then we're going to have, here, let me get rid of this comment actually, it's not as clear. Then we're going to have the word do, while, we're going to have parentheses and a semicolon. Make sure you put that semicolon at the end. It seems odd because we're used to putting curly braces after while, like, if I can type, which I obviously can't, like that. But you gotta put the semicolon there. Don't forget, it's a mistake I've made numerous times. So we have the initialization there. We have our comparison here. And we have our update here. And our actual code goes here. So make sure you do the initialization outside of the do loop, or not the do loop, the do section, because if you do it inside of the do, you're not going to be able to reference that variable here because it's not going to exist outside of these curly braces. I'll show you that in just a moment. So let me just comment this stuff out so I can keep it here. And let's actually write one. So we're going to say do, and what we're going to do is we're going to ask for user input. And we're going to scan, and this is where the initialization comes in. You say, oh, I need to scan in a variable. My first thought is to go like int input and then do a scanf. This isn't going to work quite right though because we're declaring input inside of the do section, which we don't want to do. It's got to be outside of the body of the do. But we'll do that in a sec. Like that. So we need to take this input and we need to put that out here. There we go. Now we have while. And now we just basically say as long as input is not legit, we're going to keep doing it. So if input's less than 0 or input is greater than 9. Oh, yep, got to use the address of operator because it needs a pointer. Please enter a number 0 to 9, 5, and the program ends. Let's do it again. Do -3. It keeps asking me. Oh, okay. So it doesn't work with characters, but you know, it's a start. So thank you guys. Hopefully that helps you understand the do while loop. Thank you for watching, and I'll see you in the next video. Hey guys, welcome back. This video we're going to be talking about the break keyword. Now we talked about the break keyword earlier when we were talking about switch statements. So you might want to go check that video out if you need some more practice with that. But essentially, this keyword here is going to prevent us from falling through from this statement and executing the rest of these statements, which we definitely do not want to do. So make sure you understand how that works, but there's also another use, and that is to get out of loops. So I'm going to show you an example. It might not be the most practical example, but then I'll show you something a little bit more useful. But let's first look at the functionality, and then we'll be able to generalize that for other uses. So let's say we have this big loop that counts lots of numbers, and we want to break out of this loop earlier without going through the entire thing. So we might use the break keyword. In this situation, it's kind of pointless because as soon as the for loop starts, it's going to hit break, and then it exits the for loop altogether. It doesn't go to the next iteration. It goes all the way past it and just skips all of the rest of the iterations. So that's dumb, but you might have it after a conditional. So like, let's say if I is equal to let's say 6, then we're going to break. And just to see this, we're going to print something. You can see it prints for I equals 0, 1, 2, 3, 4, 5, 6, and then this comparison evaluates to true, and the break statement is executed. So that is how the break keyword works, and this is a very simple example, but one really good use is for indefinite loops. So an indefinite loop is similar to an infinite loop, but it's not something you literally want to run infinitely. You just want to run it indefinitely until something happens, and then you want it to end. So you might see something like this: while 1 or while true,
and then we're going to do something indefinitely. And then at the end, we're going to have some situation that makes it stop. So as long as this thing evaluates to true, then we're going to break out of this while loop. Otherwise, the while loop is going to run forever. So just to think of an example, let's say we are trying to crack some passcode or some number or something. And I'm just going to hard code that here, but obviously it's not going to work that way in the real life of hacking. But you know, this is a tutorial series. I can do whatever I want. And I is going to be the number we use as a guess. We're going to start at 0. So if we end up getting the right guess, then we can break out of this loop. So if I is equal to the number, we need to break out. Now we need to make sure we increment I, otherwise this is just literally going to compare 0 to this number forever. That's not indefinite, that's infinite. So in this situation, it should be working, and we can prove it by printing a statement here. And just for fun, let's print I. So that way we can kind of keep track of what's actually happening in this while loop. Now let's execute this. Let me add a space here. Looks like my computer froze. You guys seeing this? Okay, I'm not sure what that's about, but it is printing the numbers. It's just not putting a space there, so you'd want to put a space there. But eventually it does find 23232 because you can see it right here, 23232, and then it says we found it. So that's exactly how the break statement works. And even if you're using a loop where it's not indefinite, if at some point it's going to get the answer, you can use the break statement to get out of the loop to not waste cycles, because it might be that after a particular number is found, we don't have to continue processing and we can save processing by using the break keyword. So that's pretty cool. The next video we're going to be talking about the continue statement, which is similar but definitely not the same thing, and it's used a little differently. So definitely check that out, guys. Thank you for watching, and I'm sorry that my computer decided to stop working here. Alright, peace out. Hey there, guys. This video we're going to be talking about the continue keyword. I definitely recommend you check out the break keyword. So the break keyword is going to essentially, once you hit this break, it's going to exit whatever loop it's in immediately. The continue is a little bit different in that the loop doesn't get exited, but that iteration does. So it's just going to ignore everything after the keyword for that iteration, and then it'll go to the next one. So let's just see a simple example of this. Let's use a while loop, and we're just going to say, let's just create a while loop from 0 to 10, for example. So while I is less than 10, let's do something. And then we need to increment I. So now we have the basics of a loop. And what we could do is, for a particular case, we can treat it a little bit differently so we can really see the power of the continue statement. So let's say if if I is equal to, let's say 7, we're going to do something a little bit differently. Otherwise, we're going to do something else here. So you could use an else statement, but let's just not do that for the sake of this video. Let's use the continue. So we're going to treat 7 a little specially. So we're going to say 7 is awesome. Otherwise, we're just going to just print the number. And we could do that using the value of I, like so. Okay, let's put some space there. Let's try this. So 0, 1, 2, 3, 4, 5, 6, 7 is awesome. 7, 8, 9. So it says 7 twice because it hits this and then it goes down here and hits the rest of this code. So if you wanted to basically say, in the case that we're here and this evaluates to true, then I don't want the rest of this code to be executed, rather than putting everything else in an else statement and having an if else, we could just put the continue keyword. There is one gotcha though, because the incrementation is going on down here. So this will create an infinite loop, because once we hit 7, it's going to continue, and I never got incremented again, so it's forever going to be 7. So we need to make sure we have that increment here as well.
So now it goes 0, 1, 2, 3, 4, 5, 6, 7 is awesome, 8, 9. So that is how you use the continue statement. It's just another tool in your toolbox. Goes with break very commonly, so make sure you understand both of them. And thank you guys, hopefully that was helpful. And don't forget to subscribe, really means a lot to me, and definitely need all the help I can get. Okay, thank you guys, see ya.
Hey, what's up everybody? This video is going to be about arrays. And just wanted to throw this out there, that this video was sponsored by Caleb Curry, who produced the one and only C programming crash course, which you guys can find in the description. So check that out if you want your brain to explode with info. In a good way, of course. It'll definitely be helpful if you need a review or you just want to learn all this material without watching a 100-part series. Now, for those of you who want to watch these videos, we're going to be talking about arrays in this video. So what is an array? An array is essentially a collection of data stored within one variable. So we can store multiple things in one variable. Now, they're all going to be of the same data type. So for example, we can have a collection of integers. We can have a collection of characters. But just the thought is crazy. We can store multiple pieces of data in one variable. It's awesome. All right, so look at it like this. If you had to visualize an array, it's going to look like this. Yeah, not really. It's going to look like this. And each one of these boxes is going to have something. So let's say this is called my grades. And yeah, so as you can see, my grades are drowning because they're all below sea level. This allows us to store multiple grades inside of one thing. So this is my grades. And my grades in this situation is an integer array. And the way you would define this is like this. Int my grades, and then you're going to use square brackets. Now this is another thing that is kind of annoying, and it's not C's fault, it's probably the other programming language's fault. So when you're working with other programming languages like C# or Java, the array symbol typically goes with the data type. So you can clearly see, hey, this is an integer array. It doesn't work that way in C. When you declare a variable of type array, you put the array symbols, the square brackets, with the variable name. Not that one is necessarily better than the other. Personally, I think the array symbols going with the data type is a little clearer, but other people might think differently because they might see the variable name and know immediately, hey, it's an array because of the square brackets. So, personal preference, doesn't really matter. All you guys need to know is that if you're in school and you're learning like Java or something, this is slightly different, and the only real difference is you just got to move these these square brackets right after the int. Simple as that. So, now that I'm done with that little chat, let's talk about how this works. So within these square brackets, you need to declare a size. So an array is statically sized. So what that means is that the size cannot change. You say what size it is, and that size is known at compile time. So when you compile your software, your array only has that many elements. You can't add any more without going into like dynamic memory or using something like a linked list, which we will be getting into not today. So statically sized, we're only given this much size in memory, and you have to use that, no more. And if you go past the end of the array, like if you try to reference this one right here, you can cause some serious issues in your code and likely crash your program. So, statically sized, you're limited to the number of elements, and you say how many elements by putting that right here. So in this situation, we would have 1, 2, 3, 4, 5. And then you would use a semicolon there. And then, to assign these values, you can do this. You can say, my grades, and then use, you can reference, by the way, these are all known as the members of the array. And each one is known as either an element of the array or a member of the array. So if you wanted to grab the first member or the first element, you would use a 0 because these are 0 based. Arrays are always 0 based, meaning the first element has the index 0. So mygrades 0, you can set that equal to 15. That is how you would assign that value. And you could do the same thing for 1, 2, 3, and 4. You don't want to use mygrades 5 because that's going to be reaching this area right here, which is not memory allocated to this array. Bad, don't do. Okay, so you can do it that way. There is actually another way, a shorthand way of assigning these, and that is, ignore this for a second. If you just get rid of this number here, you can make an equal sign and just put the values right here. So you could say 15, 24, 60, 32, and 15. That is the shorthand way. It's much easier, and I think it's a lot easier to read as well, but you can still always go and reference the values or change them using these brackets. So hopefully that helps you understand the concept of an array and how it works. Just the main thing, I can't say it enough, is that it's statically sized and you don't want to go outside the bounds of the array, which is very easy to do when you're using arrays inside of for loops and you're referencing elements using an I variable or some kind of iterator. So just be really, really careful. We're going to get into some practice with these arrays, so please be sure to check out the next video where we're going to get hands-on and make some arrays. So yeah, thank you guys for watching. Check you out in the next video.
Hey everyone, welcome back. This video is going to be all about arrays. Now, I would highly recommend you check out my previous video, which is going to introduce arrays in a more conceptual manner, talk about some of the syntax, but this video is going to be the hands-on attachment to that. So I'm going to repeat some of the same stuff and help you guys get some hands-on practice, and it's going to be awesome. But you know what else is awesome? My C programming crash course. So please, if you're interested in that, go check it out in the description. And I don't think you'll be disappointed. So definitely go check that out. So when we create an array, we're basically creating a grouping of data. And all of this data is of the same data type. So when you're creating an array, you need to say what data type all the data is going to be. And you can't mix data types. So if you wanted to mix integers and doubles, that's not going to work. You would need to create 2 arrays, one for integers and one for doubles. So let's just say we're creating an array, mygrades. The way you say it's an array is by putting these square brackets. Then there's 2 different ways essentially to put values in this. The first way is you create a size up front, and then you go and manually say what each value is. And it starts with 0. So this number here is known as the index. So index 0, we could set to 10. And then we can do it again for index 1, 1, and set that equal to 11. And we could do this for all 10 of the elements. And then once we do, we could access those elements the same way. So mygrades index 0 is going to give us the value 10, and we could print that out as an integer, like so. You can see it prints the value 10. So that is the first way that you initialize, you declare an array and then you initialize it with some values. Now, the other way is that we could do it all at once. So let me just get rid of this. Let me get rid of these 2 here. And also get rid of the size. You're not going to want to use a size in this example. You're going to use these curly braces and put all of the values here. And you can do as many sizes as many elements as you want. And the size is going to be determined by the compiler. So we don't want to go in here and put a size, because then if we ever decide to update the list, we'll have to remember to update that size too, which is extra work on us. And just doing stuff like that makes it more likely to make mistakes. So makes you more likely to make mistakes. So you don't want to do that. So this should work just the same way. And you can see it prints the value 10.
Okay, so now I just wanted to talk about some vocabulary. The first one was index, which I told you. The next one was element, and the next is size. Okay, so the index, this is a zero-based number, and it's the number associated with each one of these elements. So this one is 0, this one is 1, this one is 2, this one is 3, and so forth. An element, the first element, this is kind of like the same thing, but I don't consider it to be zero-based. So the first element is going to be this one. The second element is this one. The third element is this one. And the reason I'm bringing this up is mainly just out of my own bitterness, I guess, because one time I had a test in school and it asked me what, like, for example, what the first element was. And, you know, and if it was this example, I said, oh, 10. And I got it wrong because what the teacher meant was, hey, what's the element with index 1? Which is not the same thing, in my opinion. And I got it wrong, and I told him about it, and he was like, nope, you're wrong. And I was like, no, you're wrong. So that was annoying. And honestly, I've only ever been wrong once, and that was when I thought I was wrong. All right, so that is how you use arrays. And in the upcoming videos, we're going to just talk about different ways to work with these arrays. But some of the things you can do, because each one of these elements is really just an integer, anywhere you expect an integer, you can use one of these elements. So you can use them in expressions. So I could say my grade's 4 plus 10, and I can assign that to some value, to some variable. And you can see there's no compiling errors. That works just fine. If you have a function that expects an integer, you can pass in this here. One thing though is if you want to reference the entire array, it's just my grades. It's not my grades with this here. You leave off the square brackets. This is how you say this is the array. You only use the square brackets when you're declaring the array or when you're trying to reference some index of that array. Also, one last thing is what happens if you go outside of the bounds of the array? What happens if we do like this? Well, let's just find out. Let's try to print this. It's one of those days where literally every neighbor decides to mow their lawn while I'm trying to make videos. All right, so it gives us a warning. It says it's past the end of the array, but we're gonna run it anyways, you know? And we get some crazy value. Now, I think the result of this is technically undefined, meaning we don't know what's gonna happen when we do something like this. It could output a value, it could explode, it could crash, it could do whatever. So it's undefined behavior, and you definitely want to be careful when you do something like this. So that's all I got for this video. In the next video, we're going to talk about printing all of the values of an array. Rather than doing like this manually for every single element, what can we do to just go through from beginning to end and print every single element? That's what we're going to talk about in the next video. It's going to be sweet, so please guys, be sure to check that out. And if you've enjoyed this series, I would definitely appreciate it if you hit that subscribe button. Help me hit 100,000. That would be tremendously helpful. Thanks guys, see you then. Hey everyone, welcome back. This video we're going to talk about how to print all the values of an array. So starting at the beginning and going all the way to the end, printing each one. So the easiest way, and also I never did define size in the previous video, so this is basically the total count of elements, and it's not zero based. So in this situation, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the size of this array is 9. And typically, you're going to have a size variable to keep track of these arrays, because as you pass these arrays around into functions, for example, it's difficult to figure out the size of the array without having a variable to just keep track of it. And this has to do with something called decay. When you pass an array, it decays to a pointer, and you can look up that if you are interested, but we're going to go on with what we were talking about. So you can think about it like this. Let me get rid of some of this stuff. Let me just start nice and simple. So we have an empty array right now, and if we wanted to print every value,
let's just give it some values. Let's do it the hard way. So we're going to say the 0 element is 10, and we would need to make a size here. So let's declare a size. And then we're going to put size here, just like that. And now we could fill out each one of these elements. And this is going to be the last one because the size is always one more than the highest index. So if we did this, we would be going into the sixth element, or the sixth element, because we have 1, 2, 3, 4, 5, 6, which is one more than the size. That's going to go outside of the bounds of the array, and that's going to slap us real hard. So we don't want to do that. Okay, so I made it really difficult, and I assigned some values using this technique here. This might be done if you are getting these values from user input or from a file. You wouldn't have this section, but you would have the size statically defined here, and you would create an array of that size. And then you would basically go through and assign each one of these indexes a value from a file as an example. And then let's say we wanted to print all those values. Well, a way you could do this is if you just imagined a print statement. Let's write one out. And we'll also put a space there. All we have to do is put the number, the index that we want to print. So we could do 0, or we could do 1. And you can think that the only thing really changing, this all stays the same. The only thing changing is this number that we want to print. So if we could somehow make a loop to start at 0 and then increase one at a time all the way up until we get to the highest index 4, well then we could essentially print every value of an array. So in order to do that, we have to put this in a for loop, or a while loop if you like to make things more complicated on yourself. Go for loops, woo! So we're going to define a variable I, and like I've said previously, you may need to define this outside of your for loop, so you might need to do int I equals 0, or just int I and then say I equals 0. But I like to declare it inside of the for loop. It's just clear to me, and that's more consistent with other programming languages, so that's typically what I do. Now you're going to do I is less than size. And then you're going to do I++. And I always try to keep it as just less than. I think it's clearer for me, and I think it's more common. It's if you always stay the same, you get more practice and you go out of the bounds of the array less often. Then what happens is you can actually reference I inside of this for loop, because every single iteration, I is going to be incremented. So this should work, but I probably have bugs. That's always what happens. Yeah, okay. Too few arguments, yeah. See, I tell you, every single time I make a video, everybody decides to let their dogs bark and have a party and mow their lawn. Okay, so I just had a printf floating around, which I shouldn't have had. Now we just printed all those values, 10, 15, 20, 25, and 30. If you're not careful and do something like this, less than or equal to size, it's going to go outside of those bounds of the array. And you can see it prints 1, but it's really undefined behavior. We don't really know what's going to happen. So that is how you would loop through and print all of the values in the array. Hopefully that was helpful for you guys. Hopefully next video I'm not going to have a dog pound in the background. Alright, I'll see you guys then. Bye.
Hey guys, welcome back. This video we are going to be talking about multi-dimensional arrays. Now you definitely want to make sure that you understand arrays up to this point, so make sure you understand what would be called single dimensional arrays, which is just, array of integers, for example, which I talked about in previous videos. Now that you got that understood, you can move on to multi-dimensional arrays, which are essentially arrays of arrays. So if you need to visualize this, think of it as a table. So originally we thought of an array like such. And we used the completely unique example of student grades and we had a one person's grades in an array like such. Well, with the multidimensional array, you can think of the same thing, but now you have multiple students' grades in the same structure, same format, but now you can reference multiple students. So let's say there's just 3 grades for each, or let's go with 4. 4 grades for each student. How would you define this array? So there's 5 students, 1, 2, 3, 4, 5, each one with 4 grades. And we'll just call it student grades. Make sure you can see this, okay. It would look something like this. Student grades, and you're going to need 2 square brackets. So the first square bracket refers to the rows. So how many rows are there? The answer is 5. The next one is how many columns this way, which there's 4. So there's going to be 4 grades. Beautiful. So this would give us this structure, which we can visualize in our head as such. But if you wanted to reference a specific row or a specific column, then you need to think, what are we going to put when we're referencing it? We're going to put student grades, and then we're going to put something here and something here. So for example, let's say we wanted to reference this cube, or this cell, I guess you could say, right here. Well, here's what the code would look like. So we already declare our array. And the way you would declare it is you would first give it a type, int student grades, semicolon. And then you could assign each value individually, or you could use the other syntax, which I showed you in the single arrays, which would be to set it equal to curly braces. And then inside of the curly braces, you would define each row with curly braces. So you could do something like this, comma, another set, sorry, it's curly brace, 2, 3, 4, 8. These students did really bad because the grades are out of 100. Comma, and you could do that for each row. So once you declare it, how do you go and reference one of the cells? That's what I want to show you guys now. So let me get rid of this and also get rid of the type. So now we're trying to reference one cell. And we're going to use the same similar structure. We just have to think. Both of them are 0 based, both the row and the column. So we start with 0, 0, 1, 2, 3, and then 0, 1, 2. So that is going to let us access this cell, which we could print out as an integer, or we could assign it some value like such. Beautiful. So that is how multidimensional arrays work. And it's really clear, it's really important that you understand the data types and just what to call things. So if you just have, let me get rid of this. If you just have student grades by itself, this is a multi-dimensional array. It's a 2D array of integers. Now, if you have student grades with a number, that is a single dimensional array, one row right here. So that's a single dimensional array. So if you had a function or something that required a single dimensional array, you could pass in a row like that. Now, if you add another square, 0, 2, 0, 1, 2, it'll be this one right here. That's an integer. So you can use that anywhere an integer is expected. Just so you guys can understand the different data types, you might want to practice some of that. Now, the last thing is, just wanted to clarify that this is not the limit. You could have a 3-dimensional array, which you could visualize as a cube if you needed. And you can have a 4-dimensional array, and so forth. So thank you guys. Hopefully that was a good introduction to multidimensional arrays. Obviously, this is very conceptual here. The next video, we're going to get hands-on and create some of our own. So please be sure to check that out, guys. I'm sure it'll be helpful for you. And as always, be sure to subscribe. And one thing I wanted to mention, you guys, is that I actually am working on a C programming crash course, which if you would like to consider donating a fixed amount of money in exchange for some goods, aka make a purchase, you can check out the link in the description. And yeah, that's it. So thank you guys. I'll see you in the next video.
Hello everyone, this is your video on multidimensional arrays. I would definitely encourage you to check out the previous videos on single dimensional arrays, as well as the video introducing multidimensional arrays. Now we're going to get some hands-on practice with it. But before we get started, I just want to do a quick shout out to my C programming crash course. I think it's something you guys would all be interested in, so check out the links in the description if that's something you might find useful. So when we create a single dimensional array, we say what type it is and give it a name, and then use these square brackets. And then you can put some values in here. And that is how you create a single dimensional array. A multi-dimensional array is very similar. You still only use one type. So every single value is going to be of the same type. So this one up here, this might be one person's grades for 3 assignments. So now we want to store multiple people's grades for the 3 assignments. So we need to use 2 square bracket groups, and then we can assign the same way. So it's going to look something like this. I like to format it so it looks like a table. So this is the first student. And then this is going to be the second student, who's a little bit smarter than the other one. All right. So this is actually not going to compile. And this is an interesting thing that I'm not entirely sure why, but maybe one of you guys can help. So when I said to make a single dimensional array, I said don't put the size here. But when you're making a 2-dimensional array, it actually wants you to put the size. Specifically, you only need the size right here, which is the number of columns. So you could put a 3 here, and that would work just fine. But I don't know why that's like that. I don't know why it can't just say, oh, there's 3 columns. That means we should just give a size of 3. But apparently it has to have the size. And generally when I do that, I prefer to have a variable. So we could have a column variable set to 3. And if you're going to do this, you actually need to have the const keyword here in order for it to work. Like so. Now it should compile. And we can actually access any of these elements fairly simply. So for example, let's say we wanted to access this 89. Well, what we would do is we would say grades, and the first square bracket is going to talk about the row. So this is row index 0, this is row index 1. So we would say 1, and then we're going to do another set of square brackets. And this is going to be the column. So index 0, index 1, index 2, right there. Now let's compile this and just make sure it works and run it. 89, so it works. That's how you access a particular element. And this is just a normal integer, meaning you can change it, doing the same thing. So now I'm going to print it before, change it, and then print it after. 89, 30. So that's how that works. Now, I wanted to talk about how we print all of the values of a multidimensional array. And you're actually going to need 2 for loops, so a nested for loop. The outer for loop is going to go through the rows, then the inner for loop is going to go through the columns. So it's going to look something like this. Now we need the number of rows, and actually don't have this hard-coded, so just for clarity, let's do that. So now as long as I is less than rows, and you could put rows here if you wanted. It doesn't need it there though, so I'm not going to put it there. Okay, now that's going to cycle through the rows. Now for each row, we need to print every single column value, so we need another for loop. Now typically, you'll use another variable, either j or k. So you could say int j is equal to 0, and then j is less than columns, j plus plus. So now within here, we can use these variables as the indexes for our array to access each element individually. So basically it's going to go I0, and then for every I0 it's going to go J0, 1, 2, and then I is going to go to 1, it's going to go 0, 1, 2. If that made no sense, then just print it out, you'll understand. It's hard to explain this kind of stuff sometimes. So the first one is going to be I, and then the next one is going to be J. Okay, we have a little issue. Oh, here's the issue. We need to change it to grades, and that's a lowercase g, not my grades. So grades was the single array up here. I'm going to get rid of that. And it prints out all the values. It looks a little funky because this printf here is still there. We need to get rid of that. I was looking at it, I was like, what is going on? It's not working. But it's working. It's just not looking right. There we go. 12, 23, 45, 64, 78, 89. Now, if you want to print it out as a table, after each row, you need to print a new line. Like that. And that is how you print a multi-dimensional array. Hopefully that was helpful for you guys. Please be sure to subscribe if you've been enjoying this series, and let me know what other kind of content you'd like me to cover. Thank you guys, I'll see you in the next one.
Welcome back, everybody. This video, we are going to be talking about strings inside of the C programming language. Now, up to this point, you've probably worked with some strings because we've done it in earlier videos, and you might understand how they work a little bit, but I just want to go in a little bit more depth and talk about some of the warnings. So definitely want to watch this video because this is some important stuff. But before we get started, I just wanted to mention to you guys that I'm taking all the content from this course, condensing it down into a crash course version where you guys can basically do it for review, for interview prep, whatever you need. It's definitely a good hands-on way to basically get all the information from this course quickly. So go check that out in the links of the description. So let's get started. Just to refresh, let's talk about what strings are from scratch. So strings are essentially a character array. So let's say we have, let's just first look at the constant version of strings. So by constant, I just mean it's a value. We could use that in an expression, so forth. We're not assigning it to a variable yet, it's just a value. If we wanted to assign this to a variable, we would need a character array. So we would have something like this. And I'm just gonna name this A, because it's, creativity, not really. And this is going to be an array. So I'm going to put the size of the array here, and we're gonna talk about that because that's not always the best thing to do. So just make sure you watch to the end. But for now, I'm gonna put that there, and then we'll talk about it in just a minute. And then you can assign it that value. So this is basically the easiest way to assign a string to a variable in C programming. So what this is going to do, and let's ignore this up here for now. We don't need that no more. This is going to make an array, and it's going to look like this. We're going to have HELLO \0. And what that is, this is called the null character. And it's represented as a \0. Similar to how the \n represents a new line, well, the \0 represents the null character. And what this is it's a character used to represent, or it's used to indicate the end of the string. So if any function was to go through this string one character at a time, it would go through it, it would hit that null character, and it would know that the string is done and to not go forward. This is like super important because if you don't have that there's high chances that you're going to be going into areas of memory that you're actually not allowed to access, and you're going to, well, actually, it's hard to say what's going to happen because technically I think the issue is undefined, the behavior. You don't know what's going to happen. More than likely your program will crash, but you might accidentally modify some areas of memory. It might hack into your bank account. We don't know. It's very, very undefined. So you just want to make sure that you don't accidentally overwrite this character. So for example, if you did something like this, 0, 1, 2, 3, 4, 5, and set that equal to exclamation mark, that's an issue because what we just did is we overwrote it. It's not overwrit. And we replaced it with an exclamation mark. So now there's no way to tell the end of the string.
this can come up when you always want to make sure your sizing for the array is correct and that you don't make it too small for the string you're trying to fit. And as you are using that array, you always want to remember that the last character in that array or the string is that null character. Very, very, very important. Also, just wanted to mention that when you're getting user input, you never really know the size of what they're going to give you, so you just want to make sure you are prepared for different sizes, different lengths of strings. So for example, with the scanf function, you usually would pass in like a string such as %s, and this conversion character s would basically say, hey, we're expecting a string. Well, that person can type a string as long as they want. So I think you can actually put a number here, like a 9, to limit, and it'll basically crop after 9 characters. They're not going to be able to give you any more. They can still type it, but when they hit enter, only the first 9 characters are going to be used for whatever you're using this for. So if you're assigning it to a variable, it's only going to use those first 9 characters. Just a side note, just throwing that out there. So hopefully that helps you guys understand strings a little bit better. The main thing you got to know is just that there is a null character at the end, which looks like a \0, and you never want to overwrite that. Now going back to the sizing thing I mentioned earlier. Here I put a 10, but I would actually generally not recommend this. I would leave this empty. And the reason that works is because the size of this can be used to determine this. And this happens at compile time, so it's still statically sized. It's not dynamically sized now. What happens is the compiler is the one to decide how long the string array needs to be. And if you put in something like hello, the size would be 6, because it would look like this. 1, 2, 3, 4, 5, 6. And index 5 would be, this would be the null character. So the compiler can do that. The only time you would want to put a value there is if you're not assigning a string constant like that, and like let's say you're getting it from input, well then you want to make sure that your string size is set. So you could use the value 10 there, and then only take the first 9 characters from the user, because you have to reserve that 10th space for that null character. Vitally important, do not forget. So hopefully that's helpful for you guys. Please be sure to subscribe if you've enjoyed this series. Definitely really helps me out. I'm really trying to grow this channel, and yeah, can't do that without your guys' help. So be sure to check out the next video, and that's all I got. See ya.
Yo everyone, what's up? This video we're going to be talking about strings and just working with them a little bit more than we have so far. So one of the things that I wanted to talk about is just how to get string input. And we've done this before, but if you're just jumping into this series, that's the first thing you're going to want to probably learn how to do. So let's first just kind of make a program to ask a user to input their favorite food, for example. And there are a ton of string reading functions available. Maybe not a ton, but there's more than just printf and scanf, which is what I've been using for the series. You may want to look into some of those. I'm just going to stick with scanf. It's the simplest. So you can use this conversion character, which basically says, hey, we're going to read whatever the input is as a string. And then we need to store this somewhere. So the way we create a string is we say char, and then we can name it something, and then we give it a size. Now, what's the most long food name I can think of? I don't know. Chicken Parmesan's kind of long. Doesn't matter. Just give it a value. Okay, so let's say 50. Okay, now there's something you guys got to be really careful of. The 50th character, so index 49, is reserved for the null character, the termination of the string. That means we only want to read 49 characters, so we can reserve that last one for that null character. So to do that, you can put a 49 here. And then we just need to say fave food. Okay, so you don't actually have to use the address of operator.
which we've used in the past. And it has to do with what is called decay. So when we pass in the array, the character array, it decays to a pointer automatically versus using something like an integer. We're going to get into pointers here really soon, so definitely check the upcoming videos out. But for now, just understand that you don't need to use the address of operator there. And we should be able to print out that string. So same thing, we can print this as a string. Just like that. And let's go with a new line afterwards. What is your favorite food? And it prints lasagna. Great, so everything is working so far. We got user input, and it should be protected from basically really, really, really long food names. So if I just do a ton of characters here, it's going to crop it to the first 49, which is a good thing because we don't want to try and actually store all this in our string. Okay, so cool. That is the first thing. The next thing I wanted to talk about was just talking about the length of the string. So let's just say we wanted to create some code to see how long the string was. It might look something like this. We might make a loop. So let's just say we have a variable to keep track of how many characters are in it, and then we're just going to scan through the array until we hit that null character, and then we're going to stop. So we could have something like character count, for example, and we're going to start at 0, and then we can just loop through the array. So we'll start at index 0, and we're just going to test to see if that character is the null character. So we might have fav food, index, character count. So that's going to get the first character, and we're going to check to see if that's equal to the null character, which is written with a \0. So, and actually what we want to do is, well, it's not equal to that. So as long as we're not equal to this null character, we want to keep executing some code. And then in here we could say character count ++. So that's just going to increment the character count. And then we can actually print out this character count. Just like that. The character count is 7. So 1, 2, 3, 4, 5, 6, 7. There we go. So it's working. Every character increases the character count by 1, and it's not including that null terminating character. So that's good. And if we were to put in a huge string, I didn't need to compile again, but that's okay. It should say 49, hopefully. Yep, the character count is 49. So we basically created a section of code that can be used to get the length of a string. And eventually you could take some code like this and we could make our own function. So if we wanted to go down here and do something like int car count or whatever, we could create our own function. But there's actually something already built into the C programming language to do that. The function that's available in the C programming language is called strlen, so string length. And the way you would do something like that is you would basically say, or actually we could use this variable here. We could say character count is equal to strlen of, and we could pass in our string. So we could say fav food. And let's see what happens when we compile this. All right, so it says to include string.h, so we need to make sure we do that. The character count is 7. So there's no way to guarantee that they're doing the same method that we are doing, but it very well could be. We don't know. So that's just some cool things you guys can do with strings. Hopefully that gives you more familiar with strings. And let me know if you guys have any other cool things we could talk about with strings, because I might do some more videos going into some more of the functions available or just some of the things you can do with them. Thanks for watching, guys. Please be sure to check out the next video, and if you're enjoying this series, I'd encourage you to check out the description for a link to my C programming crash course, which you could use to basically study all the material in this course, as well as just get prepared for any kind of job interview or anything like that. So thank you guys, I'll see you in the next one.
Yo, what's up YouTube and other areas of the internet that find this video? Just wanted to say that this video is going to be about functions. Now, if you've watched this series from the beginning, you know functions. You got functions down good. But I just wanted to go in more depth, sort of how I did a video on strings, even though we talked about strings. I wanted to talk about some of the principles behind functions and why you would want to use them. But just to review, let's talk about what a function is. A function is basically you can think of it as a tool in your toolbox that does something for you. It's like, don't want to say slave because that sounds like really bad, but functions basically do the work for you, and then you just call the function and you magically get an answer. Okay, slave was probably a pretty good use of the word. Okay, moving on into the less negative part of the video. What is a function? This is so weird. Okay, so a function, for example, we have printf, which is one of the simple functions we learned. Functions have these, when you call them, you put these curly braces, or the parentheses. And this, all you have to worry about is what you put in here, which is known as the arguments. And you don't have to worry about how printf works or what it does, as long as the output from this function is what you want, which usually, if you are doing it right, it is. Because it's kind of like, it's an agreed upon interface in a way. The arguments are the part you worry about, and in exchange you get an output. That is the basis of a function. And you can create a bunch of these functions to do things for you and create a library. So we've talked about, using the built-in functions, but we can create our own functions and we can combine them into a collection known as a library. And then at the beginning of our program, we can do an include, sort of how we do like include standard io.h or whatever it is, standard bool. We can include our library and then have a collection of tools in our toolboxes. Or you can think of it as weapons in our arsenal. And in general, you could say that the idea behind functions is very dry because it stands for don't repeat yourself. Okay, so yeah, don't repeat yourself. Basically, if you have a piece of code that you're going to call or do multiple times, you will definitely want to use a function because that reduces errors, it reduces mistakes, logical errors. So because if you were like, oh, this function's not working or this section's not working quite right, you can go modify it, but you'll have to go remember to modify it in every location that uses it. But if you have a function, all you have to do is change the function code, and as a result, it's going to use that code every time you call that function. You can kind of think of it like Legos, right? So these functions are Legos. Right now, we're just working with like pure plastic, and we are building applications using custom plastic. But it would be so much easier if we formed Legos out of this plastic, and then we just had building blocks to make our applications. It's a terrible example, it's a terrible illustration, but it works. So, for example, we could create a function, factorial. And maybe something like this already exists. And basically in math of factorials, when you take a number and multiply it by all the numbers lower than it, so the factorial of 5 is equal to 5 times 4 times 3 times 2 times 1. And we could manually calculate the factorial every time we need it, or we could just say factorial and pass in a 5, and then this would return an integer, so we could literally use this as an integer. So for example, we could print it inside of a printf like such. Now there are some general things you should understand about
function design. And there's just some good rules, right? So the first thing is that you shouldn't output to the console inside of a function. So don't output. And there's one exception, and that exception is if you wanted to do some kind of function that would do an elaborate print, a set of prints to basically log a series of data in the console. So if you wanted to make the printing process easier, you could create a function to do that. You could just call it like output or dump variable values or whatever you wanted it to do. But in functions that aren't specifically designed to output data, you don't want them to output data because it limits the use. You want the function to be as general as possible so you can use it in more than one scenario or scenario. Do you guys say scenario or scenario? Just curious. So don't output. That means if you want to create a function, the output would be in the calling side. So let's say we wanted to compare two variables. Let's just say we have x and y, and we have a function like, I don't know, r equal. We'll just call it equal. And you pass in x and y. And then you could throw this function call inside of an if statement. So if equal, and then you could print something. Whatever you want. You can do the print in the calling side. So the calling side is we're calling this function and we're printing based on the results. Some people instead would, inside of the equal function that they defined, if they're equal, they would print inside that function and say they're equal. But that means every time you use this function, even if you don't want it to print, it's still going to print they are equal. So you want to basically extract anything that's going to limit the use of the function. Another good rule is you try to make the functions have one use or one function, basically. Meaning that the function, the name of the function should describe what it does, and it should not have the word and. It should do one thing. So if you wanted to do something like sort and display, instead of doing a function sort and display, you could do two functions, sort and then another function, display, and then call one after the other, passing the results of one into the input of the other. So basically what I'm trying to say is that the purpose of a function should be to solve one problem, and then you should have a collection of functions to solve various problems. This also makes the use of the function more general in the sense that you can use it for more things. If you go back to the example of Legos, think of like the little square Legos. You can build like anything out of those, right? But if you just have like some huge Lego that does everything, and you want to build something a little smaller or a little bit more specific, that's not going to work. So as your function becomes bigger, it becomes less useful. So you want smaller, to the point functions that solve one task. And then you start to build up a library that allows you to do more complex things. So that's all I really got for you guys introducing functions. Next video, we're going to be talking about some of the things with arguments and parameters and all that good stuff. So be sure to check out that video. Please be sure to subscribe. And also check out the crash course in the description below. See ya. Welcome back to part 2 of the function part of the video series. An extremely intense introduction to a rather boring subject of functions. So let's get started. The first thing, you need to watch the previous video, okay? Go watch that. And if you just need all the information from this course really quickly and you don't want to watch the rest of these videos, just check out the crash course in the description below. Definitely something I'd check out. But back to what we were talking about. Every function we create needs a name. In the previous video, we used the example of a factorial function. Oh, that looks terrible. Factorial. Now, in order for this function to work, we need some input. And when we're defining a function, we say up front, here are the data, here's the data that we need, and these are known as parameters, and they're defined in parentheses after the function name. So we could say int n, and we give it a name. In this example, we just gave it the name n, and it's named because it's an actual variable. It's just only usable within this function. After this function, it doesn't exist. So inside of the body of the function, which we'll get to, we can reference this variable n. Okay, the next thing you need to know, by the way, just to write that down, that's a parameter. You need to remember that word. It's important. Parameter. Next thing is the return. So that is defining the type of output we're expecting from this function. So what does a factorial do? If we passed in the value 5, it's going to multiply from 5 down to 1 and give us a new value. That is going to be an integer, okay? Because when we multiply integers together, the result is always an integer. That's a concept in math known as closure. The integers are closed in multiplication. So the return type is going to be an integer. And you put that out here. So you say int factorial. So just from this so far, we know that we are creating a function that takes an integer, does some magic with it, and then gives that number back out to the caller. So what now? Well, we need the body of the function, which is structured using these curly braces. And here we do the code to calculate the actual factorial. And I'm not going to worry about that because I can. Then what we do is we return. The return is important too. So there's two things you really need to know. The first thing is the return type, which is up here. That's the return type. The next thing you need to know is the return keyword, where we actually give it a value, and that is the actual data passed out of the function. It's like copied out of the function, which we'll see that in the end of this video and into the next video. So when the function is done, we have to say return because the person calling this function is expecting something in return. You know, it's fair, right? We give it something, we give the function a cookie, and it returns us something in return. Makes sense. So we say return, and you can return either a value, a variable, whatever it is. We could just say, we could just return n, and this code up here would need to convert n to the factorial. So we got the return type, we got the return statement. And that is the three main things you need to understand for creating a function. Okay, the next thing you need to understand is invoking the function. So if we just kind of put this to an aside, and we are now back in our main function or some other function, whatever it is, somewhere in our code, we need a factorial of some number. Well, we can just call this by saying factorial and pass in the value 5, for example. Or even better, let's say we have a variable, int x equals 5, and we pass in x. That works just the same. So the value of x has the value 5. The value here is going to get copied into n. And then n exists within this function. So if we change n, x does not change. It stays the same. This is a copy of the value. We work with it, and then we return a new value. So once we get to the point of returning, that's going to be sent back to the caller. So that means we need to do something with it. If we just say factorial x, it creates a factorial and then nothing happens because we're not doing anything with that value. So what we need to do is we need to either print it out or we need to assign it to a new variable. So I could say
int f equals factorial of 5. Now, this f is going to contain whatever the factorial of 5 is, which would be 5 times 4, which is 20, times 3, which is 60, times 2, which is 120. So in f, f would contain the value 120. So the words and the keywords you need to know here, when we pass in some data, this is known as an argument. This is slightly different. I'm going to jump over here for a minute. This is slightly different than a parameter. The parameter is the variable on the inside of the function. The argument is the data we pass to that parameter. There's a clear difference. It's small, but it's definitely a clear difference. Unfortunately, people use these terms interchangeably, which personally I believe that introduces confusion, but so many people do it, it's not really a big issue. I try to make sure I use the proper term, because if I'm talking about a parameter, I'm talking about a local variable to a function. If I'm talking about an argument, I'm talking about a value passed into the function. Two distinct things, and you should understand the difference. And also understand that parameters, if you pass in a variable, you cannot change those inside of the function. It gets copied. The only way you can change the parameter is if you're doing it via a pointer. So once we get into pointers, you'll see that. And that kind of explains the differences with arrays. You don't have to with arrays, you can change the array because an array decays to a pointer. So if that doesn't make any sense to you, it's cool. We haven't talked about pointers, so I don't really expect you to get that. But if you get it, that's good. So yeah, that's basically everything you need to know about creating a function. Obviously, this is very conceptual and messy and disgusting, and that's fine because in the next video, we're going to create this function or something very similar to it, and we're going to be able to see all of this in action. So hopefully that was helpful and not too crazy, messy, and complex. I never really know or understand how these videos will be taken, because when I plan them, I'm like, oh, that video is freaking awesome. And then I teach it, and I'm like, wow, that was a disaster. So the main things: parameter, return type, return statement, and argument. One other thing is you can only return one thing. So if you need to return multiple things, you need to either change values of pointers, the values at pointers, where they're pointing to, or you need to encapsulate them in something known as a struct, which we will talk about all that another time. So check out the next video. Thank you guys. Peace.
Hello everyone, welcome back. This video we're going to start our talk on functions and how to create a function. So when you're first starting out, it's probably best to kind of realize the need for a function, because you're probably going to be writing a bunch of code in main, and eventually you're going to come up with some series of codes that I say codes, it's like something like a not computer person would say, like you're typing codes. Anyways, you're gonna find some lines of code that you would like to repeat, and when that happens, generally that's a good use or a good time to think of maybe creating a function. So we're going to start in main, and we're going to try to write code to calculate the factorial of something. So just for you guys to understand, a factorial is when you take a number such as 5 and you put, in math you'd put the exclamation mark, and basically that means 5 times 4 times 3 times 2, and I think times 1, but doesn't really matter. So that's essentially what we're going to do. So what we might have is we might have a number that we want to take the factorial of, and what we're going to do is basically create a for loop. And let's say we're going to set I equal to 5, and we're going to count down. So as long as I is greater than 1, because we don't actually have to multiply by 1, then we decrement. And then what we can do is we basically keep track of what the number is. So let's just start with
1. The reason I'm using 1 is because we're multiplying. If we set it to 0 and started multiplying, we wouldn't get any value. So 1's not going to change the multiplication at all, but it's going to allow us to actually keep track of the value that way. So we might do something like this: factorial, and then we're going to multiply that by I. So if you guys aren't familiar with this, this is the same thing as doing just a shorthand. So you can put the multiplication on the left-hand side of the equal sign. So what's going to happen is I is going to be 5, and we're going to do 1 times 5, and then it's going to decrement down to 4. We're going to do whatever that value is. Well, it's going to be 5. 5 times 4 times 3 times 2 times 1, and so forth. And then at the end, we're going to print that value. And we can say the factorial of the number is the number. So number is the number we're asking for the factorial of, and then factorial is the actual result. And then we can return 0. The program's done. So let's try it out. The factorial of 5 is 120. So it seems to be working, but now the issue is, what if we wanted to calculate the factorial of, I don't know, 20, the factorial of 120, and we just wanted to, well, that's a really big number. And we just wanted to keep doing it until we got tired of calculating the factorial. Well, we might have to go in here, we might have to change this hard-coded value, and then we'd have to keep running the program. And, it's just not very scalable, right? And especially if you wanted to calculate the factorial twice in one program, you'd have to basically copy all this code and paste it below and then change some things, and it's just really not that good. So this is where there's a huge red flag that we might want to create a function. Now, if you look at main, this is actually a function, and we're going to basically create another function so we can kind of follow the format of main. So it has a data type. This is what's known as the return type, and that is the value it gives back. So you can think of the function as basically something we throw some data at, and it throws some data back. It does all the work for us. We don't have to do anything. We just have to create it. So it's going to return an integer because the end result right here is an integer. And it's always going to be an integer when we're calculating the factorial, because like I said in the previous videos, integers times integers always give you integers. That's a concept known as closure. So it's going to return an integer, and we can just call it factorial. So this is the structure, so main doesn't have anything in these parentheses. I think you can put some stuff in there if you want to take like command line arguments or whatever. But for factorial, we definitely want to take something as a parameter, take it as an argument and store it in a parameter. So it would look something like this. Number. So this is the equivalent to this. What are we trying to calculate the factorial of? And then what we're going to do is we're going to return the result, which is going to be factorial. And we need to declare that up here, just like we're continuing from right here. So we start with 1, and then we go through the process of this multiplication. All right, so now I think our function works because we have the number and we have the factorial. All the other code works exactly the same. Now, in the next video, I'm going to be talking about how we call this function and how it would be different than having, the code in main and what we need to change to make everything work right. So thank you guys for watching. Be sure to check out the next video. Appreciate you watching, and please be sure to subscribe. If you've enjoyed the series, also check out the link for check out the description for a link to my C programming crash course. All right, welcome back. So in the previous video, we created this function, and now I wanted to talk about the various ways we can call this function. And it's very simple. I probably could have attached it to the end of last video, but whatever. So basically, we get this return value. So this is going to be returned. And whatever the value is we pass in is what we're trying to calculate the factorial of. So in the previous example, we wanted to calculate the factorial of 5. That's what we would pass in.
and the result would be 120. And when you have something that returns a value, you need to do something with that value. Otherwise, it just goes away. So for example, I could do this. I want to get the factorial of 5. And I can compile this, and I can run it. Absolutely nothing happens, because we're not doing anything with the value 120. So what we need to do is we need to actually assign this to something. So we could say int fact equals factorial of 5. So fact should be 120. Yep, there we go, 120. So now we have the same exact program that we had in the previous video when it comes to the result, but the structure is much more consumable. And now if I wanted to basically expand this to more numbers, it's very easy. So I could do the value 8. Now we have, oh, I would need to print it, of course. I always forget the simple things like printing. Now we have both of these numbers. So we basically just doubled our output very easily. And we could even make it simpler, because anytime you have a function that returns a data type such as int, well, anywhere that the program would typically expect an integer, you can use a call to this function. And it's going to call that function first, it's going to get a return value, and then that integer is going to be used. That's why when we do this, this is going to return an integer, so you can kind of just think of it as doing this in a way. That means since certain functions ask for integers, we could just use the function call instead. So let me get rid of this line here. And what we could do is we could actually just pass in factorial of 5. And that'll work exactly the same way. And we could do the same thing with factorial of 8. And it's going to work. See, same exact result. That's because this printf function is currently expecting an integer, and this returns an integer, as so does this. Now, this means that when other functions require integers, such as the factorial function, we can actually pass in a call to the factorial function. So now, this is going to ultimately return the factorial of the factorial of 5. So the factorial of 120. And we can print that all within a %d, because it's an integer. Okay, that didn't work. The reason it's not working is because the number is way too large. I wasn't really thinking factorial of 120 is going to be enormous. So let's try something a little smaller. Maybe this will work. And there we go, because 3 times 2 is 6, and the factorial of 6 is 720. So there you guys, there you go, guys. That is just some practice with functions. And before we go, I just actually wanted to talk about one other thing. You can see that we're printing values here. I just wanted to emphasize that if you wanted to debug this, you could do print statements inside of the function. So you could say, oh, where you could keep track of what the value is as you're multiplying. But in general, you do not want to print inside of functions, because it limits the use, because then you can only use the function when you want to print. And that just goes for things in general. Always keep the function as simple as possible to do exactly one thing. So this function, you know it's calculating the factorial. You're not expecting it to print or do any logging. It's not going to do any of that stuff behind the scenes unless you want it to. But in general, you want to keep a function as simple as possible. Thus, if you want to do like printing, it should be out here in the main function, which you would say is the caller. So the caller side should do the printing and all of that stuff. So thank you guys for watching. Please be sure to subscribe, and I'll see you in the next video. Hey everyone, welcome back. This video we are going to be talking about void functions, as well as functions that call other functions. So what exactly is a void function? First, this is the function we created in the last video. You can see it has a return type of integer.
This means it's taking some data, it's calculating something, and then it returns the value. So you could say that it's basically calculating something. Well, a void function in general is not used to calculate something, rather it's used to do something. So for example, if you wanted to create a function to do some logging, or if you wanted to create a function to just do some console outputs, this is typically where a void function would come in. So it's not so much the case that you never want to output inside of functions. Like in the previous video I mentioned, you don't want to do console logging inside of functions. That's not entirely true. You just don't want to use console logging inside of functions that are not designed to do console logging. So like this factorial function, for example, the only reason you would ever want to do a printf statement in here is if you were debugging the function and you just wanted to output some progress to see how it was going through the code. Or you could use some debugging tools, which we're not going to get into right yet. But in general, you keep the functions focused on one thing, and then if you wanted to create a function to do some logging or some console outputting, then you would make a void function to do something like that. And that's exactly what we're going to do. So we're going to create a void function, and we're going to call it output, let's make that lowercase, factorial. And this is going to take an integer, and that we can just call that input. And basically what this is going to do is it's going to basically take this printf statement and do it inside of a function. Thus we can make the printf statement a little bit more complicated, and if we wanted to print multiple factorials, we wouldn't have to keep repeating the same printf statements. We could just call this output factorial function numerous times. So like let's say we wanted to say, here, let's just start inside this function. We're gonna have an input. So let's just say the factorial of, and we're going to put input there, is, and then we're going to put the factorial of the function there. And then we're going to put a new line. Then we just put a comma, input, and then we call the factorial of input. And here you can see that we're actually calling a function within a function, and that's totally okay to do. So let's compile, make sure we got everything working. And it works. And you can see that there's no return statement in here. So this one has a return, this one has no return. Now you can use the return statement inside of these functions, but you're not going to attach anything after it. So for example, you could say if something, then return, which basically just means, hey, we want to end the function. Can you please stop running? So you could do something like that. And then if this evaluated true, you can exit the function. But you're never going to return something like input, because that's saying, hey, we're passing an output, which we're actually not, because it's a void function. So if you tried to compile this, you can see that it should not return a value. So we don't want to do that. Now, instead of doing the print statements in here, we could just say output factorial 5. Sometimes you're going to want to do this. Typically, I'll do something like this. I'll make a function to do some more complicated printing statements if I need to regularly output the values of something, just to make my life a lot easier. But you don't have to do this every single time you want to print anything. Just throwing that out there. Let's compile this and see if it works. The factorial of 5 is 120. Now if we wanted to calculate other things, much simpler. Factorial of 8 is whatever that is. And we could even do a loop. Like that. There we go. We can calculate the factorial from 0 all the way up to 9. There we go. Thank you guys for watching. Hopefully that helps clear up some more use of functions and also makes void functions very clear. Thank you for watching. If you've enjoyed this series, I would encourage you to check out my description, where I'm going to have a link to my C programming crash course, which is awesome and definitely something you would be interested in. So be sure to check that out. Thank you guys. I'll see you in the next one. Hey, welcome back everybody. This video, we are going to be talking about a very common word you'll hear in development, and that word is refactoring. So what is refactoring? Well, the primary thing is that refactoring is a way to change your code without changing the functionality of your program. So this is an entirely behind the scenes thing. So why would you want to do this? Why would you want to put effort into changing your code but keeping your app exactly the same? There's a couple main reasons. The first one is you might have a new way to do the code that might be optimized. So for example, you might change an algorithm to a different algorithm that has a faster time complexity, or a lower time complexity, I guess I should say. Or you might want to change code that is sloppy or messy, or you might want to make some new functions, make your code more readable. And those are the two primary reasons you would refactor your code. Basically, you're cleaning up the code base, you're making it better without changing the functionality of your app. Now, generally, what I recommend, before you go and refactor a whole project, you will want to have some kind of tests to verify that your code is working properly. So generally, when you're building a more large application, you're going to have some kind of testing framework, or even if you don't have that, you can go in a main function and just call a bunch of different functions and verify that they're returning the correct results using if statements. That's like the basis of testing. And the reason you want to do this is because as you change your code base, it's very, very easy to accidentally break other parts of your code without realizing it. So you definitely want to make sure that you have some way to check to verify that your code is working exactly the same. So with that, we're going to be talking about refactoring. And specifically, we're going to be building some functions from some code that could really use some functions. So make sure you watch the previous videos on functions, because we talk about how to create functions, how to call them, and everything like that. Now, if you have all that figured out, then you should be good to go. And what we're going to do is we're going to go into one of our older applications, multiarray.c, and in here, if you haven't watched this video, you can code it right now. But basically what we're doing is we have this 2D array, and we're going and printing every single value of this array. So if you guys want to see what this runs and what it looks like when it runs, it just prints these values exactly like that. And personally, I think this is cool. It's not too crazy complex to read, but I think it'd be much prettier if it just said, hey, print this array, and it was a function call. So the way I'm going to break this up is I'm going to break this inner loop as a function and then this outer loop as a function. So let's start with the inner loop. And basically this is just going to print one array, a single dimensional array. And yeah, so let's just get started. And now let's talk about what it's going to take as an argument. Well, in this situation, we're using an integer array, so it's going to take an int array, just like that. Now, what are we going to do inside of here? We're going to make a for loop. Okay, now here's where something interesting is. When you pass an array to a function, the size is going to go away, right? So it's not easy to figure out the size. So what we need to do is we need to actually have another parameter here, and that's going to be the size. And when we call it, we need to pass in that size. So as long as this is less than size, it's good to go. And then we're going to increment I. Oops. Erg. There we go. And we're going to basically just print the individual elements of array using the I as the index. All right, let's compile, make sure it's okay. It compiles, so we're good so far. Now that we have this print array function, we should be able to make this code a little bit more readable, because we're not going to need this inner for loop. We can just call our function print array and pass in some data. So what we're going to need to pass in is we're going to pass in the grades, and we're just going to pass in a single bracket, which is how you can just pass one individual row. So if you just want to pass this, for example, then you just use a single bracket, and you're going to use I as the index to say which row we want to pass. So the first iteration is going to pass that one, and the second iteration it's going to pass that one. And we're also going to need to pass in the length of these, which is the columns. So we're going to pass in columns like so.
and it seems to be working. Now, if we wanted to, we could print the new line here, or we could print the new line here. I'm gonna print it out here just because I generally try to leave as much out of the function as possible, because we might want to use this and not print a new line, which would not be possible if we put the new line inside of the function. So I'm just gonna put it here. And there we go, we have the same exact output as before, and we could even go farther and create a function to print a multidimensional array or whatever it may be. You can expand this to more complicated things, but we have essentially refactored our code, so we get the same exact output that we did before. But now looking at this, it's much clearer, because basically for every row we want to print that row. Very, very simple to read. So thank you guys for watching. Hopefully this gives you a good understanding of how refactoring works. Appreciate you guys watching, and I will see you in the next video.
Hey, what is up everybody? This video we're going to introduce pointers, and in the next video we're going to get some hands-on practice with them. They can be pretty darn confusing for beginners, so I'm hoping I can give you guys some pointers. Alright, enough of that nonsense. Just before we get started, I just wanted to mention that I am producing a C programming crash course, which is basically a really awesome version of this series. Hands-on, condensed. It's great. Check it out if you're looking to interview or get some more practice with C programming and you don't want to have to go and watch this whole 100-part series again. Thank you guys, and just check that out and let's get started. So what the heck is a pointer? So this kind of takes us to new grounds in programming, especially if you if you've never programmed, then this is even more crazy. But even if you've used other programming languages, they don't really use pointers. So it's new, and because of that, it's challenging. So what in the heck is a pointer? It's kind of confusing for beginners, and that's okay if you have a hard time, but I'm going to make it very simple for you guys. First, think of a normal variable, int x, and this is assigned some value. Now, when we do this, inside of our computer, there's an area of memory. There's an area of memory. Another name for memory is RAM. So inside of our memory, there is a spot holding the value of x. So if you wanted to think about it that way, there's a cell in our memory with the value 5. Now, a pointer is a way to point to this location of memory. So we can actually basically change the value of this memory or reference it, but not using the variable x. We're referencing it indirectly through a pointer. The way you create a pointer is you say what type you want to point to. So we're going to point to an int, and then you give it a name. So we're going to say $p. You have to use the pound sign, and that is to indicate that it's a pointer. Typically that's attached to the name of the variable here. And then what you can say is you can set it equal to a value, just like we do this. This is an integer variable x. Well, here, this is an integer pointer p. Then what we do is we can use the address of operator, which we talked about in earlier videos. But that's going to get the address of a variable in memory, x. And what this is going to do is it's going to create a variable p, and it's going to point to 5. So it's kind of like a variable equal to 5, but not quite. It's the address of the variable equal to 5. So that means if we change x to 10, well, that means we replaced this value with 10. Thus, the pointer now points to 10. Same thing, we can actually change the value through the pointer. So essentially now we have the original variable containing the value 10, and we made another variable to point to the same data through a pointer pointing to the value 10. So it's kind of like having two variables, and they can both be used to reference the same data. One directly and one indirectly through a pointer. So pointers can be a little bit confusing at first because it's kind of like one of those things where it's hard to see the benefit of them until you use them a bunch, and it's kind of
like when you're a kid and you're starting to learn multiplication, you're like, what am I ever going to do with this in life? But as you're older, you start to understand those things. Maybe that was a terrible example. It's just something you have to practice, and then you're like, oh, I see how this is beneficial. But for now, just learn the fundamentals and understand these concepts, and I promise you it'll be valuable later. So the next thing you need to know is what's known as the indirection operator, and it looks like the asterisk. So this is confusing. This is what I don't like, but we just have to deal with it. When we declared the variable p, we did it like so. And this asterisk here says this is a pointer. This is different than the asterisk here, which is the indirection operator. I hate that, but we just gotta deal with it. So when we declare the variable, we use an asterisk. Then, if we want to get the value that variable is pointing to, so p points to the value 5, if we want to get that value, we use the indirection operator before the variable p. So what that means, since p was originally pointing to x, what we could do is we could say x equals 10 and change that value to 10. Or what we could do is we could say the value at p is equal to 20. And that'll change the value. At this point, if you printed x, it would print 20. So the benefit here is that once we understand pointers, we can use pointers to functions, and this will allow functions to change the values of variables. And that can be really valuable if you need to do something like a swap function. You're not able to change the value of variables unless you're using pointers. So definitely useful, definitely important. You just got to wrap your brain around some different concepts. The 3 things you really need to understand is how you declare them, like this, how you assign to them, which is like this, p equals address of some variable x, and then, so that's the second way, that's the second thing you need to know, and then how you reference the value where the pointer points to, which is with the indirection operator. So this can also be called dereferencing. So if you dereference a pointer, you're basically getting the value where that pointer is pointing to. Hopefully that's not too crazy. I think it'll be more concrete once you watch the next video where we're going to be doing all this stuff in code, in C. It's gonna be delicious, so check that out. Thank you guys, and please be sure to subscribe. Peace out.
Welcome back, everybody. This is going to be your video on C pointers. But before we get started, I just wanted to mention that I am releasing a C programming crash course, which is going to take all the info from this course and put it in a nice to consume crash course for you guys. So please be sure to check the description for a link to that. Definitely think it'd be helpful for you, so go check it out, especially if you're looking for a job and you just need to do some prep. So thank you guys. Now let's get back to pointers. So we talked about pointers in the last video from a conceptual point of view. Now I just want to get some hands-on experience. Now, when you start learning about pointers, honestly, most of the examples are like, what? Like, why would I ever need to use this in life? And honestly, that's just kind of what you got to deal with, because it's hard to understand the point of pointers. That's funny. Until we get into some more advanced programming, some more stuff with memory management and functions, which I intend on going into. And that's something you just need to know pointers ahead of time before it really starts to make sense. It's kind of like we're building the building blocks for something greater, but it's hard to see the end picture with just these building blocks. So in the meantime, just trust me. I know it's hard, but this will be a good investment of your time. So to begin, let's just create a variable. And you know, I always got to talk about slices of pizza. That's just what I do here. So we just created an int variable. Now we can create a pointer to this variable like such. So this just created a pointer to an integer pointer. Now we can assign it a value using the address of operator of slices. So anytime we put this address of operator behind something, we are passing a pointer. We're getting a pointer to that value. So right now we have slices and we have a pointer to slices p. So let's print some values. These are integer types, so we need to go with a %d, and we could say slices like this. Go to a new line,
and we can just pass in the argument slices. If we wanted to do the same thing using the pointer, it would look like this. So we use the same format character because we're still just going to ultimately print an integer. And then what we need to do is we need to use this asterisk. And this is called the indirection operator, and it's distinct from this. So this here is used to create a pointer. This here is something else. It's confusing, but you just gotta deal with it. This is the indirection operator, and it's the way you get the value where the pointer is pointing at. So we can say the value at P. So let's try this. You can see it prints the same value, which makes sense because we're basically printing the same exact area of memory, one directly and one indirectly using the indirection operator. You may also hear this as dereferencing. So if you dereference a pointer, you're just getting the value where that pointer is pointing to. So that is how you do that. Now you can change the value of slices doing obviously the original way, like this. Let's go with 21. You know, I don't want to get too fat. Now let's do the same thing. We're going to print both of these. And let's execute this. There we go. Okay, so first it's 20, 20, and then we change the value directly through slices, and they both change to 21. So that's proof they're both pointing to the same thing. And we can do the same thing, but now we can do it through the pointer. So to do that, we're talking about the value where the pointer is pointing. So we need to dereference it and set it equal like this. All right, we're gonna go up to 25 now. Let's try this again. Just like that. So you can see it changed to 25, both when we access it directly and indirectly. So depending on how you want to change the variable value, you can do it through this indirection operator, or you can use the variable itself. It all just depends on the context if you can use this variable or not. Sometimes you'll pass a pointer to functions, and then you can change the value doing this. So that is how you work with the values, and that's pretty much everything for pointers. I mean, obviously it's not everything, but that'll give you a good foundation. There are a couple of other things that we're going to talk about in future videos. So for example, I'll give you another thing for you guys. If you wanted to increment the value, you could say this. You could say slices plus plus. But if you did this, it's not going to work quite right. And that's because this operator, the increment operator, has higher precedence over the indirection operator. So what this is actually doing is this. Let me just comment it out. It's doing, which is definitely not what we're trying to do. So what we need to do is we need to put in parentheses P and then do a plus plus. Now let's print it out. I'm using a little trackpad on my Mac, and it's hard to do that. So it incremented slices once and then again through the pointer. So it works. So that's just, that's going to come up again in the future where you need to use these parentheses. Just always be really careful. So that's all I got for you guys, just to introduce you to pointers. There's plenty more we can cover, and I hope to in future videos, but I don't want to overwhelm you all in just one video. So thank you guys for watching. As a reminder, if you've enjoyed this content, please be sure to check out that crash course. And if you want to help out this channel, please subscribe. Not that I'm begging, but yeah, you should please subscribe. All right, thank you guys. Really appreciate it, and I'll see you guys all in the next one.
Welcome back, everybody. This video, I wanted to continue our discussion on pointers, but now I specifically wanted to talk about passing pointers to functions. And this really comes back to the whole idea of whether things are passed by value or by reference or by pointer, and just to clear up all that confusion. So what exactly does that all mean? Well, let's just start off with the pre-knowledge that in C, everything is passed by value.
What that means is that the value of an argument is copied into a parameter. So this is important to understand the difference between an argument and a parameter, which is why I try to be very clear. If we have a function such as, well, let's say double value. So it's going to take an input and it's going to double it. And let's say it takes an int x. And we're not going to worry about the return type right now. This is a parameter. When we call this in our code and we pass in some value or variable or something, let's say we have int x equals 10, and we pass in x here, this is an argument. The value of x gets copied into this x. There are two x's. These don't have to be named the same thing. So for example, I could name this one y and pass in y. It doesn't matter because they're two separate variables. What happens is we have an x local to this function, and then we have the x in our main program. And what happens is we have the value 10 here with x, that gets copied over to this x and is given the value here. So in this code, if we do this, x equals x times 2, sorry, it's kind of hard to draw an asterisk. What happens here is the value of x here is changed to 20. But this does not go back and change the value here because the value was passed in and not a reference to the value or anything like that. So some different languages such as like C#, you can pass things by reference. And if you pass like an object, it's passed by reference, meaning if you change that object's values, it's going to be seen here because it's referencing the same area of memory. The closest thing to that in C is passing pointers. So for example, if in this situation, before we go into pointers, if we actually wanted to change the value of x here, we would have to return an integer, and then we would have to return x, and then we would have to assign that return value to x again. So x is now double x. That gets passed in as 10. It's doubled to 20. Then we return that, and then we assign that back to x to equal 20. Much more complicated. If we just wanted to use pointers, it would be a lot more simple, and that's what I'm going to show you now. Since we're going to be working with a pointer, we no longer need to return a value, so this is going to become a void function, meaning there's no return type. And instead of taking an integer x, we actually need to take an integer pointer, which is going to look like that. That's how you say we have an integer pointer and we named it x. And instead of passing x, we need to pass the address of x, which is done with the address of operator, the ampersand, or however it's pronounced. So in this situation, any changes we make to x here is going to be reflected here because they're pointing to the same thing. So what's happening is we have this value x in our main function. It has the value 10. We create a pointer to it. So let's just say this is a pointer, and it points to this value. We give this pointer value, whatever the memory location is, to this parameter. My camera just died, so I have no idea where it just left off. But now we're going to have to use the indirection operator to change the value of x. And basically what we're doing is we're creating a new variable x, which also points to the same location. So we said we have two variables, the x here, and then we have the pointer passed in, which x gets. It's kind of confusing. Maybe it'd be clearer if we use two different variable names. So for example, if we used y here, our variable would be y. We would be passing in the address of y, which would get copied into the value for x. So this illustration is kind of confusing, and one of the best ways to understand it is to just do it in code, which we're going to be doing in the next video. So check that out. But now that we kind of talked about this, I just really want you to think about some of the other functions we've used, such as scanf. Scanf requires the address of a variable That's because inside of the function, they're changing the value. And that's only possible with the use of pointers. Welcome back, everybody. This video, we are going to be talking about passing arrays to functions. And this isn't something new. We actually did this a little bit ago when we did, what was it, multi-array? We basically created this function to print arrays. And in fact, I'm going to use this function. So if you don't have it, pause it now and type it out. Now I'm going to go back to my pass array file. And basically what I want to show you guys is how passing arrays works and why exactly we need this size variable. Okay, so let's create an array. And I love my pizza, so not only do I eat pizza like a lot when I eat it, but I eat it regularly throughout the day. So every single meal, I have 6 meals a day. I mean, I eat a lot of pizza. So this is what I ate today. Like usual, I'm giving you a completely useless example, but that's okay. Now, when we call this print array, we're going to basically say slices each meal, and then we're going to have the size, which is 6. And then when we compile and run, this is what it will do. It'll print the values. Prints them all, and then it's done. So the thing is, in general, when we pass things, not in general, all the time, when we pass things to an array, it's passed by value, meaning that we can't change the value out of the argument that was passed in. Meaning, if I do something like this, here, let me show you. Let me create a function. Actually, I'm going to make this a void function. And this is going to take an integer. And we're going to increment a here. Well, what happens is if I did something like this, and a equals 5, and then we called do something and passed in a, well, for one, these are 2 different variables, just so you guys are clear. This a is not the same as this a, but it's passed by value, meaning the value 5 is copied into this a. Thus, if we print a out here, it prints the value 5. But enough chatter, let's just go through an example. Let's say not only do I print this value, but I actually want to increment that value. So what I could do is say ri++. What you'll notice is that this is actually going to change the original array that was passed in. And I was going to say we could just call the print function afterwards, but it's going to change the value. So let me just copy this code here. So we're going to change the size to 6 there. We're not going to increment it. And we're not going to call it R here. We're going to call it slices. And then we're going to reference index I. And I think that's everything. Okay, now I just need to clean some of this up because it's not clear. There we go. Okay. So the original values are 4, 5, 4, 6, 3, 2. We pass them into this function, and they're changed to 5, 6, 5, 7, 4, 3. But then when we go and print the array again outside of the function, the values remain at the incremented values, not the original. So what happens is when we pass this slices each meal, when we pass that into the print array, it's decaying from an array to a pointer. And that's what happens when you pass arrays. And when that happens, you also lose some functionality of figuring out the size of the array. There are some tricks you can do to figure out the size of the array, but you would only be able to do it like here, or in this main function. Once you're in this print array, you're not able to do that because a pointer doesn't contain a size, so therefore we need to include this size. if we tried to figure out the size using some of the other techniques that are out there that would work in this main function, you're going to calculate the size of the pointer, which is definitely different than the size of the data the pointer points to. So this is some confusing stuff, and I'm not going to pretend to be an expert, but what I can say is that it is possible to make functional code and understand what's going on. It just takes a lot of practice. So go through, make some functions, and try changing values inside and seeing if they are changed outside and understanding when that's the case and when that's not a case. The two main cases are if you're passing an array or a pointer, you can change the data on the inside. If you're passing something like an int or a character, you can't. So that's all I got for you guys. Thank you for watching and really appreciate all the support you guys give me. Please be sure to subscribe and also check out the C programming crash course in the description below. Thanks, guys.
Welcome back, everybody. This video we're going to be talking about structs. And let me tell you, structs are one of my favorite things in C programming. They're really super cool. They basically allow us to encapsulate numerous pieces of data or values inside of one variable. So to go through an example, let's say we wanted to create a rectangle or something. Well, we might have a length and we might have a width. And that's not too crazy, but if you had numerous rectangles, you'd have to have two variables for every single rectangle. And that's just a very simple thing we're trying to create. What if we had a more complex structure and as a result, we just had numerous variables we had to keep track of? Well, with a struct, we could basically combine these into one data type called rectangle, for example. So to do that, what we need to do is outside of main, we can say struct rectangle, give it a name, and then inside of these curly braces, put these two variables. So that is the simplest way to make a struct. So now, when we create a variable, instead of saying int length or int width, what we do is we say the type is actually rectangle, and then we give it a name, my rectangle, whatever you want to call it. And before the rectangle type, we actually have to say struct. So this is how we declare a struct. And we can give it values by setting it equal to, and then using curly braces and putting two values in here. So we could say 5 and 10. So it's basically a way to group a length and a width together inside of one variable, my rectangle. Okay, so how do we actually go and access the values? Well, if we wanted to say print these, for example, well, we could say the length is equal to, and the width is %d, and the value we're going to pass in is my rectangle dot length. And that's for the first one, and then we're going to pass in my rectangle dot width. So this dot operator allows us to access the members of this variable, my rectangle, which correlate to the length and the width. Now the only thing that's different about creating one of these things is this struct keyword. Now there's actually a way to get around this, and to do that, it's a little funky, but you have to put type def, and then down here you say rectangle. So that is how you would get rid of this requirement to put this struct here. It basically allows us to use this rectangle as any other data type. And then this variable here, this value here, is actually optional. You could get rid of that if you wanted to, like that. So we just created a struct of type rectangle. And here's how we instantiate it. We set it equal to curly braces and we put all those values in there. So this is a good start, but we can actually make more complicated things. So for example, let's say we created another struct for a position. So we would say type def struct position, and this would have an int x and an int y. Now together, these things are kind of useless by themselves. So a position is just a location and a rectangle is just a rectangle. But if you combined them, maybe it could be something like the building plans for a house. So this is the size of the house and this is the location of the house, for example. So what you could actually do is you can make a struct of these other structs. So we could say type def struct building plan. And inside of here, we could have the first one be the rectangle. And we'll call this And you can actually name this the same thing as the type. So we could say rectangle, rectangle, and then position, position, just like that. We could also store other things in here. For example, we could have an owner. So this could be a string, like so. And that's where we could store the name of the owner. If we wanted to create a building plan down here, it would look like this. We would give it the type building plan, give it a name, and then inside of these curly braces, we could just assign a value for each one of the things. Caleb Curry for the owner, and then for the rectangle, we're actually going to use another set of curly braces, and we could say this is at a 10 by 5 house, or let's go 5 by 10 just to be consistent with this here. And this is at position 3248, which I know means absolutely nothing here, but just follow along. Pretend these are some kind of coordinates of some sort. And we can actually print out this entire house, and we only have to use this my house variable rather than keeping variables for all of this information. So I'm going to write out a printf statement. It's going to be a little bit more complex than usual, so I'm just going to skip to when it's done. All right, so here's the format string. The house at position, position, size is owned by name. Then we just have to make a list of all the arguments also passed in for these formats. All right, so this is the entire printf statement. You can see we can traverse through these structs using the dot operator. So we can say dot position, and then inside of that, dot x. All right, so let's compile and see what happens when we print this. All right, I have an issue. All right, I have a spelling mistake in position, so I'm gonna scroll up and fix that. I also forgot to put the type here because I'm a failure, apparently. Let's run the thing. The house at 3248. Size 510 is owned by Caleb Curry. Awesome. So that shows how to use structs in your program. The next thing I wanted to show is that you can actually make an array of structs. So for example, if we wanted to make an array to store a bunch of positions, for example, it could be a path. We could say path and set that equal to numerous positions. So inside here, each one's going to be inside of curly braces. And we could say where you need to go for this path. So what each point is. We could then iterate through this entire array with a for loop. Typically, if I'm going to use a number here, I like to assign it to a variable. And then we can basically print these values like so. All right, let's see if that works. Obviously, you don't want to return beforehand. You want to do that after. I always forget to do that for some reason. All right, so there it'll print out the path. Awesome. Another thing I wanted to talk about is how to make a pointer to a struct. It's fairly simple. So if we have a struct, so scroll up, we have this my house. This is a struct. Well, we can make a pointer to that, just like we would make any other pointer. We use the asterisk symbol and then give it a name, just like so. And then we can set that equal to the address of my house. Okay, so when you want to access the values at this pointer, it's a little bit different. So typically you use this dot operator, such as right here, but now you're going to use an arrow. So you could say struct pointer arrow, and then you would be able to go through here and say position or rectangle or owner. So let's just say position.x, and let's print this. And you can see there, it prints 32, which if we scroll up, we can see that we did define it as 32.
Hey, welcome back everybody. Congratulations for finishing this series. Or if you didn't finish the series and you're just watching the final video for some reason, I wanted to mention that there is a crash course version of this. Link in the description. It's going to give you everything you need to know, hands-on, to the point. Definitely good if you want to prep for a job interview or just review the content of this course without having to watch the entire thing. So I wanted to emphasize that we covered a lot of material. We covered literally the bare foundation of programming, functions, input and output, control flow, tons of other things. We talked about creating our own functions. We even talked about pointers, which is more on the advanced side of C. But this is by no means even scratches the surface of everything you can do in programming and with C.
That's all I got for you guys. If you've enjoyed this video, I want to do more content. I just need to know what you guys like, what you don't like, what's helpful, what's distracting. Am I not serious enough? Am I too serious? I'm flexible. I'm willing to work with what you guys think is best. So please be sure to leave a comment below saying your favorite part of the series and what made this series something you were willing to watch. So please do that for me. It's the one thing I ask. Oh, and subscribe. But other than that, I really just want to know feedback and what you want to see more of. So thank you guys, and if there was anything I covered in this series that was confusing, please tell me now so I can consider that for future videos, maybe trying to approach it from a different point of view. Thank you, and as always, I'll see you guys in the next video. And congrats on getting through the series. Peace out.